So now it's time to start a discussion about collections. But first I'm going to create a new project. I'm going to call it collections. For the language, select Kotlin. For the build system, IntelliJ. Make sure to have the JDK selected and also check this box to have the main function auto-generated for us. So I'm going to click on create to create the project. Now I'm going to delete this code because we don't need this code. And also I'm going to hide the project pane. Now, what are collections? Collections are a group of objects stored together in a single variable. They are similar to array, but they are different in some sense. And there are mainly three collections that we're gonna look at, and those are the list, the set, and the map. And those among those collections, they are separated in two groups. So there are mutable list and sets and maps, and immutable list sets and map. And mutable means that you can write to that collection, so you can add or remove elements to it. So that collection can grow or shrink as you add or remove elements to it. And immutable means that you can only add elements only when you instantiate that or when you create that collection. You cannot add later elements to it. The size is fixed, so you cannot add or remove element. So this is the difference between immutable and mutable. And we're gonna look at all of those in this video. So we're gonna look at the list collection first, and we're gonna look at an immutable list. So we type val. I'm gonna create a variable names, and here we're gonna type, to create an immutable list, type list of. And here we need to specify the type, what kind of data I'm gonna put here. And we'll type name1, name2, and name3. Now, we cannot add or remove element from this list because it's an immutable list, but we can get an element to output in the console, and to do that, we type print line. We type names, we put square brackets, and we get the element by its index, and the index also starts at 0. So let's get the first element. So if you run this code, you'll see name1 outputted in the console. So you get name1. So this is an immutable list. We cannot add or remove elements from it after we instantiate it here. Now let's look at an mutable list, so a list which you can add and remove elements to it. So to do that, we just change this from a list of to a mutable list of. So we type here mutable list of. We can also remove the explicit type here, the explicit type declaration, because it's gray out. So remove that because it can be inferred. And to this mutable list, now we can add or remove the element. So I can type here names, and we have this add function. So we can type add, and here we can pass a new element. So we pass here, let's say, name 4. Now if I let's type here names dot for each, print line, not this for each, names dot for each, this for each, print line. Now if you run this, now you see you have name1, name2, name3, and name4. So name4 was added to our mutable list because our list is mutable. We can add or remove new elements. So down here I can type names dot remove, and we can remove an element, and we can remove the element I think by you can use this function remove at, so we can remove the element by its index. So we can type here the index, and that is gonna remove the first element. So if you run this code, name1 is not gonna be showed. So as you can see, name1 was removed because we remove it by its index. And we can also remove an element using this function by typing the element. So we type here, let's say name2 element now is going to be removed. So Now if you run this, name2 was removed. So those are two functions with which you can remove elements from the mutable list. So this is a mutable list. You can add and remove elements to it, and the list is gonna grow and shrink as you add or remove elements to it. So this is the mutable list. Now we're gonna look at a set, and a set is a collection which can store only unique elements, so you cannot have duplicates. So if I delete this in our mutable list, we can put an element which is the same. So we can have two elements which are the same. So if you run this, we have two elements which are the same. You're gonna see name1 at the end. We have name1, name2, name3, and name1 again. So we can have duplicates in our collection on our mutable list, but in a set you can't. So, but first we're gonna look at a immutable set, and then at a mutable set. So we type here. Let's delete this. We type here set of, and here we need to pass string. Now if you run this, you will see that name1 is not shown two times here. It's going to be shown only one time. So you have name1, name2, and name3. This is because the set is not allowing duplicates in its list. So, and this is an immutable set of. So if I type here names.add, we cannot add or remove new elements, but we can also use a mutable set of. So we type here mutable set of, and now we can add and remove new elements to it. So you can type names.add. So here you can add a new element. Let's say name. So now if you run this, you're gonna see name1, name2, name3, and name4. And our duplicate is not shown because, as I said, a set can only store unique elements, not duplicates. But if I add objects that we create, look what happens. So let's create some user objects, but first let's create the class user, and it's gonna have a val name is gonna be of type string. Now let's create some user objects here, and we're gonna add to our mutable set. So we type here val user1. I'm gonna type here user, and we're gonna pass some generic names like name1, and let's control D a few times. Let's change this to name2 into 5, and let's add here a val user 6 equals user, and let's type here Alex. Let's press Ctrl D, and let's change this to user 7. Now let's add those to our mutable set. So let's change now the type. So it's gonna store user objects. So we're gonna pass here user1. I'm gonna speed up now this a little bit. I'm gonna press Ctrl Alt L to format the code. Now we can add this. We cannot add here name4 because now the type is user. Now if you run this, let's actually change this print to it.name, and let's run our code now. And we have name1, name2, name3, name4, name5, and we have Alex 2 times. So why you have duplicates, even though I said that sets can only store unique elements? This is because previously the set, actually what it's doing to determine if it has duplicates, is using the equals to function that we talked about in our video about data classes. So when we typed only strings, then it was using the equals to function which was overridden inside the string class to determine if there are equal strings. But now, because our class doesn't have the equals to function overridden in its class, it's not it's using the equals to function which is inside the any class, so it cannot determine if two users are equal. And to change that, just let's hide the console and to just put the data keyword here, because now this will generate the equals to function, the two string and the hash code. So now if you run this, now we have Alex only one time, because now it's using the equals to function which was auto-generated by the class user, because you put here the data keyword. So this is a good thing to have in mind, that this mutable set is using the equals to function to determine if the objects that you add to yourself are equal. So having this in mind, now let's look at maps. So I'm going to close this. I'm going to delete this. Let's delete this. Let's delete this also. Now let's look at the next collection that you can use in Kotlin, and that is the map collection. And use collection when you want to store key value pairs. So I'm going to create a variable. It's going to be called users, and I'm going to put equals, and I'm going to create first an immutable map. So we type map of, and here we need to specify what kind of type is going to be the key. So the key is going to be an integer, but you can put any class you want here, and the value is going to be a string. So I'm going to store the ID and the name of a user. And to define our element in pairs, here we type first the key, and then we use the to keyword to map our key to its element, so to its value actually. So we type 1, 2, and now the value. Let's first type Maria. So now we have one element stored in paired, and the key is 1, the value is Maria. Next, I'm gonna do the same for the next one. So I'm gonna type here 2, the keyword 2, Alex, and then I'm gonna type 3, the keyword 2. So we need to type the value now. I'm gonna type John. Now, to get one element from this map, we type print line. We type here users, square brackets, and we get the element by its key, as you can see by this hint key. So we get, let's say, the element 1. So now if you run this code, we get Maria, because Maria has because this key is for the key 1, the value mapped, the value which is corresponding to this key is Maria. And if you change this to 2, gonna get Alex. If you run this, so this is an immutable map. In this map you cannot add or remove elements, but if I declare this as an mutable map, so let's change this to a mutable map. So we type here mutable map of. Let's delete this from here, and let's pass here int and string. Now here so you need to put this in parentheses. Here we can add new elements, so you can type users. Actually, first let's loop through our map to see our elements, and I'm gonna use the for each function to loop. So we type here users dot for each, and we choose this one. And inside our loop we add a print line, and I'm gonna put quotation marks, and here we're gonna put $. I'm gonna type t, and t is the key, and $u, and u is the value. So now if you run this, we get 1 and Maria, 2 and Alex, 3 and John. So we have the key and we have the corresponding values. And you cannot have duplicated keys, and this is very important to know. You can also add or remove elements from this map. So to add an element, you just type users, and we need to specify the key. So we put square brackets, so we type user square brackets, and then we put a key, let's say 5. And we put here equals to, and here we need to pass a value. So the value is going to be, let's say, Vlad. Now if you run this, we get 1 and Maria, 2 and Alex, 3 and John, and 5 and the corresponding value Vlad. So Vlad has the key value 5. So you can also remove an element from our map. So we type users dot remove, and you here for this remove function you pass the key of the element that you want to be removed. And let's say that I remove 2, so I remove Alex from our map. So if you run this code, now Alex is not going to be shown here because it was removed on the line 4. So Alex was removed. So this is how you can use immutable and mutable maps. This is how you can add and remove elements, and this is how you can loop through our map. And this is our discussion about collections, and see you in the next video. Now it's time to start a discussion about collections operations, and we're going to look at the first operation, and that is transformations. And we're going to start with the first one called mapping. So I'm going to create a new project. I'm going to call it collections operations. Select Kotlin, IntelliJ, then click on create. We'll go on the left hand side, click on Kotlin, right click, new. I'm going to create a new file. I'm going to call it main. I'm going to create the main function. Now, what are transformations? As the name implies, transformations are some functions with which you can change a specific collection. And we're going to look at the first one, which is called mapping. So I'm going to create first a collection. So I'm going to type val numbers, and it's going to be a set. So I'm going to type numbers equals to set of. And here we're going to define some values like 1, 2, 3, 4, 5. Let's press Ctrl Alt L to format the code. Now I'm going to add a print line here. Now to use the mapping collection transformation, we just type numbers. And one important thing to know here is that those transformation functions are lambda functions. So if you don't know what lambda functions are, I suggest you to watch the section which is called lambda function to first understand what are lambda functions, because it will be very hard for you to understand how those transformations work without understanding how lambda functions work. Now here we're gonna call our transformation function, which is the first one, which as I said is mapping, and the function is called map. I'm going to explain immediately what it's doing, and as you can see it's a lambda function. So I'm going to press enter, and we are inside the curly braces, and here we're going to define our transformation. So what we're saying basically here is do whatever I type here in this in those curly braces, apply to every element of this collection. So if now to refer to the parameter to a specific parameter from the numbers set, we type it, and I'm gonna type it times 10. So what we are saying here is do this transformation. So change this this set by multiplying every element inside this collection, inside this set, by 10. So if you run this, now every number is going to be multiplied by 10. So if I run this, now we get, instead of 1, 2, 3, 4, and 5, we get 10, 20, 30, 40, and 5. So what this map function and what this it times 10 did is it transformed, it changed our set into what it was changed by the expression that we defined here. So we said that I want every element we said here to be multiplied by 10, and then we display them here. We can go even further. We can put here an if statement. So we can type here if, let's say it, so it refers to a specific element in that list, in that set. So if it equals, so if equals 3, we're gonna say here it times 100. So what we're saying here, if one of those elements inside this numbers set is equal to 3, then multiply it, change it, so change it by this expression, so multiply it by 100. And you can also put the else part. So we put else, we're gonna put it times. So if the else part is true, if the else part is executed, we're saying if the number is not equal to 3 from this list, then multiply the number by 10. So now if I run this, look what we have here. So we have 10, 20, and we have 300 here. This is because this transformation now is using the if and else statements that we define here. So this is what the map transformations allows you to do. You can change, you can transform a specific collection by an expression that we defined inside the curly braces of the map function. All right. Now let's look at how we can use the map transformation with another collection. Let's see how can you use the map transformation with a map. So with a map which has a key and a value. So to do that, we just type here val numbers map. So I'm gonna type val numbers map. I'm gonna put equals. I'm gonna type map of, and here I'm gonna type key 1, 2, 1. Then key 2, 2, 2. Then key 3, 2, 3. And finally key 4, 2, 4. Now if you wanna use the map transformation function on the map collection, you can use it either on the keys, so you can use it on the keys, or on the values. So we can type here print line number map, so we choose here dot, and we choose map keys now. So we choose this one, map keys lambda expression, so map keys, that one. And here we type it dot key, so we get the key dot uppercase, so that is gonna uppercase all the keys inside our map. Then we're gonna add another print line here. We're gonna type number map dot map, now we choose map values, and we type here it dot value, so the value plus it dot key dot length. Now, if you run this, though this expression is going to be applied to all of our keys inside our numbers map that we defined above, and the second transformation is going to be applied to all the values that we defined inside our numbers map. So if you run this code, now we're going to see the keys being first uppercase, and then we're going to see the keys plus the length. So you see, first we get 10, 20, 300, 40, and 50 for our first transformation that we have here. Then we have our second. Then we have our transformation on the map keys. So we have the key, and then we have the value. We have key, and the key is uppercase because we said to do that by using this expression. So it uppercase all the keys, as you can see here, and then you see the corresponding value for the key. After that, you see you have numbers map.value, so you have it.value plus it.key.length. So you have key, and you have 1, and we have 6. You have key 2, and you have 7. So the key, the value of the key is to the value of the key is added the length of the, so to the value that we have here, we have added the value length of the string key that we defined here. So this way we have 2, then we have 7, then we have 8, and then we have 9. So this is how, and you can also do for the map transformation, and to type here numbers dot map, and we choose this one, index not null. And here we choose, we have 2 parameters. First is the index, and second is the value. So I'm gonna choose the name for the first one, index, and for the second one, let's call it value. Then we have the arrow, and here we're gonna define our transformation, our expression, which is gonna be applied on our numbers. So here I can use the index. So I'm gonna type here an if statement. So if index equals 0, then I'm gonna assign. So I'm gonna transform we're gonna put that value null to the index 0. Else I'm gonna type index times value. So else you're gonna multiply the index times the value. So if you run this, we get 2, 6, 12, and 20. So for the first one we get nothing because for the first index we assign null, and then it's using the else part to transform our numbers list, and it's multiplying the index by the value. So we first have this indexed 0 multiplied here we have null for the, because we checked here, so we have null. So at the index 2 we have 1 times 2, and we have 2. Then here we have at the index 2 we have 2 times 3, so the index is 2, the value is 3, and we get 6 here, and so on. So this is how you can use also the index if you want in your transformation. Now we're going to look at the next transformation that we can do in our collection, and that is zipping. Now it's time to look at the transformation function called zipping. So I'm going to add a comment here called zipping, and I'm going to declare 2 lists. I'm going to call the first one colors. I'm going to put equals. I'm going to type list of. I'm going to type red, brown, and gray. And I'm going to create another list called animals. Equal list of. I'm going to type here fox, bear, in quotation marks, and wolf. Now, what the zipping or the zip functions allow us to do is to create pairs of elements with the same position in both collections. So we can create pairs with red. We can create a pair of fox and red, a pair of bear and brown, and a pair of wolf and gray. And you can do that just by typing here print line. And you can do this in two ways. You type colors, and you can type dot zip, and you type here animals. And if you run this, you will see them in pairs. So you're gonna see fox red, bear brown, and so on. So you see here red, fox, brown, bear, gray. Also the zipping is used to create pairs, and the pairs are at the same position in both collections. Or if you don't want to use this zip function with parentheses, you can type here colors, zip, and animals. And you type here animals. Now if you run this code, you're gonna see the same output. Now, if you want to use a transformation with the zip function, you can type here print line, and you can type colors dot zip. Now I'm going to use the parentheses animals, and now I'm going to put curly braces, so the lambda function here. I'm going to type animal, or let's put first color and animal. I'm gonna put the arrow sign, and here I'm gonna type de. But I'm gonna put first quotation marks. I'm gonna put de, and I'm gonna put $sign, and I'm gonna refer our animal parameter that we defined here. So we type here de animal dot, and we call the replace first char function. So type replace first char, and as you can see, this also is I think a lambda function, and inside of this we type it dot uppercase, and this is gonna uppercase the first letter of the animal that is defined here, and I'm gonna type is $sign color. Right, now if you run this, you're gonna see the fox, and the F is uppercase because it's uppercase by this expression that we have here. It replaces, and this it refers to the animal variable that is defined here, and it refers to the first letter. So it says it that uppercase, so uppercase the first letter, then return that to the animal variable. And we have the fox is red, so we have the color, and then we have the bear is brown, the wolf is gray, and all the animals start with a capital letter like we define here in this expression. So this is the zip function. So this is how you can use the zip function to create pairs, and also you can use the unzip function to unzip a list of pairs. So first let's create a list of pairs. So I'm gonna type val number pairs equals, I'm gonna type list of, and here we're gonna put 1, 2, 1, 2, 2, 2, 3, 2, 3, 4, 2, 4. Now if you want to unzip those pairs that we created, you can just type here print line number pairs. Let's first display them as pairs, and next let's print line, and let's type number pairs dot unzip. Now if you run this, you're gonna see them first in pairs, and then you're gonna see them unpaired, because we use here the unzip function. So as you can see here, you have first 1, and you have 1, 2, 2, 3, 3, 4, 4. So you have in pairs first. And then we have them separated. So we have first 1, 2, 3, 4, and then we have the numbers 1, 2, 3, 4. So we unzip them, we separated them. They're not pairs now anymore with this unzip function. So this is how you can use the unzip function. Now it's time to look at the next transformation that we can use, and that is association. Now, what is association? Association transformations allows you to build maps from the collection elements and certain values associated with them. In different association types, the elements can be either keys or values in the association map. We're going to see what this means. And the basic association function is the associate with, which creates a map in which the elements of the original collection are keys, and the values are produced from them by the given transformation function. So let's see an example with this. So I'm going to delete this code because it will make the output hard to understand, because they have so many things here. And I'm going to type val numbers, I'm going to put equals, I'm going to type list of, I'm going to type here 1, 2, 3, and 4. Now I'm going to type here print line numbers, and we are going to use the associate with the function. So we type associate with, and this is going to produce, as I said previously, it's going to produce a map in which the elements of the original collection are keys. So the keys of this map are going to be those elements, and the values are going to be produced by what expression we define here inside the parentheses. So I'm going to define here it. So I'm going to type it dot length. So now if you run this, you're going to see the keys being 1, and then you're going to see the value being the length of that specific element. So if you run this, we get the key 1, the value 3, the key 2, the value 3, then you get 3, the value is 5, then you get 4, and the value is 4. So what has happened now is that the associate with function created a map in which the elements, the key are the elements of the collections. So those are the keys inside our map, and the values of those associated with those keys are produced by the expression that we define here, by it.length. So basically gonna use the length of that specific element, and it's gonna be the value. So this is why I have 1, 3, 2, 3, 3, 5, and so on. Now, for building maps with collection elements as values, there is a function called associate by. It takes a function that returns a key based on an element's value. And if two elements keys are equal, only that last one remains in the map. So let's look at this one. So I'm going to type here print line, and I'm going to put here numbers. So we type numbers dot associate by. And now here we're going to define the expression which is going to build the key, because now the associate by function is going to build a collection which the elements now are not keys like we had previously, but they are values. So here in the expression we need now to define how the key for those respective values that we have here is going to be created. So we type here it dot first dot uppercase. So this is what this is gonna do. is gonna create a key. It's gonna use let's say that we have element 1, and it's gonna take element 1. It's gonna take the first letter of the element 1 and it's gonna uppercase it, and we're gonna have O, and as the key we're gonna have O, and as the value we're gonna have 1, and for the next ones it will be the same. So now if I run this code, as you can see, now the values are now the collection elements are the values here. So they are the values. Previously the collection elements were the keys, and the keys were built by the expression that we defined here by this. So we have O, and we have T, and we have 4, and we have T only one time, and no, we don't have 2 and 3 because you cannot have duplicated keys in a map. So this is why we have only one T here. So this is association. Now associate by can also be called with a value transformation function, and to do that we just type here print line numbers dot associate by. Now we need to apply a transformation now on the key and on the value. And how gonna do that? We can type here, actually let's delete this because we don't need curly braces. We put parentheses and we type here key, and we have a suggestion, key selector. So we're gonna apply the first transformation on the key. So we type key selector dot name the argument, and we put curly braces, and here we type it, so the key dot first dot uppercase. So now what we're saying here, apply this transformation for every key in the map that is gonna be built. So apply this transformation for every key that is in the map that is gonna be built. So we're saying to uppercase, to take the first letter and uppercase it. Then we also need to apply a transformation for the value. We put comma here at the end of our curly brace, and we type here value. You also have a name argument. We put again curly braces, and here we're gonna type it that length. So this is the transformation that is gonna be applied to all the values in the map that is gonna be built. So this is the transformation. So this is how all the keys in the map that is gonna be built are gonna be changed. So the first letter is gonna take, this thing is gonna take the first letter of the keys and it's gonna uppercase it. This will take the length of all the values in the map that is gonna be built, and it's gonna display the length of that element. So if you run this, we get 0, 3, T, 5, F, 4. So we have the first letter uppercased, and then we have the length 3, then we have T, we have the letter uppercase, and we have the value 5, the length of that element. Then we have F, so we have a 4, and we have the transformation apply on that element, on this element, on 4, and we have the length, and we have 4. So this is how we can use transformations with the associate by function. And next we're gonna look at the next transformation function, and that is flatten. Now it's time to look at the next transformation function that we can use, and that is the flatten function. But first, let's see why you'll need to use this flatten function in the first place. So I'm gonna add a comment here called flatten, and I'm gonna create a variable here. So I'm gonna type val, it's gonna be called numbers sets, and this is gonna be a list with list. So I'm gonna type here list of, and inside the list I'm gonna type set of. So we have a list inside of a list, and I'm gonna provide some values to our set of, like 1, 2, 3, then another set of 4, 5, and 6, then another set of 7, 8, and 9. So what we are having now is we have a list within a list where the index of this list is its own list. So we have a list of sets of ints. Now, if you want to loop through this list, if you want to display the elements in this list, it is not that easy, because you will first need to loop, because let's say that because what we have here is what is called a multi-dimensional array. So more specifically, what we have here is a two-dimensional array, and at the index 0 we have a list, at the index 1 we have another list, and at the index 2 we have another list. And to navigate to this list, we need to first get inside that list that is at that specific index, to loop to that list, and then we need to move to the next index and to loop through that list to that next list, which is at that index. But now let's see first how we can access one individual element from our two-dimensional array, so from our array of arrays. And to do that, to type here print line, I'm gonna put numbers set, and if we put square brackets, and we define the index from which list we want to access the element. And now I want to access the element 9, and the element 9 is stored at the index 2. So we put 2, and let's say that I want I want to access, as I said, the element 9. Now to access the element 9, I need to go within this list and use the index to get the element 9, and the element 9 is stored at the index 2. So I'm gonna put square brackets 2. But this, for whatever reason, doesn't work with a list of sets, and we need to change this to array of. Also change it to array of, also array of, and now everything will work fine. So array of. So if you run this, so now we are accessing the index 2, where the array is stored, where our number is stored, and we get the element 2, we get the element 9. So now if I run this, you're gonna see 9 outputted in the console. So we get 9. So this is how we can access one individual element from our multi-dimensional array. So I'm gonna delete this, I'm gonna change it back to a list of and to set of. So let's type list of, set of, set of, and set of. And now let's see how we can loop through this two-dimensional array. And to do that, we type here for, and we type numbers. I type specific numbers because this is gonna, as you can see, gonna hold the numbers, the set of numbers, for numbers in number sets. So now we are getting the, as you can see here, this is of type is the type set of ints. So this basically gets the element at the number set index, let's say 0, and it gets the first set. And now we need to loop through that set. So another for number in numbers. So now we are looping through the list, through the set which is inside the list at the index 0, and I'm gonna add the print line to output that number. I'm gonna type here number, and also I'm gonna add a space here. So I'm gonna add the print line here, and I'm gonna type here /n. Now if you run this, as you can see, you have on the output 1, 2, 3, then we have a space 4, 5, and 6, then 7, 8, and 9. But we achieve this by using a loop, and then we use another loop. So we have a loop inside the loop. We have a nested loop in order to get to this two-dimensional array, because as I said, the index of this array is its own list, so it contains a list. Now with the flatten function, what we can do is that we can convert this two-dimensional array in one-dimensional array. So we don't need to use these nested for loops in order to loop through to them. It will return the nested it will provide access to the nested collection elements without you needing to loop through this two-dimensional array. It will basically take that two-dimensional array and it will convert it in one-dimensional array, and you will not need to create to have this nested loop inside. You have to have this loop inside the loop in order to display the numbers. So to do that, we type here val numbers, let's say flatten, equals to number sets, so our list with list, dot flatten. Now if you look at the type here, now this is a list of ints. You no longer have a list of sets of ints. So this is very informative, because it tells us that this now is just simply a list of ints. It's not a list with a set which itself is also a list of ints. So this converts that two-dimensional array in one-dimensional array. And because of that, now it's much easier to get one element from our list, because now our list is not a two-dimensional array, it's just one-dimensional array. So if I type here print line, and let's say that I want to get the element 9, I'm going to type here numbers flatten, square brackets, and I'm going to type here 8, because it's stored at the index 8. So now if I run this, so we get 9 here. And as you can see, this is much easier than with the two-dimensional array. So this is what the flatten function is doing, is converting the two-dimensional array, or if you have a multi-dimensional array, into one-dimensional array. So now let's look how we can loop through our one-dimensional array. So let's delete this. And if you want to loop through this, you just type for number in numbers flatten, and we add here a print line number. And let's comment this code. And if you run this code, now we get the number displayed one after another, so we get 1, 2, 3, 4, 5, 6, 7, and 9. And we got this because our function, our flatten function, our transformation flatten function is transforming, is converting our two-dimensional array in one-dimensional array, so it's easier for us to get the elements and to loop through them. So this is what the flatten function is doing. And next we're gonna look at the string representation and the functions that we can use for the string representation. So I'm going to close the console. Now it's time to start a discussion about string representation. So if you need to retrieve the collection content in a readable format, you can use functions that transform the collections to strings. And there are two functions to do that, the join to string and the join to. The join to string builds a single string from the collection elements based on the provided arguments. The join to does the same but appends the result to the given appendable object. And what that means is that it's going to add the text to the object on which that function, the join to function, is called. You're going to see an example with this immediately. And now I'm going to create a variable called numbers, val numbers. I'm going to put equals. I'm going to call it actually numbers strings equal, and I'm going to type here list of and I'm gonna put here the text 1, 2, 3, and 4. Now, if you want to retrieve if you want to get the string representation of this list, if you just type here print line, and we put here numbers strings, and if you run this, we get 1, 2, 3, and 4. But this I think is calling the toString function. It's not because we're not using the join toString function, and I don't like those square brackets. I want them to be separated by comma with spaces. To get that, just type here print line. So let's put here print line, and to type numbers toString dot join toString, and we delete this and we put parentheses. Now if you run this, you'll see now the string representation of our list. They are going to be separated by comma, when it's going to have spaces. Now let's look at the join to function, and for that I'm gonna define another list down here. So I'm gonna type here, let's press Ctrl Alt L to format the code. So I'm gonna type here val is gonna be called list string, and now I'm gonna use something called a string buffer, and this is like the string type is a little bit different, but it's gonna allow us to do it's gonna allow us to present how the join to function works. So string buffer, and we put parentheses, and here we define our text, and we're gonna type the list of numbers, and I'm gonna put colon. So we type here the list of numbers colon. Now to use the join to function, we just type here another print line. We type number strings dot join to, and as you can see, this receives a buffer, and this is the buffer that we created here. So I'm gonna press enter, and we're gonna give us the argument, the list string that we created. And what is this? This is gonna do is gonna append this text that we have here in front of all of our elements that we have in our list, number strings. So now if you run this code, as you can see, it added the text, the list of numbers that we have here, to our number strings in front. So we have the list of numbers 1, 2, 3, and 4. Now, if you want to build a custom string representation, you can specify its parameters in a function arguments, which are the separator, prefix, and postfix, and the result will start with the prefix and end with the postfix, and the separator will come after each element except the last. So let's see how we can do that. So I'm gonna use the numbers to string. So I'm gonna type here print line numbers to string, and we type join to string, and we select this one with the with the separator parameter, and we type here separator. So now we define what is gonna be the separator here, and we're gonna put quotation marks, and we're gonna put this. So this is gonna be our separator between our elements. Next, we're gonna define the prefix. So we put here comma, we type prefix, and now I'm gonna put the prefix, and the prefix is gonna be the text start and colon. So we put quotation marks, start, and colon, and we also need to provide the postfix, and to do that we put another comma here. So those are named arguments, which are defined in this function join to string. So we type here postfix, and we put colon end. Now, if you run this, you're gonna see them separated by this separator that we define here. It's gonna have the prefix start, and it's gonna have at the end this postfix, which is comma and end. So now if you run this code, as you can see, we have start and we have 1, then it's separated by the sign that we define here. Then we have 2, 3, 4, and we have the end. So we have our postfix that we have defined here. Now, for bigger collection, you may want to specify a limit, so a number of elements that will be included into the result. And if the collection exceeds that size, that limit, all the other elements will be replaced with a single value called the truncated argument. So let's see what all of this means. So let's say that I have a list called numbers. Let's type here val numbers, and I'm gonna create a range from 1 to 100. So what we have here is 100 numbers. And let's say that I type here print line. But first, let's convert this to a list. So I'm gonna put this in parentheses. So you put this in parentheses, and you put at the end dot to list. And this is gonna convert now our range into a list. And now as you can see, the type is a list of ints. And now if I type here numbers, and if I run this code, I'm gonna get all of our numbers displayed. Now, with as I said, with the join to string function, we can specify a limit and also a truncated, which is gonna be the thing which is gonna be showed out after our number limit. So what I can type here is I can type join to string, and we choose also one with parentheses. So here we type limit, the named argument limit, and let's say that I don't want to get all the numbers, as you can see here, from to 100, and I want to get only the first 15 elements. To do this, we just type here limit 15, then we type truncated, and that is gonna be this truncated thing is gonna be showed after our limit number. So I'm gonna put here quotation marks, less than sign, dot dot, and greater than sign. So now if you run this, look at what we have in the output. Now we only have the first 15 elements, and then for the next elements we only have this string that we typed here, this expression that we have here. And we can change this. We can change this, let's say, to 25. So if you run this now, you'll see only the first 25 elements displayed. So this is how you can use the join to string with the limit name argument and with the truncated. Now, let's say that you want to customize the representation of elements of the elements themselves. You need to, in that case, you need to provide the transform function. So what we can do is that we can type here print line, let's say, and I'm gonna type numbers strings, put dot, join to string, and we choose this one with curly braces. And here I'm gonna define how this list is gonna be transformed, so how it's gonna be changed. So I'm gonna type here quotation marks, element, and I'm gonna put colon, we're gonna put dollar sign, I'm gonna put it dot uppercase, so we're gonna uppercase all the elements. So if I run the code now, now get element and get one. So you get one uppercase, and element, you get 2 uppercase, element 3 uppercase, element 4 uppercase. So this is how you can use the transformation. This is how you can transform your list using the join to string function. So this is our discussion about the string representation, and now I'm gonna move to the next section. So I'm gonna end the video now. Now it's time to start a discussion about filtering. So what is filtering? Filtering is one of the most popular tasks in collection processing. In Kotlin, filtering conditions are defined by predicates, and that is lambda function that take a collection element and return a boolean value. True means that the given element matches the predicate. False means the opposite. The standard library contains a group of extension functions that let you filter collection in a single call. Those functions leave the original collection unchanged, so they are available for both mutable and read-only collections. To operate the filtering result, you should assign it to a variable or chain the function after filtering. Now, the basic filtering function is filter. When called with a predicate, filter returns the collection elements that match it. For both list and set, the resulting collection is a list. For map, it's a map as well. Now, let's define a variable here called numbers. So let's type here val numbers. I'm gonna put equals to list of, and I'm gonna type here 1, 2, 3, and 4. Now, if you want to filter this list, what you need to do is let's create another variable here called longer than 3. I'm gonna put equals, and I'm gonna type numbers dot, and we type filter. So filter, and we choose this one. And here we defined how our list, so we could define the expression which is gonna determine how our list is gonna be filtered. So I'm gonna type here it, so the element dot length, let's say greater than 3. Now, if I add a print line down here, print line. Now, this list is gonna contain all the elements from our numbers list which are longer than 3. So if I put here longer than 3, and if I run this, we get 3 and 4 because those are the only string numbers which have a length longer than 3. So I'm gonna close the console. Next, let's see how we can filter a map, and for that I'm gonna create another variable called numbers map. I'm gonna put equals to, it's gonna be equals to map of, and I'm gonna define here the key is gonna be a string key 1, the value is gonna be 1, comma, then key 2, 2, 2, then key 3, 2, 3, and now I'm gonna put key 101 to 101, the value. Now, if you want to filter now this map, I'm gonna create another variable called filtered map, and it's gonna be equal to our numbers map, but it's gonna be filter. So I'm gonna type dot numbers map dot filter, and now I'm gonna filter the map both by the key and by the value. So we type here it dot key dot ends with, so we want to filter it first by the key, and we want that key to end with a specific character, and that character is going to be 1. And so we put the operator and we want the value to be greater than 100, so we put here it dot value greater than 100, and the only key which satisfies this condition that we define here is this key. So now if I add a print line here, and if I type filtered map, so the map which was filtered using the expression that we define here, now if you run this, you're gonna see this in the output, because this is the only one which satisfies the condition. So we get key 101 and we get the value 101. So this is how you can filter a map using both the key and the value. Now, the predicates in filter can only check the values of the elements. If you want to use element position in the filter, use filter indexed. It takes a predicate with two arguments, the index and the value of an element. To filter correction by a negative condition, use filter not. It returns a list of the elements for which the predicate yields false. So let's see how we can do this. So I'm gonna declare two variables down here. Val filtered index is gonna be equal to numbers, or a variable that is defined above, dot filter index, and this is gonna take two parameters, index and the value. So I'm gonna type here, actually we need to put curly braces, index, let's change this to value, actually let's keep it as S, Control Z, and here we're gonna define our expression by which our list is gonna be filtered. So I'm gonna type here that first I want the index to not be equal to 0, and I also want that the value of the element. So actually let's change this to value to make more sense. So let's type here value, because we're talking about those ones. So I want the value of that string, so the value dot length, I want it to be less than 5. Alright, so this is the transformation, if you want. This is not a transformation, this is how we want to filter our numbers list that we define above. I want to filter both by the index, so this is why we use the filter index, and also by the value. And I want the index to not be equal to 0. This is the first condition for the filtering. And I also want, so we use the AND operator, that the value of the element, the length, to be less than 5. Now, if I print this, so if I added here a print line, but first let's also use the filter not. So I'm gonna type here val. So val filtered not, and I'm gonna type equals numbers dot filter not, curly braces, and we type here it dot length, so the value of the element to be less than equal to 3. Now, if we output those two in the console, so if I add here print line, and I'm gonna output filter index, this should be filter index, so let's refactor this. So let's type here index. I type it wrong. So let's type here index, actually it will make more sense, but I have index, so why? Anyway, so I'm gonna output that first, then I'm gonna add here a print line, and I'm gonna type filtered not. And filter not, as I said, is gonna return a list of the elements for which the predicate yields false. Now, if you run those two, look what you're gonna have on the output. So this is the output for our first, for this print line and for this print line. So let's think about what we have here. First we have 2 and 4, and we define the filter here. First, the index should not be equal to 0, so the 1 is first excluded, and we also want the value length to be less than 5. So the only ones which for which the value is less than 5 is the 2 and 4, because the length of the tree is bigger than 5, because it has a length of 0, 1, 2, 3, 4, and the length is 5, but I want the length to be less than 5, not less than equal than 5. So this is why this is not included, and you only have 2 and 4. Next, now use the filter not, and it's gonna, as I said, it's gonna return a list of elements for which the predicate, for which this expression is gonna yield false. So it's gonna go through all of our elements, and it's gonna return the elements for which this is false. So we get 3 and 4 because those are the only ones which are not less than equal to 3. They are greater than equal to 3. So this is why we have here 3 and 4, because this returns the elements if the length of the element is less than equal to 3. So this is why we get here 3 and 4. And there are also functions that narrow the element type by filtering elements of a given type. So there is a function called filter is instance, which returns a collection of elements of a given type being called so let's see how you can use that. But first let's create a val mixed, let's call it mixed list. I'm gonna put equals, and I'm gonna type list of, and I'm gonna define some mixed elements here. So I'm gonna type here, let's say 1, 2, 3, then some chars like A, B, C. Now some strings, let's type here hello world, another string Alex, and let's also type a boolean. So let's type here, let's say false. Now there is a function, as I said, which narrows the element type by filtering the elements of a given type. So we can use this function called filter is instance. So what we can do here is we can type mixed list dot filter is instance. So we choose I think this one, not this one. Filter is instance. So why? So mixed arrays dot filter is instance. And here we inside the angle brackets we define the generic type for which this list is gonna be filtered. So let's first choose the char. Then I'm gonna put dot for each. So I'm gonna use the for each loop, and I'm gonna add print line, and I'm gonna type it here. So I'm gonna type the parameter, which is the it char. So now if I run this, we will get only the chars being displayed here, because it is filtering by using the instance of chars. So you get the chars. If I change this to int, now I'll get the integers from our mixed list. So if I run this, now get the integers 1, 2, 3 that we have defined here. And if I change this to, let's say, string, I will get the strings inside our mixed list, because filter is instance is gonna take the specific type that we type here, and then it's gonna loop through all of the types which are of this type in this list. So if I run this, I'm gonna see hello world and Alex. So we get hello world and Alex. Also I can filter for boolean values. If I type here boolean, is gonna output in the console the one boolean value that we have here, which is false. So if I run this, I get false. So this is how you can use the filter is instant function on types to filter the mixed list. And you can also put dot, because this returns a list, this entire thing, a filter list. You can put dot for each to call this for each lambda function, and then you output them in the console. The next thing that you can look and that we're gonna look at is called partition. So I'm gonna add a comment here, but I'm gonna hide the console first. So I'm gonna put here a comment, and I'm gonna type here partition, partition. So partition, and this is another filtering function called partition, and it filters a collection by a predicate, and it keeps the elements that don't match in a separate list. So you have a pair of lists as a return value. The first list is containing the elements that match the predicate, and the second one is containing everything else from the original collection. So we're gonna take again our numbers that we have defined above. So I'm gonna type here val, and to get this partition we put parentheses, and here we type match. So this is gonna be the values which are gonna be matched by the predicate, and I'm gonna type here rest, and here gonna be stored the rest of the values which don't match the expression, the predicate that is gonna be defined. And I put here equals numbers dot partition, and we type here it dot length greater than 3. Now if I add a print line here, I can print first the match. Let's press Ctrl D, and now I can print the rest of the elements which don't match this condition, this expression that is defined here. So if I run this code, you will see first all the elements which are greater than 3, and then we're gonna see the rest of the elements which are not greater than 3. But let's add a space here to make things more clear. So I'm gonna add here a print line, quotation marks, /n. So let's run this again. So we get 3 and 4. So those are the elements which are coming from our match list, which is defined here, which satisfy this condition, which is greater than 3. So we have 3 and 4, so the length is greater than 3. And then we have 1 and 2. So those are the rest of the elements which are not satisfying this condition that is defined here. So we have 1 and 2. So this is how you can use the partition function to get basically to get a pair in which the return value, the first is the list containing the elements that match the predicate, and the second is the one containing everything else from the original collection. So this is how you can use the partition function. So now I'm gonna end the video and see you in the next video. Now it's time to look at testing predicates, and those are functions that simply test a predicate against the collection elements. And we have 3 functions: any, which returns true if at least one of the element matches the given predicate. Then we have none, which returns true if none of the elements match the given predicate. And then we have all, which returns true if all of the elements match the given predicate. So let's test all of them. So I'm gonna type here print line numbers dot, let's start with any, so we put any. So here we type it dot ends with, and let's say e. Then add another print line numbers dot none, should be curly braces, it dot ends with, let's say w, and print line numbers dot all, let's say it dot length. So if the length of all the elements is greater than 1. So now if you run this, all of those gonna return either true or false. So we get true, true, and true. This is because first we're testing any, and this returns true if at least one of the elements matches the given predicate. So it's true. We have two elements which ends with e. We have 3 and 1. So this is why it returns true there. Then we check to see if none of the elements ends with W. So we check to see if none of the elements in our numbers ends with W. And it's true. None of our elements ends with W. So we have true in the output. Then we check numbers.all. So we check to see if all the elements, the length of all the elements, the element strings that we have here, 1, 2, and 3, are greater than 1. And it's true. All of them are greater than 1. So this is why I have true, true, and true. So this is how you can use the test predicates on your collections. Now it's time to look at the plus and minus operators. So in Kotlin, plus and minus operators are defined for collections. They take a collection as the first operand, and the second operand can be either an element or another collection. The return value is a new read-only collection. And let's look at an example with this. I'm going to type here val numbers. I'm going to put equals to. So now I'm going to type here mutable list of. So mutable list, a list to which you can add and remove elements. And I'm going to type here 1, 2, 3, and 4. Now, if you want to add an element to this list, you need to type here numbers dot add, and here you need to specify, let's say 5. And now this new element is going to be added to the list. But with the plus and minus operator, we can do this in another way. So you can type here, but I'm going to put this in another list. So you can type here val plus list. So we put equals to, and we type numbers plus, and we type 5. And now this element is going to be added to our list that we have here. It's going to be added the string 5, and it's going to be stored in this plus list. Now let's look at the minus operator. So you type here val. I'm going to call this minus list, and I put equals to, and I'm going to type numbers. So now I'm going to use the minus operator. So I put minus, and we type minus mutable list of, and we put here, let's say 3 and 4. So we type here 3 and 4. I have an underline. Let's see what it says. Now, anyway, let's run our code to see what we get in the output. But we need to add some print lines to get something in the output. So I'm gonna add here a print line, plus list, and another print line, minus list. Now if I run this again, we get 1, 2, 3, 4, and our 5 element added to our numbers list from our plus list, which is outputted here. And then we get 1 and 2 because 3 and 4 were removed using the minus operator. So this is how you can use the minus and plus operators with collections. So this is our discussion about the plus and minus operators, and we're gonna move to the next section. So I'm gonna close the console, and I'm gonna end the video. Now it's time to start a discussion about grouping. So the Kotlin standard library provides extension functions for grouping collection elements. The basic function group by takes a lambda function and returns a map. In this map, each key is the lambda result, so the result of that expression inside the lambda function, and the corresponding values is the list of elements on which this result is returned. This function can be used, for example, to group a list of strings by their first letter. You can also call group by with a second lambda argument, a value transformation function. In the result map of group by with two lambdas, the keys produced by key selector function are mapped to the result of the value transformation function instead of their original elements. So let's see what all of this means by looking at an example. So if I type here val numbers, and I'm gonna put list of, again 1, 2, 3, 4, and 5. Now I can add here a print line. I can type numbers, and I can type here dot group by, and I'm gonna group it by it dot first, so the first letter in one of our elements, dot uppercase. And now I'm gonna look at the next group by with the key selector and with the transformation function. So I'm gonna type here print line numbers dot group by. So we have this one key selector. So we type here key selector equals, and here we put curly braces, and we type it dot first, so the first letter in our element, so first should be here. We put a comma, and we type value, so the value of the value of this list are gonna be transformed. And here we also put curly braces, and we put it dot uppercase, so put it curly braces, it should be it dot uppercase. Let's press Ctrl Alt L to format the code, and now let's run our code to see what we get in the output. So we get for the first one numbers that group by for and we have this lambda it dot first dot uppercase. It takes the first letter in uppercases, so you get so then you get 1, we get T, we get 2, we get F, we get 4, we get then we use this one on which we group elements with a second lambda argument with a value transformation function, and the result map of group by with two lambdas are the keys produced by the key selector, and the function are mapped to the result of the value transformation function. So the results are mapped to this transformation that is defined here. So this is what creates the keys. This is what creates the keys, this lambda function, and this is what creates the values. So we get O because we get it that first, so the first letter, and we get 1 because this is the value. So the value is uppercase. We get 1. So we get 1 here. Then we get again it that first for our element. So we get T. Then we get 2, and I get uppercase. Then we get F, lowercase f, and we get 4 and 5. So this is our discussion about grouping, and my suggestion for you is to play with the code. Try different values for the key selector, for the value transform, for try to group the elements by different expressions, and just play with the code until you get comfortable with the code. Now it's time to start a discussion about retrieving collection parts. And the Kotlin standard library contains the extension functions for retrieving parts of a collection. These functions provide a variety of ways to select elements for the result collection, listing their position explicitly, specifying the result size, and others. And I'm going to start with the first function called slice, which returns a list of collection elements with given indices. The indices may be based either as a range or as a collection of integer values. So I'm gonna create first the main function. I'm gonna type val numbers. I'm gonna create a list of, and I'm gonna type here 1, 2, 3, 4, 5, and 6. Now to use the slice function, we simply add here a print line, and we'll type here numbers dot slice, and we create here a range. So we type 1 dot dot 3, and next we're gonna add another print line, and we're gonna type numbers dot slice, and we're gonna put here now 0 dot dot 4, and we're gonna type step 2. Alright, so it should be slice, not sublist. So slice here. Slice. And I'm gonna add another print line here. Numbers dot slice. And I'm gonna add now a set here. So I'm gonna type set of. And I'm gonna type 3, 5, and 0. So let's press Ctrl Alt L to format the code. Now, if you run this code, look at the output. So you first get the first 3 elements. You get 2, 3, and 4, because we starting from the index 1, so we get 2, 3, and 4. Then we get from 0 to 4, so we get 1, but we don't get the 2 because we have this step 2, which steps the second element. And then we have 3 and 5 because it's stepping for the 4. So this is what step 2 is doing here. And next we have a number slice, and we get 4, 6, and 1. But we get them as the string representation. We don't get them as integers. So all right. Now let's look at the next functions, and those are the take and drop. And to get the specified numbers of elements starting from the first, you can use the take function. For getting the last elements, use the take last. When called with a number larger than the collection size, both functions return the whole collection. To take all the elements except a given number of first or last elements, call the drop and the drop last function respectively. So I'm gonna add some print lines here. I'm gonna add print line, and I'm gonna type numbers dot take three, another print line, numbers dot take last, also 3, then another print line, numbers dot drop 1, and another print line, numbers dot drop last 5. Now if you run this code, look what we get in the output. But let's add a space here, so I'm gonna add a print line, quotation marks, /n. Now let's run this code again. So we get numbers take 3, and this function basically takes only three elements from our list. Then numbers take last 3 is gonna take the last 3 elements from our list. So we have 4, 5, and 6. Then we have print line numbers drop 1. So we have 2, 3, 4, 5, and 6, and the first element is dropped. So this is what this function is doing. Next, we have numbers that drop last 5, and this function is basically dropping all the last 5 elements, and we have only the 1. So this is what those functions are doing. You can also use predicates to define the number of elements for taking or dropping, and there are 4 functions similar to the ones described above, and those are take while, take last while, drop while, and drop last while. And let's look at all of them. But I'm gonna put a space between our code that we have here. So I'm gonna add the print line here, quotation marks, /n, and I'm gonna add here a print line. So I'm gonna type here numbers that take while, and here we define the predicate. I'm gonna type not it that starts with f in quotation marks. Now another print line, numbers that take last while, and we define here the predicate it not equal to 3, not equal to 3. Another print line, we type numbers that drop while, and we define the expression, the predicate, which is gonna be applied for our drop last while. So it should be drop while here, and we type it dot length equals to 3, and we add another print line, numbers dot drop last while, and we type here it contains it dot contains quotation marks I. Now if you run this code, we first get 1, 2, and 3. So because here we check in, because we're using the logical not operator, we want all the elements which don't start with f. So we don't have 4 and 5, we have only 1, 2, and 3. Next we have numbers that take last while, and we define the expression for which is gonna be return the elements by it not equal to 3. So we only have 4, 5, and 6, and the 3 is missing, and we don't have 1 because take last while only takes the last elements. So this is why we have only 4, 5, and 6, and you don't have 3. So it doesn't care about the first element or about the second element. Next we have numbers drop while it.length equals to 3. And here we have so it.length equals to 3, and we have 3, 4, 5, and 6. So this condition is satisfied. So it basically drops all the elements which are equal to 3. So we have 3, 4, 5, and 6, and all of those are bigger than 3. And the ones which are equal to 3, respectively 1, 2, and let's see, and 6. Actually 6 is appearing here. So 1, 2, I don't know why 6 is appearing, but this is basically saying that it should drop while it.length equals to 3. So it basically drops all the elements which are equal to with the length 3. So we have, this is why we have here 3, 4, 5, and 6. 6 should not be, but I don't know why it's here. Now, the next that we have here is numbers drop last while. So again, this is specifically about the last element. So it contains I. So you get 1, 2, 3, and 4. So because this drop last while is basically dropping all the elements, or the last elements which contain contains I. So we have 6, 5. So we have drop last while. So we have it that contains I. So it drops all the element which contains I. So sorry for what I said previously. So this is why I have here 1, 2, 3, and 4, and the 5 and the 6 are missing, because it basically drops all the elements which contains the letter I. So this is how you can use the take and drop. The next function that you can use is called chunked. And if you want to break a collection into parts of a given size, then you can use the chunked function. Chunks take a single argument, the size of the chunk, and returns a list of the given size. The first chunk starts from the first element and contains the size of the elements, and the second chunk holds the next size elements, and so on. The last chunk may have a similar size. So if I have here, let's change this to numbers strings, and let's type here val numbers. While I was changing that, I should use refactor. So let's use refactor, rename numbers strings, so it will be changed in all the places where we're using that. And here have numbers, and I'm gonna put equals, and I'm gonna put parentheses 0 dot dot 13, and I'm gonna put dot to list to convert this to a list. And we add a print line to see how this chunk function is working. So we add a print line. Let's close the console, and we type here numbers dot chunked, and would put 3. So it's gonna chunk our elements into 3, into basically elements of 3. So we have 0, 1, 2, 3, 4, 5, 6, 7, 8, and they are both on chunks of 3 elements. So this is what this chunks is doing. So this is why I have here this result. And the next function that we're gonna look at is called windowed, and we can also use a transformation on our chunked element. So I can add here a print line. We type numbers dot chunked, chunked, which we also choose the size 3. Then you put curly braces, and here we're gonna define how our chunked elements are gonna be transformed. So we put it dot sum. So it's gonna sum the chunked elements. So if I press Ctrl Alt L to format the code, and now if I run this, look what we're gonna see in the output. So we get you get first the chunked elements here in three elements, and then we have our chunked elements, but they are summed up. So we have first 3 because 0 plus 1 plus 2 is 3. Then we have 3, 4, 5 because that is 12. Then we have 7, 8, 7, 6, 7, 8, and they have 21. Then we have 10, 11, and 9, and we have 30, and so on. So this is how you can use the chunked function to chunk elements together by a given size, and you can also use the transformation function to do a transformation on them, like adding them. So as you can see, we have adding them here. Next, we're going to look at the next function that we can use, and that is called the windowed function. And we can retrieve all possible ranges of the collection elements of a given size with the window function. The function of getting them is called windowed. It returns a list of element ranges that you would see if you were looking at the collection through a sliding window of the given size. Unlike chunked, window returns element ranges, windows, starting from each collection element. All the windows are returned as an element of a single list. So if I have here let's create another variable here. Let's call it val numbers string 2, and we're gonna type here let's say or I can assign the number strings here. So I'm gonna type here number strings. Now what I can do here, I can add a print line, and I can type numbers strings 2 dot windowed, and we choose, let's say 3, and let's see what we have on the output. So now if you run this code, I should have added here a space. So let's add a print line here, backslash /n. So we have 1, 2, 3, then we have 2, 3, 4, you have 3, 4, 5, and 4, 5, 6. So this is similar to chunk, but windowed provides more flexibility because you can specify a step which defines a distance between the first element and two adjacent windows. By default the value is 1, so the result contains windows starting from all elements. If you increase the step to 2, you'll receive only windows starting from the odd element, first, third, and so on. And finally, you can apply transformation to the return ranges right away. To do this, you provide the transformation as a lambda function when calling windowed. So it's similar to chunked. And so with this, I think we end our discussion about retrieving collection parts, and see you in the next video. And if you find this confusing, don't worry, because it's so confusing for me and for probably other people, because it takes time to get used to this. And my suggestion for you, just play with the code, change the parameters, play with the functions, try different values, and so on. So see you in the next video. Now we're going to look at some functions with which you can retrieve single elements from our collections. And the first one is one which retrieves an element by its position. So I'm going to create val numbers again. Numbers equals to list of and we type here 1, 2, 3, and 4, and also 5. And let's say that I want to get the element at position 3. To do that, just add here a print line, and we type numbers dot element at, and here you specify the position 3. So 0, 1, 2, 3. So we're going to get 4 outputted in the console. So we get in the output as expected 4. Now there are also two functions for retrieving the first and last element, and to do that just add another print line here and type numbers dot first. So this is going to retrieve the first element, and Control D, numbers dot last. So this is gonna retrieve the first element 1, and last is gonna retrieve the last element 5. So if you run this, we get first 4 from our this print line, then we get first 1, and we get the last 5. And we can also retrieve elements by condition. So I can type here, I can type down here, or I will type it here. Actually, I'm gonna type it down here. So now add here a print line, numbers, let's say, dot first. And now I'm gonna retrieve by a condition. So I'll type first, I'm gonna choose this one with curly braces. And the condition is that I want to retrieve the first element for which the length is greater than 3. So I'm gonna type here it dot length greater than 3. And I'm gonna add, I'm gonna press Control D, because I'm gonna do the same thing for the last. So I'm gonna retrieve also by condition. So I'm gonna type here numbers dot last, but I'm gonna change the condition. I'm gonna change it to it that starts with the letter F. So now we're retrieving the first element, which is greater than 3, and next we're retrieving the last element, which starts with the letter F. So now if you run this, we get 3 and 5, because 3 is the first element which is has a length greater than 3, and again we get 5 because this is the last element which starts with the letter F. And if you can add a space here if you want to make things more clear. So we're gonna add the print line, quotation marks, backslash n, actually /n. So if you run this, we get 3 and 5 outputted in the console. And we can also retrieve a random element from our numbers. So I can type here print line numbers dot random, and this is going to return a random number from our list of numbers. So if I run this, we get 1, and if I run this again, get 4. So every time you run this, you'll get a random number. And you can also check if the list is empty. So you can type here print line numbers that is empty, and that is going to return true if the list is empty, and if the list is not empty, it's going to return false. So if you run this, we get false. So this is our discussion about how to retrieve single elements. See you in the next video. Now it's time to start a discussion about aggregate operations. So Kotlin collections contains functions for commonly used aggregate operations. And those are operations that return a single value based on the collection content. Most of them are well known and work in the same way as they do in other programming languages. And we have min or null and max or null, which return the smallest and the largest element respectively. And on empty collections, they return null. Then we have average, which returns the average value of elements in the collection. Then we have sum, which returns the sum of elements in the collection of numbers. And we have count, which returns the number of elements in a collection. So let's declare a list, numbers, list of, let's put some numbers here, like let's say 6, 10, 14, 4, let's say 100. Now let's press Ctrl Alt format the code, and let's add the print line here. Let's put quotation marks and let's type the sum is $, and we type here numbers dot sum, numbers dot sum. Alright, and I'll add another print line, and now this is gonna say the count is, again $, numbers dot count. Another print line, the average is, again $, numbers dot average. Another print line, and now I'm gonna say the max value is, again $, numbers dot max, numbers dot max or null. And other print line, the mean value is $, numbers dot mean or null. Now if you run this code, you're gonna see in the output the corresponding values for those expressions that we have here. So again, the sum is 134, the count is 5 because we have 5 elements here, the average is 26.8, the maximum value is 100, and the minimum value is 4. So this is how you can use those aggregate operations and those aggregate functions. And beside the regular sum, there is an advanced summation function called sum of that takes a selector function and returns the sum of its application to all collection elements. And let me show you how this works. So you just type here, so we type here print line, the sum is $, numbers dot sum of, we select this one, and here you type it times 2. Now if you run this, what it's gonna do is gonna sum all the numbers like the first function that we have here. So it's gonna sum 134, and it's gonna multiply that number by 2. So if you run this, we get 268, which is 132 times 134 times 2. So this is how you can use the sum of with this transformation, which is gonna basically multiply the list with a number, with the sum of the list with a number. So this is our discussion about aggregate operations, and see you in the next video. Now it's time to start a discussion about ordering, and in this video we're gonna look at comparable and at comparator interfaces. So first I'm gonna create a list of numbers, and I'm gonna declare a mutable list, so mutable list of, and I'm gonna define some numbers here, not in a specific order. So we type 2, let's say 5, 1, let's say 40, 20, 100, let's say 60. Now what if I want to order the numbers that I have inside our list numbers. To do that, you just you type numbers dot, and there is a function called sorted. So if I type numbers dot sorted, now our numbers are going to be sorted. So if you type here for each, print line it. So now if you run this, even though we didn't type our numbers in ascending order, they're going to be sorted. And as you can see, they are sorted. We have 1, 2, 5, 20, 40, 60, and 100. So they are sorted by this function called sorted. And why this is working? This is working because if you click on this sorted function, or actually if you type here, let's say that I put a type here, int, and if I click on the type, this type integer, this class is implementing this thing called comparable, and this comparable has a function called compare to. So when we actually type numbers that sorted, what internally was happening is that the integer class was using the compare to function, which is a function which you need to implement if you implement the comparable interface, to compare to compare our numbers and to based on that to swap them, to sort them. And now let's say that I have a data class called laptop, and it's gonna have a variable called brand, gonna be of type string, another variable called year. This could be the year when this specific version was released, an int, RAM, so val RAM, also an int, and the val, let's say price, also an integer. Right now, if I create here a list of laptops, so if I type here var laptops equals to mutable list of, and I type here laptop, let's say that I type here Dell, and I put the year, let's say 2021, the RAM, let's say that is 4 gigabytes RAM, and the price, let's say that is $600. Okay, comma, I'm gonna create another laptop here, so another object. I'm gonna type here, let's call it Acer. It's gonna be, let's say, the year, let's put 2020. The price, let's say, the RAM, let's say that is 8 gigabytes RAM, and the price, let's say that it's $100, comma, and let's create another laptop object. So we type laptop, and we create an Apple laptop, which you're gonna choose the year, let's say 2022, and for the RAM, let's say that I choose 16 gigabytes RAM and $1,000 for the price. Now, if I type here laptops that sorted, let's say that I want to sort the laptops, as you can see, while I'm typing, the IntelliJ is not giving me any hints to have this function sorted to fill in that function, because that function is not working on our laptops list. And why is happening that? That is happening because the IntelliJ doesn't know how we want to sort this laptop list that we have here, because you can sort it in many ways. You can sort it by the name, you can sort it by the year, you can sort it by the RAM, you can sort it by the price. So when you say laptops are sorted, the IntelliJ is not knowing what do you mean, because previously it was working with our integers and with our integer class, because the integer class, if you type if you put the type here back, integer, the integer class or the int class, what it was doing actually, it was inheriting from this comparable interface, and it was implementing the compare to function, which is used when you call the sorted function. And inside the compare to function, it has defined its own logic for comparing integers, for comparing whole numbers. And what we need to do in order to be able to sort our list of laptops is we need to implement the comparable interface, and we need to define our own logic which is going to determine how our list is going to be ordered, by which property, by the year, by the RAM, by the price. So this is what we need to do. And to do that, you just put here colon, and we implement the interface comparable. So we type here comparable, and we have a suggestion, we choose this one. We put angle brackets, and here we type laptop, because we want to implement this, we want to compare laptops. So laptops. So this is why we put laptop there. Then we put curly braces, and now we need to implement the function. So click on that. It says implement members. And we have the compare to function. Now, here we need to define our logic, which is gonna determine what makes. Here we're gonna define a logic which is gonna determine how our element is gonna be ordered, by what criteria. And I'm gonna order the laptops first by the price. And to do that, you just type if, and you type this, and we type in this because this is gonna be called on an instance of our laptop class. It's gonna call the compare to function, and it's gonna compare with another argument. So if this dot price, we say here, is greater than other dot price, we return a positive number. So we type return 1, and positive value simply shows that the receiver object, so the object, this object is greater than the object which was passed. So this is what this means, this one. Else if the receiver object is not, so if this dot price is less than other dot price, let's say, then we're going to return -1, a negative number. So I'm going to put here -1. And what this basically logic is going to do is going to swap them. So it's going to swap the elements based on this logic. Else, we're going to return 0, and that is going to mean that they are equal. So we type here return 0. And if you click here, it says that you can write this in a different way. So if you click on list, and let's add a print line to see that our ifs are called. So if I type here print line, I'm going to say in if statement $, actually let's type swapping $, this dot brand name with $, other dot brand. So let's add this print line also in our else if, and I'm not gonna add it inside the else because we don't have elements which are equal, but you can add that if you want. Now if I type laptops dot sorted, now I have a suggestion, and if I type for each print line it, so print the element. Now if you run this, look, you're gonna see the elements sorted in ascending order by their price. So you see that we have first the brand name Dell, and we have price $600. Then we have price, we have laptop Acer, and we have $800. Then we have laptop Apple, the brand, and we have the price $1,000. So now they are sorted using our own logic, which was defined inside this comparable interface, and which was defined inside which was defined by this comparable interface, and which was defined inside this function compare to that we've overridden inside our class. And as you can see, if you look, you see here that it says if in if statement swapping Acer with Dell. So yeah, the elements are swapped based on our logic. In if statement it says swapping Apple with Acer, so they are swapped based on our logic. So this is how you can use the comparable interface. But what if I want now to compare by the, let's say, RAM? What can I do? I can't implement the comparable interface again here, and I can't I can add that property here, but that is gonna conflict with my logic for the price. So what can we do? And here comes into action comparator. With comparator, you can compare your list. You can order, actually I should say, you can sort your list using multiple properties. So you can order it by the brand name, you can order by the year, you can order by the RAM, you can order by the price. And with the comparable interface, you can do that just only by one property, and that is pretty inflexible, and it's not what we want. And how to use this comparator? To use the comparator, we just type here class, we're gonna call it comparator, let's say RAM, and it's gonna extend from comparator. So type comparator and you have the type, and for the type here we want to compare laptop, so you type laptop here, angle brackets, curly braces, and press enter. And now we need to override the compare function inside our class. So you override that function, and here again let's change those to laptop 1. So now we have laptop 1 and laptop 2, and we define the same logic. So we type here return if, because we need to return an integer, if this dot RAM, actually not this dot RAM, laptop 1 dot RAM is greater than laptop 2 dot RAM, and we need to delete these nullables because we need to have some errors there, and put curly braces, return 1, else if laptop 1 dot RAM is less than laptop 2 dot RAM, then we're gonna return, put curly braces, we're gonna type return -1, else we're gonna return 0. Now if I want to compare our let's add a space here, and I want to sort our elements based on the RAM, I'm gonna add a print line here to add a space. So I'm gonna add the /n, also here one. So copy this, paste it here, should be print. And now what we can do is we type laptops dot, and we type here sorted with, and we choose this one which has the parameter define a comparator, and we're gonna pass our comparator that we define here with the compare to function. So I'm gonna type sorted with, and we type comparator RAM, our class, and create an instance, and then we type dot for each, not this one, for each print line it. So now if you run this, you're gonna see them sorted by their RAM. So if you run this, as you can see, if you look at the first, they are first sorted by their price. So you have $600, $800, $1,000, and then we have them sorted by their RAM. So we have first the 4, which is the Dell, and then we have the Acer, which is 8 gigabytes of RAM, and we have the Apple, which is 16. And if you look, actually they are in this order in the list. So let's change this to let's say to 16, and this to 8 to make it more clear. So let's run this again. So as you can see, they are still sorted. So we have first the Dell, which has 4 gigabytes of RAM, then we have the Apple, which is 8, then we have the Acer, which is 16. So this is why. So now it's sorting our list, this sorted with, using comparator RAM that we defined, we created, and then we loop through all our elements, because that returns a list. So this is how we can use comparator. And if you want to sort, let's say now the list by the year, you just create another comparator. So you type class comparator, let's say year, and it's also going to extend comparator is going to have for the type laptops, because it's going to sort laptops, curly braces. We implement the function compare, and we define the logic for comparing elements using the year. So let's delete these nullables. Let's type here laptop 1, and here laptop 2, and I'm gonna copy this code. I'm gonna paste it here, but I'm gonna change this from RAM to year. So year, also year, again, and we have an error here missing. So let's add a curly brace here. All right. So now if I want to have the elements sorted by the year, we just type here, let's put a space also, print line, quotation marks, for session, and if I want the laptops to be sorted by the year, I just type laptops dot sorted with, and this expects a comparator. So I'm gonna call our comparator that we created, comparator year, an instance of that. Then for each, now this one again, for each, print line it. So if you run this, now we're gonna see the last element sorted by their year. And have, as you can see, you have we have them sorted by their RAM. So this is from this one, and now it's using comparator years. So it's sorting them by the years. So we have 2020, 2021, and 2022. So this is not like the order that they are defined in the list. So this is how you can use comparable and comparator. But if you think about, there is a lot of code here to just have our list sorted. You have to, if you want to, you can use the comparable, and with the comparable you can use it with just one property. And if you want to use it with another property, you have to create those comparators, which gives you some flexibility, but still you have a lot of code. And we can remove all of this code and use lambda functions. So I can delete all of this comparable that we have here. And instead of using those comparators and all of this stuff, what I can do is I can delete all of this. I can delete all this also. Now what I can do is I can add here laptops dot sorted with, and here, so we choose this one, sorted with, which has this parameter comparator, press enter, and here we type compare by, and here we type, and this line of code that we have here, what it actually is doing is creating a comparator, but it's creating a comparator using a lambda expression. So here you can type it dot, let's say price, right? And then for each, print line it. So this is equivalent to creating that comparator here and inheriting from the comparator interface and defining the logic for ordering, for sorting them. So now if you run this will have the same effect like the comparator price that we have implemented previously. As you can see, they are ordered now by the price, and I can do now another line of code. So dot laptops dot sorted with, and we type here compare by, we type it dot let's say RAM dot for each print line and it. Now if I run this, I'm gonna have the same output. Let's add a space between them, print line. So let's add a space to see the code more clearly. And now, as you can see, first they are sorted by their price, and then they are sorted by their RAM memory. So this code is equivalent to creating what we had previously with the comparator and implementing that interface and the function. And actually, there is a shorter way even to do this. We can delete this, let's say, so this sorted with and compare by, and we can just type here sort by. So this will create internally the same thing that we had previously. So if I type it.ram, and I can do the same thing here, I can delete all of this, and I just could type here laptops.sort by it.price. Now this will have the same effect like all the code that we had previously, but now it's extremely concise and easier to read. You could just say laptops sorted them by their price, sort the laptops by their RAM. So if you run this code, you'll see the exact output in the console, because what this function is doing, actually we should loop through them. So let's add the print line here, print line it. So let's put here for each print line it. So now if you run this, you'll see the exact same output with just this simple line of code. So as you can see, you have the same output. You have them sorted by their price first, and then they are sorted by their RAM memory. And if you hold control on this sorted by function, as you can see, this actually internally calls the sorted with, which receives the comparator and is calling the compare by. So this is like a syntactical sugar for us, which makes the code more concise. But internally, it's using that sorted with. And if you want to use the sorted with, one advance for using sorted with, let's say that I type here another print line to add a space. Let's put /n, should be in quotation marks, /n. One good thing about the sorted with, so let's type laptops dot sorted with, and here we type compare by, let's say it dot here. One thing that you can do with the sorted with, if you call specifically sorted with function, you can put dot and then by, so it will sort by year and then by I don't know, let's say it dot price. So this is what we can do with sorted with. You can sort it by year first and then by the price. So if you run this, as you can see, they are sorted first by the year, so, and then by their price. So this is why we get this in the output. Now I'm gonna end this video, and you should use this one always, because it's concise, more readable, very easy to read and to type. This in contrast with what we had previously with creating that comparators and implementing the comparator interface or the comparable. This is a lot more concise and easier to read. So this is our discussion about the comparable and comparator interface. So this line of code, I repeat, this line of code that we have here, this sorted by it.ram, is creating internally that comparator that we talked about. Now we're just using this lambda function. So I'm gonna end the video now and see you in the next video. So there is one mistake that I did previously. So if I press Ctrl Z to have this code, when I run this code, you didn't show on the output the list sorted by the year and then by the price, and that is because I forgot to add a for each to loop through our elements. So if I add a for each, and now if I run this, now we're gonna see them sorted first by the year and then by the price, because previously it wasn't. So this is why it wasn't. Now if you look, they are sorted by the first by the year. So we have 2020, 2021, and 2022, and then by their price. So this is why previously you saw this one, this output, and also I saw this output but some way I didn't saw that I forgot to add the for each here. So this is how you can use sorted with. You can sort it by more elements. You can put here, I think, another, then by, not here. Here we can put another, so that, then by. You can put another then by here if you want. So it that, let's say RAM. So you can add more then by if you want. So now I'm gonna end the video. See you in the next video. Now it's time to start a discussion about binary search, but before we look at binary search, we're gonna first look at linear search to see why binary search works better. So I'm gonna type a function here. I'm gonna type private fun. It's gonna be called search element, and here we're gonna type search element. So this parameter is gonna be the element that we are searching for. And then another parameter is gonna be a list of numbers. So it's gonna be a mutable list of ints, and it's gonna return a number, the search element, or -1 if you don't find the search element. And here we're gonna loop through our list. So I'm gonna type for number in our list of numbers. If at a particular iteration our number it's equal to the search element, that means that we found the element, that we found the number. So we're gonna return number. Else, if you come down here and after we loop and we did our if checks, we didn't return the number, that means we didn't find a number. We're gonna return -1 here. Now I'm gonna add a print line here, and I'm gonna type search element, because this is gonna return an element, and then we're gonna output with the print line that in the console. And I'm gonna type here 27, and for the next parameter I'm gonna define a list of numbers. So I'm gonna type mutable list of, and here I'm gonna define a number from 1 to 30. So I'm gonna type here the numbers 1, and our last element 30. Now, if you run this code, you're gonna see in the output 27. So we get, as expected, 27. But let's declare a variable here, I, to number the number of iteration it took to find the element. So I'm gonna assign 0 to it. I'm gonna increment it every time we loop. So I'm gonna type val. I'm gonna type I, sorry, ++. And I'm gonna add a print line here, and it's gonna say search number $I. So now if you run this, you're gonna see how many iteration it took to find our element. And if you look at the console, as you can see, it took 27 iteration before we found our element, because the way the linear search is working is it's going through all of the elements, it's checking out each iteration if the number at that particular iteration is equal to the search element. If not, it's gonna loop again and again and again until it reaches 27. Then it founds that element and it returns the element, and you get that element outputted here in the console. So this is what we call a linear search, and this is not particularly good because imagine if you have 1 billion elements or 10 billion elements and you need to find, I don't know, maybe the 7th billion element in that array. That is going to be very hard and it's going to take time and memory. And because of that, we have another data structure for searching elements, and that is called binary search. And I'm going to type the code for binary search here, and also you're going to see the number of iterations it took to find the element, and also I'm going to explain how binary search works. So I'm going to delete this. I'm going to type here var low, I'm going to put equals to 0, var high equals to numbers dot size -1. I'm going to explain the code immediately. Here I'm going to type while low is less than equal to high. Here I'm going to type val mid. So now I'm going to get the middle element. So I'm going to put parentheses low plus high divided by 2, and that's going to give us the middle element 15. Then I'm going to type val comparison, so I'm going to type cmp equals to numbers that get the middle element compared to, I'm going to compare the middle element with the search element. Then I'm going to type here if now I'm going to type if comparison is less than 0, then I'm going to type here low equals to mid plus 1. Else if comparison is not less than 0, so it's greater than 0, I'm going to type here that low is equal to high, sorry, is equal to mid minus 1. Else I'm going to type here return numbers that get mid, and that is going to give us the middle element. Now if I declare here a variable var I, and if I assign 0 to it, and if I increment that I at each iteration, and if I add a print line here, searched number $i. Now if you run this, you're gonna see actually I should return -1 here, because if at the end of our looping and after we checked our all of our list and we didn't find a number, then we return -1, meaning that we didn't find the element. So now if you run this again, we get search number 1, 2, 3, and then we get 27. And as you can see, this is significantly different from our linear search, because now we only took 3 searched and then he found our element. Previously we had to search through all of our elements, through our elements until the number 27 to get the number 7. But now we only get 3 iteration and we get the number 27. And how is that possible? This is because now we're using what is called the binary search. And how this binary search works, I'm going to explain it now. So now let's see how the code works. So first we have a variable declared called low, to which assign a value of 0. Then we have another variable called high, to which assign number the size -1. So we assign the size of the array to our high. Then we have a variable called I, to which we assign 0. Then we have a while loop, and we start looping by this condition, while low is less than equal to high. Then we increment our I to keep track of how many iteration it takes before we find our element, and we output in the console search element and the number at that iteration. Then we have a variable called mid, and this is gonna give us the middle element. And to get the middle element, we add the lowest element plus the highest element. So we add here 0 plus 30 divided by 2, which is 15. So this is the middle element. Then we declare another variable called comparison, and we type here numbers that get the middle element, which is 15, compared to search element. And if the middle element is less than the search element, that means that the search element is on the right of the numbers which come after the 15. And because of that, this is gonna return, because our middle element is less than the search element, is gonna return a negative number. So this is gonna be true. Comparison is gonna be less than 0. And then I'm gonna assign low equals to mid plus on. So now the low variable has the value 16, all right? Now it will loop again. It will have the I increment, and it will do the while loop. It will increment the I again, and it will output I in the console. Now here, it will calculate again the middle element, and it will add now 16 plus 30 divided by 2, and that is gonna give us 23. All right, now that is the middle element now. And what we do now here is we again have our variable comparison, and we get numbers that get 23. So we get the 23 element, and we compare with our search element, which is 27. And again, because our middle element is less than the search element, this is gonna return a negative number. So this if check is gonna be true again. Now, what is gonna happen is that now low is gonna be equal to mid plus 1, and low previously was equal to 23. So now we're gonna have 23 plus 1, which is 24. All right. Now this will loop again. So as you can see, this basically breaks the list in half at each iteration. And now this will loop again. It will increment the I, it will output the I, and now it will calculate again the middle element. Now the middle element is 24, and the high element is 30. And we have 24 plus 30 divided by 2, and that is 27, the exact number that we are searching for. So this is how binary search works. It will compare the middle element with the search element. If the middle element is less than the search element, that means that your element is on the right side of the element which come after the middle element. So all the elements from the left are going to be excluded, and it's going to search only on the right side. Then it will split the list again in half. If the middle element again is less than the search element, it will go to the right again. It will split the list in half, and it sooner or later it will find the element to the right or to the left. So this is how binary search works, and it's very powerful, because for a very big list you can use binary search, and it's more effective than the linear search. And this is the code that I type, but you don't need to use this code, because I only type this code to show you how the binary search works. But usually you'll use the binary search function provided by the collection. So you'll just type here return numbers. We're gonna put square brackets, and I'm gonna type binary. I'm gonna type here numbers again, binary search, because the binary search function provided by the collection only returns the index. So if I search for the 27 element, that is gonna return the index 26, and the index 26 then is gonna be the number 27 from our numbers list. So now if you run this, you'll see 27 outputted in the console. So we get 27. And we did this only with one line of code. You can even remove this and just have a single expression function. So we can put here equals. So just by that, it will do the same thing that we did previously with all the code that I typed. So this is our discussion about binary search, and see you in the next video. But before I end the video, I should say that binary search only works with the order collection of elements. So your elements need to be sorted in order for the binary search to work. And in our case, we used integer numbers, and it was easy because we typed our elements in a sorted order. But if the elements are not sorted, binary search is not gonna work. Also, if you have your own class, so you have your own objects, and you search using binary search through a list for a specific element, in that case your class has to implement the comparable interface, or it has to use the comparator interface, and I'm gonna show you how to do that in the next video. So see you in the next video. So now it's time to start a discussion about generics. So what are generics? Generics allows us to give to the compiler some hints about what kind of objects we are dealing with. And this helps the compiler to figure out some errors at compile time, and it also helps us to write more consistent and better code. And we already use generics when we look at collections. So every time you use an array and you specify in the angle brackets an int or a double or a class that you created, an object, what you actually did there is that you use generic. You said to the compiler that is the kind of data that specific collection is gonna store. So if you have something like this, val, let's say numbers, and we put equals here, and we type array of, here you can put angle brackets, and you can specify a type here, let's say int, because I'm gonna put numbers here. And now this helps the compiler to figure out if let's say we want to add here, let's say a string. So if I type here numbers equals, let's say some text, let's put in quotation marks, some text, as you can see you have those underlines in red, which says, if you hover over here, first it says that val cannot be reassigned, so let's change it to var to get the error that I want. So let's put var here. So we get here type mismatch, required int found string. So here we are using a generic type, and the generic type is an integer, and because we said explicitly here that this array is only gonna store integers, we cannot go down here and assign some string. But as I said at the beginning, generics are only a compile time feature. They don't make it through the runtime. And again, we're going to come back to this later because this has some implications. Now, let's delete this and let's create our own generic class to see how it works. Because here we're passing int, but if you click on this array of, you see that you don't have here an int. An int is the type that we specifically decided to pass to this array. But if you look here inside this library.kt, and if you go to array here, you see that we have var arg elements and we have this t. And t is a generic type, and the specific type that is gonna be passed here is the type that we pass when we create an array, when we want to store some numbers or some strings. And now let's see how we can create a similar thing that we have here with our own code. So I'm gonna delete this. So again, generics are there to help the compiler to figure out errors, and it also they are there for helping us to write better and consistent code, so that you don't add let's say strings to an array which is meant to store only numbers. So First, I'm going to create a class, and it's going to be an open class, and it's going to be called player. And it's going to have a property called name, so it's going to be a val name. We're going to define this in the primary constructor, and it's going to be a string. Now, I'm going to create open class here. And down here, I'm going to create two classes. First is going to be called football player. So football player. And this is going to have a name, and it's going to be a property because we're going to extend from our player class. We're going to derive from our player class and going to pass that property to that parameter name to our property name from the superclass. So we type here player because we are inheriting from it, and here we pass name. So we pass here name. Next, I'm going to create another class called baseball player. So we type here baseball player, and this is also going to have a name, also only a parameter because the property is going to be ultimately defined by the superclass, by the class from which we are inheriting from. So here we're going to inherit, put a colon to inherit from our player class. And here we pass our name parameter that we defined here. We pass it here to the primary constructor of the base class from which we are inheriting from. Alright, so now I'm gonna go up here, and now I'm gonna create a class called team. And this class is gonna represent a team, and this team can be a football team or a baseball team. And here we're gonna create a class called team. So we type the keyword class. I'm gonna call it team. And now here we put angle brackets, and inside the angle brackets we're gonna define the generic type T. And you can use a different letter here if you want, but usually and generally use the T because it stands for type parameter. Next we put parentheses to define the primary constructor, and for the primary constructor I'm gonna define a val name, and this is gonna represent the name of the team, and it's gonna be a string. And next I'm gonna define also a val, but this is gonna be called players, and it's gonna be a mutable list of also of type T. So we type here mutable list, and we put here T. Right? Now I'm gonna put curly braces because I'm gonna define a function inside our class team. So here we type fun, and I'm gonna call this function add players. So this function is gonna add players to the team. We put parentheses, and here we define a parameter called player, and it's gonna be of type T. So it's gonna be, should put colon here, and we put curly braces. And this is gonna receive a parameter of type T, and this type T that we define here and here and here is gonna be the type, a specific type that we gonna pass when we create an instance with our class team. So first here we're gonna check if the players, so our list of players contains this player that is passed to our add player function, because if we already have that player in our list, we're not gonna add it to our list. So if player, and to check if that player is in the list, we call the contains function on our mutable list. So here we type players that contains player, the argument, and if that is true, we're gonna put curly braces, and here we're gonna output something that goes to the console. So we type here print line, quotation marks, and we type player, colon, and then we put $, curly braces, and here we need to do something which is called casting. And casting is used when you want a variable to be treated as a certain type of variable. So when you want a variable to be treated by the compiler as a certain type of object or a class. So we type here player because let me show you why we need to do that. Because if I type here player, now I want to get the name, and if I put here dot name, as you can see, we don't have any name here because this t and this t that we have here is generic. The compiler has no idea if this t that is gonna be passed here. So if you pass here a baseball player or football player, it has no idea if at this moment now if that is gonna have a name property on it. This is why when you type here dot name, we don't get nothing. And to solve that, we can say to the compiler to treat this parameter here. So this is gonna be a value passed to this parameter as a player. And in that sense, in that way, we can get access to the name property. So we type here player, and to cast a variable to a certain type, we put as. So we put the keyword as, and we type player, and we put this in parentheses. So we surround our expression in parentheses inside the curly braces. And now here at the end of the enclosing parenthesis, you put dot, and now we have access to name because we said to the compiler, hey, treat this player variable. I don't know, because I don't know if this is gonna be a player object passed here, or a baseball player or a football player. Treat this player variable that is passed here as, because here we have t, so we don't know what it is. Treat this player variable as a player, so you can use the name of a variable. And we're gonna say is already in the team, and we can put here the team, and we can type here $, this dot name, so the name of the team. Else, if our player is not in the team, we put else. We're gonna press enter to add the right curly brace. We're gonna add this player to the list, because if the if fails, that means that the player is not present in our list. So we type here players, our mutable list, dot add this player that is passed, player. And we're also gonna output something to go to the console. So you add here print line, and I'm gonna copy this because I'm just gonna change the text a little bit. So let's delete this player, and so here we're gonna say, instead of it's already, we're gonna say was added in the team. Now let's create some objects with those classes that we have here. So first I'm gonna create some players. So I'm gonna create first a football player. So type here val football player equals football player, and for the name I'm gonna use a generic name. I'm gonna type just football player 1, and I'm gonna press Ctrl D to create another football player. So football player 2 is gonna be called, and I'm gonna create two baseball players. So we type here val baseball player equals baseball player, and we type here baseball player 1, and I'm gonna press Ctrl D here also. I'm gonna call this baseball player 2, and I'm gonna change this to 2. Now I'm gonna create an instance of our team class. So we type here val team, and this is gonna be a team of football players. So we type val team equals, and here we type team, and we put now, because as you can see it's expecting a type here, and the type is gonna be a football player. So it's gonna be a team with football players. And here we're gonna define a name, also a generic name, football team is gonna be called. And we also need to pass an array there. And for this array, we're gonna type just mutable array of, but I can't. List of, and here I'm gonna pass our football player. I'm gonna pass only our first football player here. Now I'm gonna create another team, val team. Let's actually call this first team football team. So let's type here football team. Now if you run this code, we don't get any output because our add players function wasn't called. But if I type here football team, actually here football team dot add players, and I'm gonna add football player 2. Now if I run this code, we get football player 2 was actually, here should be added. Football player 2 was added in the team football team. So our code works well, and we use generic types for our classes. Here we specified only the T, and this T that we have here was replaced with football player that we define here. And we're gonna do the same thing. We're gonna create another team for the baseball player, and we're also gonna look at how we can restrict the types that are gonna be passed to our generic type here. So now I'm gonna create a baseball team. So I'm gonna type here val baseball team, put equals, then you put here team, and here we type for the generic type T baseball player, because this is gonna store baseball players. And we define a name here. The name is gonna be baseball team, a generic name. And also here we need to type to pass a mutable list. So we type mutable list, and we pass here a baseball player. But as you can see here, for the type, the type here is grayed out. That is because here we pass the football player object that we created, and here we pass the baseball player. Because Kotlin has type inference, it can infer the type as being a team of football players. So you don't need to put here football player. You can delete this, you can delete all of this, and now our code still works. And you can see we have this type hint which says team football player. So it's a team of football players, and it's inferred automatically by Kotlin for us. And you can do the same thing here for a baseball player. So I'm gonna delete this. As you can see, now we also have the hint team baseball player. Now let's add to the baseball player. Let's call the baseball player function. Let's put here so we type here baseball team. Let's call the function dot add players, and here we type baseball player 2 because the first one was added there. So now if you run this code, not debug, so run this code, let's increase this, we get, let's actually decrease this, so let's put here. We get player, football player 2 was added to the team football team. So we have this code here, which is called, and it says that the football player was added to the team and the name of the football team. And then we have player, and we have baseball player 2. So this one that we have here, that we passed here, baseball team, that was this to the baseball team. As you can see, it says player, baseball player 2 was added to the baseball team. And what generics helps us to do, because I said they can help the compiler to figure out errors. If you try to pass here baseball team dot add football player, so we type here football player, now you get an error because the generic type enforces the type on the class, because here we said explicitly that this is because this was inferred to be as a baseball player. We cannot pass here a football player in our baseball team, because this is enforced, because we said here explicitly because this was inferred from here. So we have team baseball player, so we cannot add here a football player inside our team football player, and this is very, very powerful for us, because in this way we don't do things which doesn't make sense. And the same is true about our football team. So if in our football team we type football team dot add, and here we put baseball player, we get an error because we specified that because the generic type was inferred to be a football player, so we cannot put a baseball player in our team of football players. So this is what generics is doing, is figure out those errors for us at compile time. And this is very powerful because we can run our code and we don't get in those some scenarios where we have a baseball player added to a baseball team, or maybe other examples there. So I'm gonna delete this. Next we're gonna look at upper bounds, because upper bounds basically allows us to restrict what kind of type is passed to our generic type here. So and particularly gonna see how this is gonna affect this code that we use here to cast. So to add an upper bound, so to restrict what kind of type is passed to this type, we can put colon, so extends, and here we can type player. So what we're saying here is that every type that is gonna be passed here when you create an instance, like we did here, so but only that this was inferred here, this type that is gonna be passed here needs to inherit from the player class. Otherwise this type is not gonna work. So because of that, because the compiler now knows that and enforces this, that this type that is gonna be passed here is gonna inherit from the player class, we can't delete this cast, because now it knows that type is gonna have is gonna inherit from the player class, so it's gonna have the property name. So if I delete this, and if I delete this, so let's put name here. Now, so let's delete this too. Should be player here, player. So now we have player.name, because it knows that this type, so this type that is gonna be passed here is gonna inherit from the player class, so it's gonna have the property name. So you don't need to do this weird casting. So I'm gonna delete this, and now as you can see we don't have any errors. So now we have the name here, because now it knows that whatever type you pass here, it has to inherit from the player class. So if I go down here and I create another class called gamer player. So we type here class, let's call it games player, and it's gonna have a val. It's gonna be, actually let's define a parameter only. Name is gonna be a string, and we will not inherit from our player class. Let's see what happens. So if I create here another team, let's call it val, let's call it the games team. So I'm gonna type here team, and we're gonna specify here games player. Now if I put now the primary constructor here we need to define a name. Let's call it games team, and a mutable list of. Now here we have an error, and if you look, it says expected player found games player, and this happens because our games player that we have here is not inheriting from the player class, and because we said here that the upper bound is this t that is passed here, so this t is this here, has to inherit from the player class. Otherwise, if you don't inherit from the player class, it will not work, because we said here that it must inherit from the player class. Now if I change this to, if I change this down here to inherit from the player class, so we type here player, we type here name. Now as you can see, the error disappears, because now it's respecting the upper bound that we set up here, which is t, meaning games player has to inherit from the player class, and then down here it's inheriting. So this is our discussion about how we can use generics, and how we can define upper bounds. And in the next videos we're gonna look at type erasures, and you're gonna look also at reified keyword, and how we can inline our function with, because you need to inline your function when you use reified keyword. So see you in the next video. Actually, before I end the video, I should say why this generics is important. Why? Because if you think about, because here we can type, we can define a generic type. We don't need to create a separate class for every team that we want to use. So we don't need to create a football team, we don't need to create a separate baseball team, we don't need to create a separate games team. We just create a team, we define the generic type t, and here we pass our type, and in this way we can use only one class, and we can have all of those baseball team, we can have the football team, we can have, just by having the type here, which is generic. Otherwise we'll have to create separate classes for each of those teams. So see you in the next video, and next video, as I said, we're gonna look at type erasures and reified keyword and the inline functions. And in the next videos, we're gonna look also at covariance and countervariance. So see you in the next video. So now it's time to start a discussion about covariance and countervariance. And as you can see here, I put our classes above our main function, because in this way you can see if we made changes to our code. And first, I'm gonna declare this games player class as open, because I want to inherit from it. So we type here open. And down here we're gonna create another class called counter strike player. So we type counter strike player, and it's gonna have a parameter name, and it's gonna inherit from the games player, and we're gonna pass the name to the primary constructor of the games player. Now, inside our main function, I'm going to type val. I'm going to create a football team. So we type here football team. Then put equals. And now we type team, our class. And here I'm going to define not a football player, but a generic player. So we type here player, because I want to illustrate first how covariance works. Then we put parentheses to call the primary constructor, and here we need to pass a name. So I'm going to pass the name football team. And for the players, I'm going to type mutable list of, and here I'm going to put the angle brackets, and I'm going to type here for the type of the function of the mutable list, I'm going to type football player. And now here I'm going to declare some players. So I'm going to type here football player. I'm going to call it player 1. Again, football player. And this is going to be called player 2. Alright, so now we have our football team created, but as you can see, we have this underline, and we have an error which says that type mismatch, required football player, found player. I think this is a bug, because it should say that it requires player and it found football player. But anyway, what it's saying here is that we said here that this team is going to have players as its type, and here when we create our mutable list, we type for the type a football player, and we pass football players, not players, so not the type that we define here. And now this shows an error, because this is inconsistent, because as I said, here we said player, and here we define football player, and we pass to the list football players, and because T is the same here, we can't do that. Now, if you think about what we have here, that football player is a subclass of player, then we should be able to accept a football player, even though we declare this player as even though we declare here the type as a player. We should accept a football player as the type for the list, for the mutable list, because it's a subclass of player. But because the mutable list is invariant, and that means that it will only accept the exact type. So if I said here player, then you should define here player, and you should create players objects. You cannot put here football player. And now we're touching on covariance. Covariance means that we can relax this type here. We can say, hey, I don't need this exact type player to be passed here, and to be created objects with objects players here. I can relax this, and I can accept subclasses of player to be passed to our mutable list. And to do that, we need to put the out keyword. So we put out before our T inside our type of mutable list on our class team. And now the error disappears, because what covariance means is that I'm going to accept the type that is passed here and all the subclasses of the type. So I'm going to accept player, or all the classes which inherit from the player, respectively the baseball player, and in this case the football player that we have here. So this is what covariance is. It allows you to make this player a little bit more flexible, because you say, hey, I'm gonna allow to pass here not an exact type, respectively player, but I'm gonna allow to pass to our mutable list football players, because they are subclasses of our player class. And we did that by putting here out, and we made our mutable list covariant. So now it accepts subclasses of player. Now, this is covariance. Let's look at countervariance. And countervariance is the opposite. It's when you want to accept not subtypes of a type, but superclasses of that type. So let's see how we can do that. So we type here val, and I'm gonna call it games team. We're gonna put equals, then we're gonna type team again, and here we're gonna define the type, and it's gonna be Counter-Strike player. We define the primary constructor. Let's press Ctrl-Alt-L, format the code, and here we define the name. So it's gonna be called games team. Gonna put comma, and here we need to create a mutable list. For the type, I'm gonna choose games player, and I'm gonna create some games players here. So I type games players. I'm gonna call it player 1, and here I'm gonna create another object, and it's gonna be also a games player, and it's gonna be called player 1. Now here we have the same scenario, but this is now the opposite. Now we have our type, and here we pass the super type. So the Counter-Strike player is inheriting from the games player, and because again our t here and our t in our mutable list is invariant. Actually now it's covariant, but let's make it invariant. So let's delete this. Now we have also the error here. Now because this is invariant, it only, if you hover over here, it says require a Counter-Strike player and found games player. So we said explicitly here that this class is gonna have for its type Counter-Strike players, and down here for the list we pass the games player, and then we pass some games player objects. So we cannot have this inconsistency. But again, there is a relation between the Counter-Strike player and the games player, and that is that the Counter-Strike player, it's inheriting from the games player. So it's a relation between them. So how we can make our Counter-Strike player how we can make it to allow a games player here. So we can allow games player objects to be created and passed here. We can do that by making our type that is defined here countervariant, and to do that we just type here in, and that means that I'm gonna accept the type that is passed here, or all the super types of this class. So in other words, we're gonna accept all the classes from which we are inheriting this class. So we can go even further and pass here player, and we'll have no error because we declared our list, our mutable list, as countervariant. Now we can pass here any super types. So this is what covariance and countervariance is. Covariance allows you to pass to your type the instance that you want, or all the subclasses of that type. Countervariance is opposite. You can pass the type or all the super types of that class. So with covariance you go down the inheritance tree, and with countervariance you can go up the inheritance tree. But now let's change this to games player. And let's change this to make it not countervariant but covariant. So let's delete this, let's put out. And now you probably spotted this, but you have here players that add, we have an error. And this is because when you declare your type as covariant, you cannot use the list to add or to remove items from itself. That is because because we made our type counter variance, that means you can pass any of the subclasses. So you can get in a scenario where you can add here, because because our type is covariant, so it accepts any subclasses. We can have a subclass like we can have a baseball player extending from a football player, and we can add a baseball player here. So you'll have a team of football players with a baseball player in it. So this is why it doesn't allow to add players to the list. This is why I have here this in red. So this is the limitation which comes with making the type covariant. So this is our discussion about covariance and countervariance. So you can play with this code. You can change now this to in. Let's pass here games player. And as you can see, because I made that countervariant, now this error disappeared here, because it accepts the super types. It accepts the classes from which we are inheriting this type. And if you make this out, now we have the error here, because this is not countervariant, but this is covariant, so it accepts the subclasses of player. And on real app, probably you're not gonna write code like this, but I typed this code in this way to show you how covariance and countervariance works. So this is our discussion about covariance and countervariance, and see you in the next video. So now it's time to start a discussion about type erasure and reified keyword. And as I said at the beginning of our section about generics, generics are only a compile time feature. They don't make it through the runtime. So if you have a list of integers, when the code is going to be compiled and run on the JVM is only going to see a list. It's not going to see a list of integers. So they are only a compile time feature. They help us and the compiler to figure out the errors before we run our code. So and also they help us to write consistent code. So you don't if you declare a list of strings, so you want to store text in that list, it helps you to write consistent code, because in the sense that if you try to add to that list an integer later, it will warn you, it will say you that you declare a list of strings and you try to add a number to it. So they are syntactical elements which help us to write better and consistent code, but they don't make it to the runtime. So the JVM is not going to see a list of integers or a list of players or a list of or list of any object, generally speaking. And that has some implications. And one implication is that you cannot do type checking with generics. So if I delete this code, and if I declare here a list, let's call it list, and I'm gonna type mutable list of, and let's type here string, and here I'm gonna put some words. Hello. Let's put world. So because they are a compile time feature, if you try to do checking, so if you try to see if a list is a list of strings, so if I type here if list is list of string, so if I try to check for this, actually now this works, because if you look here, it says remove useless is check. This is because the compiler figured out by looking at what value we assign to our list, that is a list of string, and is always gonna have only strings. So probably when this code is executed, the if is not even it's not even generated. This is why it's saying that this is useless, because it figured out that this is gonna store only strings. But if I change this here to any, so I put here any, so let's type list again. So now because this is any, so it can store later, let's say an integer. Now it says cannot check for instance of erase type list of string, as I said, because the generics don't make it through the runtime, so it's impossible to check for this thing, because this thing is not does not exist for the JVM. But if I want to check for a list, so if I delete this, so if I want to check if it's only a list, I can't let it like this, because Kotlin wants us enforces this behavior to specify the type. And if I want to check if this list is a list, I need to put, if I click on this red bulb, it says add angle brackets, and we have this star. And this basically means check if this, check to see if this list is a list. This is what it's doing here. Now, let's create a function to see how we can use a reified keyword with and having this in mind, that the generics are erased at compile time. So I'm gonna create a function, but first I'm gonna delete this. And we go down here, we type fun, and to create a generic function, we put the keyword fun, then angle brackets, and we put t. This is the syntax. And this function is going to return a specific type of elements from a mixed list. So it's going to be called get specific types. It's going to take a parameter called list. It's going to be of type list of any. And it's going to have a return type, also a list, and it's going to return a list of t. So type here list t, put curly braces and press enter. Now here we're going to create a new list, so we type val new list, or let's call it specific list, let's call it. And this is going to be a mutable list of type t. Then we're gonna loop through our list, so type for element in our list, so list parameter is passed, put curly braces, we go down, and here we're gonna check if element is of type t, so if it's that specific type that we gonna replace when we're gonna call function, then we're gonna add that specific type to the list called specific list. So we type here if element is t, then I'm gonna put curly braces, and I'm gonna add that element to our specific list. So specific list dot add element. So if that element is of that specific type that we passed when we call this function, then it's gonna be added to the list. And when this loop is gonna end, we're gonna return this list. So return specific list. But as you can see here, we have an error. And if you hover over t, it says cannot check for instance of erase type t. Because as I said, types are only a compile time feature. They don't make it to runtime. So it's impossible to make this check. It's impossible to check if an element is of a specific type, because on the JVM generics don't make it to the JVM. They don't exist. They are erased at compile time. So we cannot check here for t. So if I wanted here, let's say I have here a val mixed list, and it's gonna be equals to a mutable list of, and it's gonna have, let's say, some numbers and some characters a, b, and C, and 2 words, let's say. Let's type here hello and world. Now if I called our function, so let's type here val specific list, so it's gonna have the same name as the variable from our specific types function, equals to get specific types. Now here when we pass the type, let's say int, and here we pass the mixed list. So now because here we want, because you passed for the type int, so this t is replaced with int. When we try to check to see if this element is an int, we can, because this is erased. But Kotlin has the notion of reification, and that means to not, if you use the reification, this type is not going to be erased at compile time, so it's going to make it to the runtime. And to use the reify, so in other words, to make sure that this is not erased, and to make possible to check for this t, in this case to check for integers, we need to mark our t here as reified t, and if you hover over now, it says that add inline modifier, because reified works only with inline functions, so we need to put the keyword inline in front of our function. And now our t, as you can see, the underline disappeared, because now our t is now our t makes it to the runtime. It's not erased because we made our function inline and we marked the type as reified. So this is what reification does. It makes sure that the types are not erased at compile time. So now if I add a loop here, so let's say data type for element in specific list, I add a print line here, element. Now if you run this code, now you will see our specific elements from our mixed list outputted in the console. So you're gonna see our integers, because here you pass for the type int. So let's wait a little bit. I think we have an error. So yes, this has to be, so let's comment this line of code because that is an error. So let's run our code again. So let's run our code again. Let's bring this up. So now we get our numbers from our mixed list. So we get, let's bring this code a little bit up. So we get 1, 2, and 360 because we specify here int, and here we checked for int because now the type wasn't erased. And now you can change this. You can change this to char, and now it's gonna output the letters from our list. So we get A, B, C. So we get our specific types chars from our mixed list here because we specify here char, and here we're checking to see if this element is of type char. Then we add that element to the list. Then we return that element. We return that list at when our loop finishes. Then we call our function here with the mixed list. We pass the mixed list. We get the elements, and then we loop here through the specific elements that we got. So this is our discussion about inline and reified keyword. See you in the next video. So now it's time to see how we can define more than one upper bound to our type, because here we have only one upper bound, and that is whatever type we're gonna pass here, it has to inherit from our class player, but we can define more than one upper bound. And to do that, I'm gonna delete this upper bound from our T there. And I'm gonna go down here. I'm gonna declare an interface, which is gonna be called listener, and it's gonna have a function called listen. So fun listen. And now I'm gonna go inside our let's say football player, and here we're gonna implement that interface. So I'm gonna put here comma and listener. This is how we can also inherit and implement an interface. So we type listener and you put curly braces, and now we have to implement that function inside our class. So implement the listen function and we delete this. Now we have this underline here in red, which says as a reference name. That's because it cannot know if this T is gonna have a property called name. So it cannot know if we're gonna pass a type here which is gonna have a property name. So this is why we have now here. We've talked about this in our previous videos. Now to set up two upper bounds, we go at the end of our primary constructor and we type where. So we type the keyword where, and here we put where where T inherits player. So this is the first upper bound. So our T, whatever T we pass to our team class, it has to inherit from our player, and also, so we put comma, it has our T, so we put also T, it has to implement the interface listener. So these are the two upper bounds which has to be satisfied in order for our T to be valid. Otherwise, we're gonna show an warning. And now here we have an error and says type argument is not within its bounds. So we have bounds, not bound now, because the compiler knows that we have two bounds. And it says expected listener found Counter-Strike player. So it knows that the first condition is satisfied because Counter-Strike player extends from player, but it does not implement the interface player. But if I change this to, let's say that I change this to football player. So if I type here football player, now we don't have an error because both upper bounds are satisfied. Our football player inherits from the player class, and it also implements the listener interface. So this is our discussion about upper bounds, and you can use two upper bounds with functions also. In the same way, you will define the two upper bounds at the end of the parentheses of the function. One more thing to know here is that you can define a single upper bound, not in this way only by defining the upper bound in the header of the class, but you can define only one single upper bound also using the where keyword. So if I delete this T extends listener and I let here where T player, as you can see we don't have any error here. So it knows that this T that is going to be passed here, and here is a special case because this is counter variant. It has to inherit from the player class. So you can define your upper bound or your upper bounds using the where, or you can define one upper bound here by putting comma and you type player. So this is the same thing as having this. Yeah, so if I delete this, so you can have it like this if you want to have one upper bound, or you can have it like this. So, or you can define the only one single upper bound like this. It's up to you how we do it. So let's change this back to listener, actually to T extends listener. So this is our discussion about multiple upper bounds. This is how you can define for your type more than one upper bound. But before I end our video, let me show you how you can define two upper bounds for a function. And for that, I'm gonna go down here. I'm gonna create a function called, and here you need to put first the fun keyword, angle brackets, we put T. So this is how we define a generic function. I'm gonna call it add player, and I was gonna have a parameter called player. It's gonna be of type also t. Now to define two upper bounds for this function, we type at the end of our enclosing parentheses, we type where. So we type where. So where t inherits from player. This is the first condition. And t implements listener. So we put t listener. And then we put curly braces. So this function is going to take as an argument a type, but that type has to inherit from player, and it has to implement the listening interface. And if I call this function here, add player, and let's say that I pass here a Counter-Strike player, we need to pass an instance here, an object, so put parentheses, type player1. Now we get an warning here, an underline. So this says require listener found Counter-Strike player. So the compiler correctly figured out that our Counter-Strike player class inherits from the player, so it satisfies the first upper bound, but it does not implement the interface listener. So it does not implement the listener interface. But if I pass here football player, and we pass also an instance, so we put parentheses to call the constructor to create the object, and we put here a name, let's call it player1. Now we don't have any error because football player both inherits from the player class, so it satisfies the first condition, and it also implements the listener interface, so it satisfies the second upper bound. So both upper bounds are satisfied and we don't have any warning. So this is how we can define two upper bounds for functions, and this is how we can define two upper bounds for classes. So see you in the next video. So now it's time to start a discussion about access modifiers. And as the name implies, access modifiers are used when you want to specify how other people are going to access your code, or how other parts of the code can access your code. And there are 4 access modifiers in Kotlin, and those are the internal, the public, private, and protected. And I'm going to look at all of those in this video. But first, let's type the main function here because we don't have the main function main.kt, and I deleted the main function because I wanted to show you a shortcut for typing the main function. So if you just type main, you have a suggestion which says main, and if you press enter, it's gonna add the main function for you. So if I press enter, now I have the main function here. Now let's first look at the public keyword, and the public keyword is used when you want to allow all the other parts of the code to access, to be able to access your code. And all the functions and classes that we looked at are by default public. So if you go inside our classes file, and let's say that I declare here a function called, let's call it fun, get data, and it's not gonna do anything. I'm just gonna add the print line here. Getting the data. Now this by default is public, and that means that you can access this from another part of the code, or from another, you can access this actually from another file, because we actually did that. So if I type here, because they are implicitly public, you see that it's grayed out the keyword public because it says that it's redundant. So it's by default it's public. Now if I go here, now I can call that function here, but in order to use that function here, I need to import that code. So let's type here import, and I'm going to type com, I'm going to type the name of the package where that code is, example dot classes, and I'm going to put dot and asterisk to get access to all the code, not only to specific parts of the code. Now if I type here get data, Now I have a suggestion, get data from the com.example.classes package. So this one, so because it's public, now I can access that function from a different file, from the main file, even though it's declared inside the classes file. So we getting the data, so our code works. Now let's bring this down. Now let's look at the private access modifier, and the way we declared our function here is called declaring at the top level. And declaring something at the top level means that when your code is declared outside of a class or an interface, that means that that code is at the top level. So if you see this thing called top level, this is what it means. Now if I make this private means that this function is gonna be accessed, we're gonna allow this function to only be used inside the same file. So if you try to use this in a different file, you will not have access to this function. So if I go now in main.kt, now I have an underline, and if I hover over, it says cannot access get data. It is private in file. So basically, in other words, what it's saying is, hey, you declare that private, and that means that it's only accessible in the classes file. I cannot use that here. So if I call it here, let's say in one of our functions, so if I type, let's say here, get data, here I can use it because it's private, and that means that it's gonna be accessible only inside the same file. So we're gonna be able to use it inside the same file, but outside this file, in another file like the main file, we can't use it because it's private. So this is what private and public are as access modifiers with functions. And we can also have classes which are private, and we're not going to look at public classes because all of our classes are by default public. If you type the public keyword, it's going to be gray out, and it's going to say that's redundant. But if I make, let's say that I make this football, actually let's make the team class private to see what happens. If I make this, actually let's first call it here to see. So let's call it here val football team equals team of football players, and it's gonna have a constructor. First is gonna be the name, it's gonna be a football call football team, and we're gonna create some football players because now our list is actually our list is counter variant, and I'm gonna type here football player. Actually let's type mutable list of, and I'm gonna type here football player 1, football player 2. So now this code can be used as in our previous videos in this file, because we've imported this code here, and because it's public by default. All the classes and functions are public. But if I make this private, so if I type the private access modifier in front of our class, if I go now inside the main function, we have the same error now. If you hover over the underline of the team, which says cannot access team, it is private in file. So because it's private, it can only be accessed inside the same file. It cannot be accessed outside the file on which is defined. So this is the public and private with the code at the top level. But you're gonna look at the next access modifiers, and we're gonna look also at those access modifiers, and we're gonna look at them inside declare them on properties. So this is what we're gonna do next, because what we did now is we only looked at the top level. But before we look at access modifiers inside our classes, respectively before we look at access modifiers on our properties. Let's first look at another access modifiers at the top level, and that is the internal access modifier. So I'm gonna go inside our classes, and I'm gonna change now the class theme from private, so in other words, being accessible only inside the file in which is declared, to internal, to see what happens. So if I change now this to internal, now if I go here, now we don't have an underline, and that is because the internal keyword is used when you want to make a class or a function to be accessible only within the same module. And you may be wondering, what is a module? A module is basically a group of files which are compiled together. So if you go on the left hand side here and if you look at this OOP, this is a module. And in Kotlin you can have multiple modules. And the internal keyword means that this is only going to be accessible only within the same module. And because the main package is in the same module, then you can use it inside you can use that code inside here. But if it were to have another module, and if you create two modules, this will not be, you'll not be able to use this class in the second module. So this is how you can use the internal modifiers, and next we're going to look at how you can use those access modifiers and the protected access modifier. And I didn't use the access modifier protected here because the access modifier protected can only be used inside classes on properties. So if I type here protected, I don't have any suggestion. And you see that it's blue, so it's recognized as secure, but I cannot use it on classes. So it says modifier protected is not applicable inside. So you cannot declare the protected keyword, the protected access modifier at the top level. So you can only use it inside the classes. And this is what we're going to look at next. I'm going to create a class and I'm going to look at all of those access modifiers now. And we're going to look we're going to look at them on properties and how it's going to affect the properties which have those access modifiers. Now let's look at access modifiers inside our classes on properties. So I'm going to delete this code now because I don't need this code. I'm also going to delete the import because it's gray out, because you don't use any of the code from that package. So I'm going to delete this. And I'm going to go down here and I'm going to create a class called user. And I'm going to define the properties inside the class, not inside the constructor. So I'm going to type first var first name. It's going to be a string, and we need to assign a value. We cannot let this uninitialize, so I'm going to put an empty string, var last name, also a string. I'm going to assign also an empty string. Let's first look at the public access modifiers, and by default all the properties which are declared are public. So if you type here public, you'll have the same thing like at the top level, so it's going to be redundant because by default all properties are by default public. So if you put here public, now the public keyword is gray out because it's redundant. So if you hover over, it says that redundant visibility modifier. So I'm going to delete this. So this is about public. They are all by default public, so you don't need to declare them. They're not really public because you access them always through the getters and setters. Now let's look at the private. So let's actually create here a user, var user equals user, and I'm gonna type here user dot first name equals Alex, and user dot last name equals Dobin. Now, if I make one of the properties private, that means that I cannot access this property outside of the class. So if I put here private, now I have another line which says cannot access first name. It is private in user. And this is because now by making this private, we're not allowing anybody to access this property outside of this class, so we can only use it inside the class. So if I have a function, he'll call the update name, let's say, and let's type here new name. It's gonna be a string. Now here I can type first name equals, and you get the idea, but I cannot use it outside the class. So I cannot use that outside the class because it's private. So if I do the same thing here, if I type private, this is also now inaccessible. We cannot access it outside. But if you think about our discussion about the getters and setters, the getters and setters have the same visibility as the properties. So because now we made the property private, the setter is also private. So we cannot change its value because this is calling the setter here. So let's look at the next access modifier, and that is the internal. And internal means the same thing. That is going to be accessible only within the same model. So if I type here internal, now I can use it outside of the class. So I can type user.first name equals to Alex. So this is internal. Now let's look at protected. And protected makes sense if you think about subclassing, if you think about inheritance. So with protected, you cannot access this outside of the class, but you can access inside of a class from which you are inheriting, or on which you are inheriting. So if I put here protected, now this is not being, you cannot access this outside, because so if I type protected, it's also underlined. But if I create here new user, let's say class I don't know, VIP user, and if I put here let's inherit now from our user class, now it's saying that to make, you need to make this open. I forgot, so let's make it open. Now I can access the first name and last name inside our VIP user. So if I type here fun, let's call it print info, and if I type here print line, and if I type inside the print line first name, as you can see, you can use it inside the class, inside the VIP user class, because we are inheriting from the user class, and protected allows us to use its properties inside our VIP user class. So if I type here first name, I can use it. If I type last name, I can use it. But if you make this, let's look now at inheritance with access modifier. So if I type here private, and I type here first name, not that, so I type here first name, I can't, because it's private, so it cannot be accessed. So this is our discussion about access modifiers. This is how you can use the different access modifiers at the top level on function and classes, and this is how you can use them on properties to allow or to restrict the access on your code. So let's type it protected. So see you in the next video. So now it's time to start a discussion about packages and imports, and for that I'm going to open the project pane. And to open the project pane, you just go on the left hand side here up, and if you hover over, there is a shortcut to open the project pane. On Windows is Alt +1, and you'll see the corresponding shortcut on your system. So, or you can press on this project. So if you press, the project pane is gonna be open. But before you open that, let's explain why you'll need to use packages and what are packages. But let's start with the second one. So packages basically are some folders in which you can put your related code, because the way we type our code here is not the way in which you'll type our code in a real app, because you have the classes and the interface and you have everything in the same file. In a real app, you will have your code organized better, and you have your code separated in each package. So you have your classes in a separate package, you have interfaces in a separate package, and if you have a database, you'll have that also in a separate package, because in this way you better organize your code and you know where the stuff is. And now to create a package, you just open the project pane, right click on Kotlin, and you go to new, then you go down here, it says package, and now you need to give a name to our project, to our package. The usual name is com.example, and then the name of the package that you want specifically. So let's say that I want to put classes here, so I'm gonna call this com.example classes. Now this package with this name com.example.classes was created, and you can take all of our classes now, and instead of declaring them inside our main.kt, we can create a new file here, Kotlin class file. I'm gonna call it classes also. Press enter, and we can see now we are inside this package com.example.classes. Now I'm gonna press Ctrl V to paste this, and now we have our classes inside here. But now our classes are inside this folder, this package com.example.classes that we created. And now we can delete this from here, but now we will have some errors because we don't have now we don't have the classes defined inside our main.kt file, and we have this this red because it cannot the classes are not declared, so it cannot use them. Now what you need to do is that you need to import the classes from our new package, and let's create another package for the main file, for the main.kt file. So let's right click, let's create a new package, and let's call it com.example.main. so here we're gonna put our main.kt file. So let's put it here, click on refactor, and now our main has the main.kt file, and our classes package has the classes.kt file. Now we still have an error here, and let's create another package. Let's call this package com.example.interfaces. So we now when you say com.example.interfaces, you are inside the package com.example. So this classes package is a package inside the package com.example. This main package is a package inside com.example.main. You can create them separately, so you can think of another way of organizing this, but this is the standard way of creating packages. So com.example.interfaces, this is gonna be called, and then we're gonna put our interface. So I'm gonna right click, create a new Kotlin file. It's gonna be a file, and it's gonna be called interfaces, and here we're gonna put our interfaces. So we're gonna take our interface from here, Ctrl C, and paste it inside this package. Now we can delete this, but now we have all those errors because the compiler can't find where all of those packages are. And now, as you can see, we have this package com.example.main, because now our main.kt file is inside com.example.main package. So this is why you have here com.example.main. Now we have we have the class team in red, the player, the football player, all the classes, all the code that we had previously now is in red. This is because the compiler cannot find them declared. So in order to have them in order to be able to use the team class, the player class, and all the classes that we declare, also the interface, we need to import them. And to import something means, as the name implies, to bring that code inside our own package. So now, because the classes are inside the classes package, you need to import those classes inside our main package. And to do that, just you can hover over here, and the compiler is going to help you to import that. And you can click on this right button and click import, and now you can see it says import com.example.classes, or you can type yourself this, and that code is going to be imported. Now you need to import also the player class, and as you can see, so if you hover over here, it says com.example.classes.player. So it found the package where this player class lives. So let's also click on the right button, but it doesn't appear. And we can type here just import, and we type com where that class is, that example that classes that player. So now you have imported our player class, and now the error disappeared. But you can do this for all the classes, but there is a shorter way to do this. But let's type first import now com.example.classes, and let's import the football player. Let's type again import. So now we're bringing that code to be able to be now we bring that code to be able to be used inside this class. So import, now I'm gonna import the Counter-Strike player, which is also in the com.example.classes package. So if I Counter-Strike player, we're gonna import also the games player, and we get the idea. com.example.classes .games player, and now our code looks similar to what we had previously, just that we imported now all of this code from a separate package, so from a separate package. And you can click on this sign, and this is gonna do this to your imports, or you can keep plus to have this in the expanded form, or you can decrease this. Now we have the same code that we had previously. The only thing is that now you imported all of that code, and we didn't define all of that code again to be able to use. Just imported that code by using the import here and the package where that specific class is defined. But if you look at this, there is a lot of code just to, if you have 100 classes, what you're gonna do? You're gonna type import for all of them, and there is a shorter way to write this by using the asterisk sign. So you can delete this, and you can put at the end of the classes. So you can put here that, and you put asterisk, and that, what this means is bring me all the code inside this classes package. So inside this classes, go inside this classes package and bring me all the code. Let me use all that code. So now, as you can see, we have the same error as previously, because by putting the asterisk here, now all of that code was imported for us. We didn't need to type. Let's press Ctrl Z. All of this, we can just delete this and put here an asterisk sign. That asterisk sign, and that is going to bring all of our code. So this is how you can use packages and imports in your code, and see you on the next video. Also, I should say that packages also help other developers to see where our code, by organizing better our code, they can see where our code is. So if you click on this arrow in front of our main and in front of our interface and in front of our classes, and if you look at this code for the first time, you know, here are the classes, here are the interfaces, here is the main function. So visually you can very easily determine where the developer who created, let's say, this program put the code. So this is also helpful for other developers, and it also increases code reusability, because you can see just by putting the asterisk sign at the end of the package from which you want to import, you can get all of that infrastructure or all of that code inside our own package, and can use that can use that in our code. So this is how this is why you need to use packages and imports. So if you want to get all the code from a specific package, just type the name of the package dot and you put asterisk, and you will have access to all of that code just by typing one line of code. So this is our discussion about packages. This is why you need to use them. They help you to better organize your code for you and for other developers, and they also increase code reusability because you can import a lot of the code. You can import a lot of can import big chunks of code inside your own code just by typing a line of code. So see you in the next video. So now it's time to start a discussion about exceptions, but first I'm gonna create a new project. I'm gonna call it exceptions. For the language, select Kotlin. For the build system IntelliJ, make sure to have the JDK selected, and I'm gonna check this little box to have the main function auto-generated for us. So I'm gonna click on create now to create our project, and I'm gonna delete this code inside the main function because we don't need this code. And I am also gonna hide the project pane. Now, what are exceptions? Exceptions are errors which happen during the execution of your code. For example, let's say that I have two variables. One is going to be called A and it's going to have the value 5. And the second one is going to be called B and it's going to have the value 0. Now, if you try to divide the 5 by 0, you'll get an exception because you cannot divide by 0. So if I add here a print line and I type here A divided by B, now if you run this code, we'll get an error, we'll get an exception, which is going to say that this which is exception in thread main Java lang arithmetic exception divided by 0. So you cannot divide by 0. Another exception, another error could be, let's say that you try to get an element from an array at an index that doesn't exist. So if I delete this code and I declare an array called numbers, and I call here array of, and I pass here only a number, and let's say that down here I add a print line, and here I type numbers square brackets 1. Now if we try to run this code, you'll get an error because we have no element at the index 1. The index 1 is not even existing. So we get exception in thread main java.lang array index out of bound exception, index 1 out of bounds for length 1. So it's saying that this index doesn't exist. We have no element at this index. Now what we can do, instead of letting the exception to be thrown and have our app crashed, we can surround our code which can potentially throw an exception with a try and catch block. So what we can do is, let's say that I press Ctrl Z to have the code that we had previously. And what I can do here, I can say try, so try to execute this code. So try to execute this code, divide by 0. And if something happens, then catch that error, so we put here E from exception, and we put what kind of exception is gonna be catched by our try and catch block. So we put here arithmetic exception, and we need to put curly braces, and we add here a print line, and we're gonna call E dot. So let's put actually something more specific. Let's say you can't divide by 0, and here you can put $sign E dot message. And this is the exception that we catch. So if I run this code now, because I surrounded our code which will throw the error, now we get message you can divide by 0. You can divide by 0 and we get divide by 0. So now we get this instead of crashing our app. And this can be particularly good if you know that a code could throw an error, but you're not sure. So you surround your potential code which can where that error can happen, and you can say try, and if that happens, then catch that and show a message or do something with that thing. Now, the problem with this try and catch is that if you have some code here, let's say if I had a print line here, which is doing something, let's say divide by 0, and now if you run this code, you'll see something interesting. You can divide by 0, and you don't get this print line, because when the exception is thrown, so when this line of code is executed, the try and catch block is going directly to the catch, and the code which comes below of our code, which is where the error happens, is not executed. So if you have something important below here to, I don't know, maybe you need to close a database or something, that code is not going to be executed. So this is not good. What we can do is we can add a finally block, and finally block is used when you want to execute some code, no matter if the exception happens or if the exception does not happen. So if I put this now in the finally block, and this can be some code which you want to have executed, no matter if the exception is thrown or not. So now if you run this code, you can divide by 0, so you get our catch, because it's throwing the exception, we have the error, we can divide by 0, and then we get divide by 0. So now we get our code executed, because the finally block is going to be executed no matter what, no matter if the exception is thrown or not. So if I put here 5, let's say, and if I run this code, now we have 1, because this is because we have 5 divided by 5, and we have divided by 0. So the finally is always executed, no matter if the exception is thrown or not. And let's close this, and let's change this back to 0, so to have the error. And you can use the try and catch block also as an expression. So let's see how we can do that. Now, to use try and catch as an expression, we just define here a variable called result, and we're gonna assign our try and catch to our variable result, and the last line of code in the try or in the catch is gonna be assigned to our variable result. So here I'm gonna put a divided by b, and here I'm gonna put 0. So these are the values that's gonna be returned by our try and catch to our variable result. And down here I'm gonna output in the console that value. So I'm gonna add print line here, and I'm gonna type result. Now if you run this code, you can divide by 0, so our catch is called, and get this divide by 0 from the dc.message. Then we get our code which is called from the finally block, because the code from the finally block is called no matter what, irrespective of what is happened, irrespective if the exception is thrown or not. And then we get 0 because our catch block is called, and the last line of code in the curly braces in the block of code of the catch is assigned to our variable result, similarly to the way we use if then as an expression. But if I change this to 5, now if I run this, now this is gonna be assigned to our variable result, because that is the last line of code, and we get in the output 1, because now the exception, now the code inside the try is executed and it outputs 1. Then we get divided by 0, because the finally, as I said, is called irrespective of what happens if the exception is thrown or not. then this a divided by b is assigned to our variable result, and we get 1 again. So this is how you can use try and catch as an expression, and this is how you can use try and catch to try and catch exceptions in your code. So see you in the next video. Now it's time to start a discussion about lambda expressions and higher order functions. But first I'm going to create a new project. I'm going to call it lambdas. I'm going to select Kotlin for the language, build system IntelliJ, make sure to have the JDK selected, and also I'm going to check this box to have the main function generated. Now let's delete the code inside the main function because we don't need this code. Let's hide the project pane. Now, what are higher order functions? If a function can accept functions as parameters, that is called a higher order function. If a function can return a function, that is also called a higher order function. If a function can do both, that is also called a higher order function. Now, what are lambdas? Lambdas are just functions without no name. And we're going to look at some examples with those. But first, let's create a function called add in the traditional way. So we're going to type here fun add is going to have two parameters, int, so it's going to be, they're going to be of type integer, and it's going to have a body, and it's just going to output in the console the sum of a plus b. So we're going to type here quotation marks, and we're going to put a plus b equals $, curly braces, a plus b. So this is gonna return, this is gonna output in the console the sum of a plus b. So if I call this function here add, and if I pass here two numbers 5 and 10, now if I run this, we'll get 15. So we get a plus b equals 50. So this is how we're doing in the old way. Now let's see how we can achieve the same thing using a lambda function. So what I will do first is that I will first show you how to assign a lambda function to a variable. So I'm gonna type here val. I'm gonna call it my lambda. Now, to declare a lambda function, we just put curly braces. Then we need to type the parameters. I'm going to explain this immediately. So we put here a. I'm going to be an integer, b. So those are the parameters of our lambda function. Now I'm going to put dash and arrow, so the greater sign. And now I'm going to define the body of this function. So what comes on the right of the arrow is the body of this function. So we type print line, and we're going to put here a, let's actually put quotation marks, a plus b equals $, put curly braces, a plus b. Now, what we did here is we define a lambda function. So what is inside those curly braces, lambda function. Those are the parameters of the lambda functions, similar to what we have here. So what we have here is what we have here. Those are the parameters, and this is the body. This is the body of this function. So what we have here on the right of this greater on the right of this arrow is what we have inside here. So this is the body of this lambda function that we have here. So what we do is just print. We're gonna output on the console the sum of a plus b. Now I can call this lambda function now in my code. So if I type here, let's say my lambda. Now we put parentheses, and here we need to, as you can see, we have int and int. So I need to pass some parameters. So I'm gonna type here also 5 and 10. So let's actually put the different numbers. Let's put 8 and 9. Now if you run this code, now we get a plus b equals 17, and this we got this using our lambda function. So we We did this not using our add function that we have here, but with our lambda function. And again, those are the parameters a and b, like we have here. And on the right hand side of this arrow, we have the body. So we have this. So we have the body of this lambda function. And we assign this lambda function to our variable my lambda. And we call that inside our code here. And it outputted 8 plus 9 is 17. So this is using a lambda function. And if you hover over this my lambda function, it says that val my lambda. And here you have the data type. What kind of type this function is. And we're going to talk about this immediately. Now, if you hover over my lambda, it says that you have a val my lambda and you have colon int, and then you have the arrow sign and you have this unit. So what is the meaning of this? So this is the type of this lambda function. So this is what the compiler inferred to be the type of this my lambda function assigned to my lambda variable. So here you have my lambda, and it takes two parameters of type int, and on the right here of this arrow it says unit, and this means that this function is not returning anything, so it's returning nothing. This is what this is the meaning of this. So similar to the way you have a variable here called text, and it's gonna be of type string, and we're gonna assign a text here. So similar to the way this variable has a type and the type is string, in the same way this lambda function also has a type, and the type is those ints here, and and it has also this greater. It has this arrow and unit. So it's saying here that this function is gonna take two integers and it's gonna return nothing. So this is the type. So lambda functions have type. And the type for a lambda function can be inferred, as you can see here. We didn't declare here, we didn't put here colon, int, and then dash, greater sign, unit. So we didn't type this explicitly here because in the same way that this variable string can be inferred, so if you hover over here, it says that remove explicit type specification. In the same way, this lambda function can also be inferred to be of type int, and is gonna return unit, because the compiler can figure out that. But there are scenarios where we need to specify the type of a lambda function, and we're gonna look at those. Now, let's say that this add function that we have here is gonna take as one of its parameters a lambda function, and to do that, we first need to define here that this is gonna take a lambda function, and to do that, we type here lambda, let's say, or we can choose another name. Let's call it action, and here we need to specify the type, because now it can't infer the type, it can't figure out what type is, because we don't have here an expression, don't assign here the actual function like we did here. And here it inferred the type because it looked on the right, and it saw that this is of type int, and it's gonna return nothing. Here we need to specify the type. So I'm gonna specify here, let's say this is gonna be an integer, and it's also gonna return nothing. So we put here dash, greater than sign, and the type unit. So what we say here, that this is gonna be a lambda function, is gonna take as a parameter one integer, and it's gonna return nothing. This is what we're saying here. And down here we're gonna call that. So we're gonna type action. Now we need to put parentheses the same way and you see now it's expecting an int. So we type here a plus b, right? Now if I delete this, let's say that I delete all of this code. Now if I type here add, now I need to pass two numbers. Let's say that I pass 5 and 10, and now we need to define here the lambda function, and we can define it like we have it previously by typing val my lambda, and we put equal, put curly braces, and here we're gonna define a parameter. It's gonna be of type int, and then we put what is going to be the body of this lambda function. So we put dash greater than sign, and the body is going to be just to output whatever that parameter is going to be a in the console. So we type here a. Now we can assign that lambda function here to this parameter, my lambda. So type my lambda. So we assign to our parameter action my lambda function that we created here, and we assign to this variable. So now if I run this code, we get 15. So this is correct. We get 15, and we did that by assigning my lambda function to my lambda to my action parameter that was defining, and this is going to be a lambda function. But what you can do with lambda functions is that if the last parameter in the function or in the header of the class, in the constructor of the class is a lambda function, you can declare the lambda function outside. But first let's see how you can put it here. So what you can do, because this is an expression, we can delete this, and we can take this, press Ctrl C, and we can paste here directly this. So now if I run this, because this is an expression, now this is gonna be assigned to this action, my lambda, and it's gonna output 15. And we did this like this is similar to object that when you look at anonymous classes, because this now is also anonymous in the sense that we don't have here a name, so we don't assign this to anything, we just define it here, so it's an expression. So you get also 15. So now if I close this, what you can also do if the last parameter in the function is a lambda function, and or if the last parameter in a constructor is also a lambda function, you can put the lambda outside the parentheses of that function or of that class. So what I can do here is I can delete those, and I can put here parentheses, and now I can press enter, and this is gonna work fine. So let's actually put it on the same line. So now as you can see, the lambda is outside the parentheses, not defined inside the parentheses that like we did, because if the lambda is the last parameter in a function or in the constructor of a class, it can be defined outside of that outside of the parentheses. So if it's the last parameter, so if I run this, now you'll get the same output. We get 15. So let's close this. Now let's see how we can change the code that we had when we talked about object expression with lambda functions. So I'm gonna delete this code, and now I'm gonna speed up now the things a little bit, because we're gonna add that code that we had previously in a previous video. So I'm gonna type class button. So this is the code that we had in the video when we talked about object expressions. Now I'm gonna create here the two buttons, val login button, it's gonna be a button, it's gonna have the login text, the ID is gonna be around the number, and here you need to type the on-click listener, and here I'm gonna type object, and gonna implement our on-click listener. So you need to click on this red bulb, implement members, and implement on-click. Now let's copy this, let's paste it here, and I'm gonna call this sign up. Now let's also change the ID. Now what we have here is that we have an object expression, we have anonymous classes, and by using the object keyword, and let's press Ctrl Alt to format the code, and we implement that on-click function on this specific button, or for the login button and for the sign up button. But to do that, we use the object keyword, we implemented that from the interface to override the interface here. And there is a shorter way to achieve the same thing using lambda functions, because our lambda functions and the code that we have here, respectively our object expressions, because object expressions and lambda functions are both expressions, so they can be assigned to a variable. We can define here a lambda function instead of the one-click listener interface, and we can pass a lambda function to our object, which is going to be created with this class, or to our object, which are going to be created with this class. So I can delete the code that we have here. So I can delete this. Here also, I'm going to delete this code. Now what I can do is I can change this from a one-click listener let's also call it one-click listener, but it's gonna be a lambda function. So let's define a lambda function, and here we're gonna put parentheses because this is not gonna take any parameters. Our one-click function doesn't have any parameters. Then we put dash arrow and gonna return unit. That means that this function is gonna return anything. So I'm gonna delete this. Now, because our lambda function is the last parameter inside the header of the class, we can define it outside. We can define it outside the parentheses. So I can put it here. So I can put here curly braces, and that's all. We have our lambda function there, and I can put here also. But if you hover over, we have this underline. So it says move lambda function argument out of parentheses. So let's click on this, and let's click on this also. So now, here we can add the code to log in the user if this button is clicked. So let's put a comment here, login user, and sign up the user. So these are, now we achieve the same thing that we had previously, respectively. We have a particular behavior when one button is clicked, when the login button is clicked, it's gonna execute the code inside this lambda function, and when this button is gonna be clicked, it's gonna execute this code inside the lambda function. And we did this now using the lambda function and not using the interface and the object keyword and implementing that. We did it by declaring our last parameter as a lambda function. Now let's actually look at Android Studio to see how Android Studio suggested us to change our code that we had for our buttons, the one-click listener that we had, to change our code from a object expression to a lambda function. So if I open Android Studio, as you can see, we have an underline here, and if you hover over, if you click on this yellow box, convert to lambda. So we can change that to a lambda. So now this was changed to a lambda function. And if you hover over this, it's also saying the same thing. So convert this to a lambda. So let's convert it to lambda, but let's put the code one line. So now we have the same code, that now we have the lambda. So this is the last parameter inside this function set on click listener, because it can be put outside the parentheses. So this is our discussion about lambda functions, and see you in the next video. Now it's time to look at the it identifier inside our lambda function, and it is the implicit name of a single parameter inside the lambda function. So let's look at an example with this. So I'm going to create a function here. It's going to be called uppercase. So it's going to uppercase the letters of a certain parameter. So we define here the parameter is going to be called str, it's going to be of type string. And here I'm going to define a lambda function. I'm going to call it my function, my fun. And now here we're going to define the type of this lambda function, and it's going to take one parameter of type string. Then we put dash greater than sign, and it's going to return a string. It's going to return the string uppercase. So we put curly braces and press enter. And here we type val let's call it uppercase word, put equals, and it's gonna be equal to my function, so my lambda function. Now we put parentheses and we pass our str, and this is gonna return the text uppercase. Let's actually hover over here. Alright, so let's add the print line here, and we type here uppercase word. Now here we're gonna call our function uppercase. We define a word, let's say hello, with lowercase letters. Then we define our lambda function. So we put curly braces. We type the parameter. So let's type here, let's say, and here we define the parameter for our lambda function. So we define, let's call it s. It's gonna be of type string. And we're gonna type here dash greater than sign, and here we're gonna type s dot uppercase. So this is our lambda function. Now if you run this code, you're gonna see our text uppercase. So we get hello uppercase in the console. And if you look here, if you hover over, because you have an underline, the lambda arguments to be moved out of parentheses. So this is the first thing, that this can be moved out of parentheses because the last parameter inside the higher order function. And now we can use when you have only one single parameter in your lambda function, instead of using instead of defining the parameter here then also you can delete the dash arrow. So you can delete the dash arrow, and here instead of putting s, we can put it. So it that uppercase, and now I can delete this arrow, delete the string, and let's do it. So now this it is it's like having our s, but this it is the implicit name for a single parameter inside the lambda function. So now if you run this code, now you'll have the same output, just that now it's more concise and we have only this it identifier. So you get also hello. So this is how you can use the it identifier with lambda function. See you in the next video. Now it's time to start a discussion about scope functions. So what are scope functions? Scope functions are functions which can be called on almost any object inside your code. And what those scope functions are basically doing is the same. They execute a block of code on an object. What's different is how this object becomes available inside the block and what is the result of the whole expression. The scope functions do not introduce any new technical capabilities, but they can make your code more concise and readable, as you'll see by looking at some examples. And because scope functions are very similar, choosing the right one can be a little bit tricky. And the question which arises is how you can distinguish between them. There are two main differences between scope functions. First is how you can refer how you refer the context object, and that is the object on which the scope function is called. And you can refer the context object either by using the this keyword or the it identifier. So this is the first difference. The second difference is the return value, because the scope function can return a value, and the return value can be either the context object, and the context object is the object on which the scope function is called, or the lambda result. And we'll see what all of this is in this video. And first I'm gonna create a main function, because I deleted the main function here. And to create the main function, just type m, and IntelliJ is gonna give me some suggestion. You can choose main, the first one, or you can choose main a, and that is gonna be the main function with the args and the array of strings. So I'm gonna choose the first one, and I'm gonna create a class down here. It's gonna be called user, and I'm gonna define I'm not gonna define the properties inside the primary constructor. I'm gonna define the properties inside the class. So I'm gonna type here var first name, and I'm gonna assign some default values. I'm gonna put equals, gonna be an empty string, var last name, also an empty string, and var age, I'm gonna put -1. Now here I'm gonna create an user, so I'm gonna type val user, I'm gonna put equals user. We need to call the primary constructor, but we don't have any properties because the properties are defined inside the class. And now if you want to define values to our properties, first name, last name, and age for our user object that we create, we need to type user dot first name. We did this in a previous video, equals Alex user dot last name equals Dobinka, and user dot age equals 23. And this is fine, but what we have here is code repetition, because we have user dot first name, user dot last name, user dot age, and imagine if you have hundreds of properties, you'll have to type user and user again and again. And with a scope function, specifically with the with scope function, we can make this, we can reduce this code repetition by using the with scope function. And the with scope function, you can refer the context object on the with scope function using this, and the result, the return value of the scope of the with scope function is the lambda result. But let's look how we can use. So actually let's put that code back to see exactly. So if I type here with, and here we need to pass the object on which you want to operate. I'm gonna pass our user object, and the next parameter is the lambda function. So we put curly braces and press enter. Now, because the with scope function, as I said, scope functions are used to make our code more concise and readable. Now we can avoid typing user.first name, user.last name, and so on, and we can just type here this, because this is how you can access the user object inside this lambda function, inside this scope function with this.first name equals Alex, this.last name equals Tobinka, and this that age equals 23. Let's press Ctrl Alt L to format the code, and now we have the same thing, but now we're using the this keyword, and we didn't use the user again and again. And because Kotlin is about conciseness, we can also remove the this keyword, because it will be generated under the cover. So we can delete this, also here, also here. And as you can see, now we don't need to use user.first name, user last name. We can just type the first name, last name, and age, and you can assign the specific values to the properties. And now I can delete this because I don't need this. Let's press Ctrl Z. Let's bring this up a little bit. Now let's look at the return value of this scope function, and I said that the return value of this scope function is the lambda result. So this scope function can return something. So the lambda result means that this scope function will return whatever is the last line of code. So if the last line of code is an integer, and if I type here val result, now if I hover over the result to see what type it is, you see that the result is of type of integer, because this is the last line of code, and the last line of code is going to be the value which is going to be returned. If I put here a text, let's say that I put here text, the lambda result, so the value which is returned, is going to be a string. So we have a string. So this is what lambda result means, and the value that is going to be returned specifically with the with scope function is going to be the last line of code. And you can also return the object, and to return the object, because you can refer the object using this, we can type here this, and now what is going to be returned is going to be the user object. So if I hover over here, now I have user. So this is what the lambda result is. The last line of code is going to be returned. Now next we're going to look and now you see how this makes our code more concise and more readable. And next we're going to look at the next scope function, which is the apply scope function. So let's delete the with scope function and let's look at the apply scope function. And the apply scope function, you can refer the context object also using this keyword, and the return value of the apply scope function is the context object. So the object on which the scope function is called is gonna be the object which is gonna be returned by the apply scope function. And we can call the scope function by, we can call it on an object. It's not like the with scope function which can receive the object. So we type here dot apply, because we're gonna look at the apply, and here you can type this dot first name. So similar to the with scope function, Alex, this dot last name equals Dobinka, and this dot age equals 23. So this is similar with the with scope function, but the difference is that it cannot receive you cannot receive a parameter. You need to call it on an object, so you call it on the user object that we created here. And we can also remove this, because this will be generated under the covers. And now the difference is that the return value, so if I delete this just to show you, the return value is this whole expression. So this entire object is going to be returned, is going to be the return value. So if I put here 23, let's say, I have this, and it said this expression is unused because this is not going to be returned. So to show this more clearly, let's type here val user. So let's put equals. Let's press Ctrl Alt L to format the code. And now if I hover over here, you can see that this is a val of user. And if I type here 23, let's say, this is still an user, because the return value is the context object, and that means that the return value is the object that is created here, so the entire object. So this is how you can use the apply function, so to provide some values to the properties. And now down here you can use the with scope function to print those values in the console. So you can type user, instead of typing user first name and last name and age, you can type here print line, and you can type first name. Let's press Ctrl D 2 times, and you can put here last name and age. Now if you run this code, we get Alex, Dobinka, and 23. And now you can see here clearly how scope functions can make our code more concise and readable. And with the apply function, we defined some values to our properties. With the with, we output them in the console without using that user that first name and doing that repeatedly. The next scope function, and again the return, I'm gonna repeat this, the return value of the apply scope function is the context object. So it's the object on which the apply function is called. So it's the object that is created here. So the user object is returned. So it's in contrast with the with scope function, which returned the lambda result. So whatever was the last line of code. So this is the difference between the two. And also the fact that the with scope function receives the object on which it wants to perform the operation. Here we call on the object the apply function. So but the main difference is what they return. So this returns the context object, the object on which is called. So, and this returns the lambda result. And next we're going to look at the also scope function. And the also scope function is used when we want to do some additional operation on an object after you instantiate it or after you created that object. So I'm going to look at that next. So now let's look at the also scope function. And for that, I'm going to move the properties that are defined inside the class, inside the primary constructor. So I'm going to delete those. And I'm going to define them inside the primary constructor. You'll see immediately why. So I'm going to type val, first name of type string, val, last name of type string, and val age of type int. Now I'm going to delete the with scope function because we don't need this, and I'm also going to delete the apply scope function because we don't need this. Now the also scope function is used when you want to perform an extra operation after you initialize an object. So let's first initialize our object. So let's pass some values to the property of the primary constructor. So I'm going to type here Alex, Dobinka, and 23. Let's press Ctrl Alt L to format the code. Now let's delete the curly braces because we don't need those curly braces. And I'm gonna declare this class as a data class because I want to have the toString function auto-generated to have the string representation of the class. Now if I want to print the value of the properties of this class, because now it's a data class, I can just type here print line, and I can type here user. And now if you run this code, we get user, first name Alex, last name Dobinka, age 23. So we get the string representation of the object. But in order to get the string representation of our user class, we had to first initialize the object, then we store that into a variable, and then we use the print line to output that in the console. And with also you can do this in a more concise way. So you can delete this. We can also delete the variable on which the user object is created, and I can type at the end of our object which was initialized that, and we type also. So we type also and you press enter, or you just type, you can type also yourself, and you put the lambda function. Now here what I can do, because here now also scope function, you can refer the context object, so you can refer the object on which the lambda function is called using the it identifier. So what we can do here is you can type print line, and we can put here it, and it is the user object which was instantiated. Now if you run this code, we get user, first name Alex, last name Domingo, age 23, and this is using the also scope function, and this is more readable and concise, and we did that by using the also function. Now what is the return value of this also function? The return value of this also function is the context object. So if I type here val result, if I put equals, if I hover over the result, you can see the type is an user. So what the return value of the also function is the object itself. So it's the object on which the also function is called. So this entire expression is going to be returned inside our variable. So this is the also function, and again we can delete this because this looks more beautiful and concise. Next we're going to look at the let scope function. So let's close this. So let's look at the let scope function, and for that I'm going to delete this code because I don't need this code. And we generally use the let scope function to avoid null pointer exception. So let's declare here a variable. Let's call it text, and it's going to be a nullable variable. So you put the exclamation mark here, and we assign null to it. Now if we try to output this variable in the console, we get a null pointer exception because we assign null to it, so it has no value, so the compiler doesn't know what to do with that. But with a let scope function we can avoid that. We can print that, and we type text, so the object on which you want to call the function, and we put that, and we type let, and we press enter, and within the lambda, now to refer the context object, then to refer the object on which the function is called, the scope function is called, we use the it identifier. So we type here print line it, so print the value of the text you're saying here, in other words. But this will still throw a null pointer exception if I run this. So if I run this, we get null. And let's close this, and to avoid this we need to use the let scope function along with the safe call operator. So we need to put at the end of our variable, we put question mark dot let, and then, so what we're saying here, let execute this block of code only if this value, this variable, the value of this variable is not null. Now if I run this, we don't get nothing because this is not now executed, because we said here execute this this code, the print the code inside the curly braces, the code inside the lambda, only if it's not null, and because it's null, it's not executed anything. But if we assign down here something to our text, let's put here equals name, let's declare it as a var. Now if I run this, now we get name because it executed the code inside the scope function of the lambda, so we executed this code, and the code is to output the value in the console, so you get name. And generally this is how you're gonna use the let function. You're gonna use along with the safe call operator on variables which are nullable, but it can be used in other cases too. And now next we're going to look at the next scope function, and that is the run scope function. But before we do that, let's talk about what is the return value of this scope function. And the return value of this scope function is the lambda result, and that means that whatever is the last line of code, so if it is an integer, if it is a string or a char, that is going to be the value which is going to be returned. So if I put here let's say text, not like that. So if I put here text, now if I put here val result equals, now this is gonna be a string, a nullable string. So this is how this is what the lambda result is, whatever is the last line of code. This, if as I said, if it is an integer or a string, that is going to be returned by the scope function. So now let's look at the run function. Now let's look at the run scope function. For that I'm going to delete this code because we don't need this code, and I'm going to create a user, val user, but it's going to be a nullable user, and I'm going to assign null to it. So I'm going to type user nullable equals null. Now the run scope function is a combination of with and let function. So let's type the with function here, scope function. So let's type user, and let's type print line, first name, let's press Ctrl D, let's change the last name, and to age. But now we have a problem, and the problem is that this can be null, and we assign actually null to it. But because this is this is a nullable now user object. We cannot output this in the console because we have another line which says that only safe call, so you need to use the safe call or the not null assertion. And the only way to get around this and to get the values, to get the properties outputted in this way in the console is to use a run function, a run scope function. And to use a run scope function, you just type user, we put the safe call operator dot, and you type run, and inside the run you can reference the object, the context object, using this. But because we looked already at this can be omitted, you can type directly here. You can type here print line first name. Let's press Ctrl D, and now we don't have that underline that we have here. So print line last name and print line age. So this is what the run function is. It's a combination of let and with, and the return value is the lambda result. So whatever you type here, so if you type an integer and if you type here val result, then if you hover over here, this is going to be an integer, a nullable integer. So whatever you type at the end of the whatever you type as the last line of code, that is going to be the type that is going to be returned by the scope function. So this is what the run scope function is doing. It's a combination of both with and let, and this is how you can use it. So this is our discussion about scope functions, and see you in the next video. Now it's time to start a discussion about threads, but first I'm going to create a new project. And now the window for creating a new project looks a little bit different because the JetBrains, the makers of IntelliJ and the makers of Kotlin, have released a new version of IntelliJ. And now the window looks like this, and personally I found this more intuitive. And here you select a name. I'm going to call it, here you give a name, threads. And for the language, select Kotlin. For the build system, select IntelliJ. For the JDK, make sure to have the JDK there. And I'm gonna check this add sample code, and that is gonna generate the main function and the main.kt file for us. So click on create. Now our project is gonna be created. And I'm gonna delete this code because I don't need this code. And also I'm gonna hide the project pane because I don't need the project pane. So now, what are threads? Threads are a unit of execution within a process, and every program that you create has at least one thread, and that thread is called the main thread. And the process is also called an application. This is your program. And our code is executed on that main thread. And now you may be wondering why you will need more than one thread. That is because our code is executed line by line. So if you have a line of code which is read, it has to read that line of code to finish whatever that line of code is doing. So if it is doing some hard operation like getting some data from a database, it will do that, and it will not execute the next line of code until it finishes this line of code to get that data. And because our code is executed, let's say we just want the main thread, that it will block the execution of the rest of the code. And by creating another thread, we can put that hard work on another thread, and we can leave the rest of the code to be executed normally. One way to think about thread is like having one road, and on this road there are cars which are moving, and if one of the car stops, all the cars on the road are going to be stopped. And creating another thread is equivalent to creating another road to put that car on that road, and you don't block the traffic for all the cars. So this is how you can think about threads. And let's say that I have here to show you hello world multiple times to see this. So I'm gonna press Ctrl D, a few times here. And I'm gonna put hello world 1. Now if you run this code, you'll see in the output hello world 1, 2, 3, 4 and so on. So we get hello 1, 2, 3, 4, 5, 6, 7, 9 and we get 11. Now this code is executed on the main thread, and we can get access to the main thread by typing thread. So let's say that I type here thread because we can put the thread to sleep, and this sleep is gonna mimic, let's say, the getting some data from a database. So we can put the main thread, the thread on which this code is executed, on sleep for a few seconds. So we put thread.sleep, and here we need to pass as an argument the milliseconds. So let's put 5000 milliseconds. That means 5 seconds. So if you run this, our code is gonna be executed until hello world 5, then it will pause for 5 seconds, and after that it's gonna execute the next line of code. So you look here, we have 5, then it stays, it passes 5 seconds, and then it outputs hello world 5, 6, 7, 9, 10 and 11. So this here could be getting some data from a database, and if that takes a lot of time, it will block your execution of your code, and we don't want that. Now to avoid this, we can execute this hard work, which is now we just type thread.sleep, but let's imagine that you have a function which does something, get some data from the database, let's say. You can create another thread to put this working to be done on that thread, and we don't block this main thread, and this main thread is going to execute this code that we have here. So to create a thread, let's go here, we just type thread, and we select this, which has that block of code, and inside here we put our code which we want to be executed. So this code is now going to be executed not on the main thread, but on our second thread that we created there. So now, as you'll see, our code is not going to be blocked by this thing thread.sleep. As you can see, now it outputted the code without that pausing. And to show that this actually works, I'm gonna put here a print line, which is gonna say, let's type here print line, thread 2 has finished. So now if you run this, now our code is executed normally on the main thread, and after 5 seconds we get thread 2 has finished. So we get, in a way, our code executed in parallel. So we can do more than one thing at the same time. So this is how you can use a thread to do some work on the background. And there is more to talk about threads, but I'm not gonna do that because there is something else that we can use in Kotlin to do this work on the background and or this work in parallel, and that is called coroutines. So see you in the next video. What are coroutines? Firstly, in order to understand coroutines, you need to understand how your application works when the user launches the application. So by default, when you launch an application, a default thread is created, the main thread. And this is the thread on which all the operations are performed. And the operations are performed in a linear fashion, line by line. What that means is that the next line of code has to wait for the previous line of code to finish execution. And those operations are small operations like UI interaction, mathematical operations, small logical operations. So on the main thread we perform small operations. Now, what about the long and heavy operations, such as the ones which require the use of internet, like upload or download a file, loading or displaying an image, or running some heavy database queries? Well, if you run these heavy operations, because the code is executed in a linear fashion, the next line of code will have to wait until this heavy operation is done. And that will block the main thread. So the main thread will not be able to do anything else while it's performing that heavy operation, and this will appear to the user like the application has freeze. And if the main thread remains blocked for a longer time, the app will crash. Therefore, running those heavy operations on the main thread is not recommended. To solve this situation, we have a solution. Instead of using the main thread to perform those long operations, we can create background threads to perform those long operations. We can create a thread to perform network operations, we can create another background thread to download the file, and we can create a background thread to perform database queries. By doing this, now the main thread will become free for the other small operations. Those background threads seems to be like a solution, but there is a limit of how many background threads you can create, because the device will run out of memory if you create too many, and the application will crash again. Therefore, creating many background threads is not a solution. So what is the next solution? And here comes into action coroutines. So when we use coroutines, we don't have to create so many background threads for each operation. Instead, we can just have one background thread on which we can launch a coroutine. So you can launch a coroutine to perform the long heavy operations like uploading a file. You can launch another coroutine on the same background thread to do some network operations. And similarly, you can launch another coroutine to download the file. And you can have more coroutines to perform other long and heavy operations. With just one thread, you can perform so many heavy operations. So this is what coroutines are. They are like threads in the sense that they can run in parallel, they can wait for each other and communicate with each other, but they work within a thread. They are not threads. And you can create thousands of coroutines without any memory problem. Now, how to use coroutines? To use coroutines, you need to first create a Kotlin project. So I'm going to open IntelliJ IDE. Click on Create New Project. I'm going to call it Kotlin Coroutines. For the language, select Kotlin, and for the build system, now select Gradle. And after I selected Gradle, this option down here, Gradle DCL, appeared. From here, select Kotlin, and then click on Create. Now our project is going to be created, and also you should make sure that you have internet connection in order to be able to have the project created. Once the project is created, just go on the left hand side of the project pane and double click on build.gradle, because here we're going to integrate our coroutines, and we'll go inside here where it says dependencies, and here we're going to integrate our coroutines. And here you need to paste this statement, this one. So I'm going to copy this, and this is going to integrate coroutines in our project, and I'm going to paste it here. Now this on the top, this icon now appears here. So if you click on, if you hover over, it says load Gradle changes, and this is going to integrate the coroutines and it's going to apply the changes. So I'm going to click on this icon. Just wait a little bit. Alright, now our project is ready, and now we can use coroutines. But first I'm going to create a file. So click on src, click on main, right click on Kotlin, go to new, and select Kotlin class file, select file, and I'm going to call it main. And press enter. And now we have our file. And now I'm going to start a discussion about coroutines. Now I'm going to close the build.gradle file because you don't need this file, and also I'm going to hide the project pane. And I'm going to add the main function, so I'm going to press M, press enter. And by default the main function and the code within the main function is executed on the main thread. So let's add a comment here, executed on the main thread. So let's add a print line here, which is going to say main program starts. Let's put colon, $, and we're going to type thread, that current thread. So this is going to give us the current thread on which this statement is executed, that name. So it's going to give us the name of the current thread on which this code is executed. And now we're going to pretend that we're going to do some work in the background, but we're going to do this work also on the main thread. So I'm going to, instead of, because we don't do actually that work, we're just going to pretend. So we're going to type thread, we're going to put the thread to sleep for a few seconds. So we're going to type thread.sleep 2000. So this, I'm going to add a comment here, pretending to do some, pretending here to do some work. So here we're going to pretend that we're doing some work in the background. And then I'm going to add here a print line, which is going to say main program ends, also colon, $, and thread, that current thread, that name. So all the code that we have here, this code is going to be executed on the main thread. And because here we type thread.sleep for 2000 milliseconds, so we're pretending that we're doing some work for 2000 milliseconds. Now, when this line of code is going to be executed, the thread is going to pause, and then it's going to execute the next line of code. So if you run this code now, we get main program starts and we get main, then we have that delay of 2000 milliseconds for 2 seconds, then we get main program ends. And we did this on the main thread. So as you can see, this thread.current.name, it's returning here main because the work is done on the main thread. But as you can see, this is not the way we'll do things, because this blocks the main thread for 2000 milliseconds. And imagine if you have here a function which performs a heavy operation, it will block the thread like I explained in the introduction video. What we can do is creating a background thread, and we're gonna put that thread.sleep, so that work that we're pretending to do, into that thread. So I'm gonna type here thread. So we're gonna type thread lambda expression, press enter, and we're gonna put this code. Now I'm gonna put this code inside here. But I'm gonna add a new few print lines. So I'm gonna add here print line, and I'm gonna type fake work starts, colon, $, thread, that current thread, that name. So that is gonna give us the thread on which this so this is gonna give us the thread on which this background thread is, on which this code is executed. And I'm gonna add also print line here. After we finish the work, we type fake work finished, also colon, and I'm gonna type thread, that current thread, that name. So what we're doing now is we creating a background thread, and now we're executing that work that we imagine on this background thread, so that we don't block the main thread, the execution on the main thread. And this code now is going to be executed without waiting for that work to be finished, because now that work is done on the background thread. So now if I run this, as you can see, we get main program starts, main program ends. So this line of code is executed, then this background thread is launched, and then the execution of the code continues. So this code now doesn't block the main thread, and it says main program ends, and then we get fake work starts, and we get thread.0. So this is the thread on which this background work is executed, and then we get get fake work starts. I get the name of the thread from this that we have here, thread.0, and then we get fake work finish. And the code on the main thread and the code on the background thread, it's executed in parallel. So in other words, it's executed concurrently, and that means that the code is executed in parallel. So the code on the main thread is not waiting for the code on the background thread to finish. No, it just executes this line of code. It sees here that there is a background thread, and then it goes to the next line of code, and it's executed this line of code. So it's not waiting for the background It's not waiting for this to finish in order to be able to execute this line of code. So this is why we get here main program start main program ends main, and then we get fake work starts, our background thread, and then we get fake work finish. And now if you run this again, you'll see the same output. So I get main program starts, main program ends. So those two are executing in parallel with those two that we have here. And this is because we're using a background thread. Now, let's see how we can achieve the same thing using a coroutine. So instead of thread, I'm going to delete here what we have here, and I'm going to type here coroutine scope. Now, but before we create our first coroutine, I want you to notice something which is very important. So I'm going to change this back to thread. Now I'm going to run this code again. And we get main program starts, main program ends, we get main, then we get fake work starts, thread, fake work finish, thread. So we get our code executed in parallel, concurrently, and what I want you to notice is that even though this last statement was executed in our main function, our program didn't end there. The program waited for the background thread to finish the work, and then we get process finish with exit code 0. So then the application finishes. So by default, the application will wait for the background thread or for the background threads to finish their work, and only after that it will finish the application, it will terminate. So let's now change this back to coroutine scope. So we type here coroutine scope. I'm going to explain immediately what is a coroutine scope. And now the coroutine scope is expecting here as a parameter a coroutine context. But first, let's talk about what is a coroutine scope. So a coroutine scope is usually used when you want to group a bunch of coroutines together. So if you want to have a bunch of coroutines to be grouped together because maybe one coroutine depends on another coroutine, and if maybe one of the coroutine fails, you can cancel all of them. You can do that because if you use them, if they are in the same coroutine scope. So this is what coroutine scope is used for. It's used to group a bunch of coroutines together. So you can have flexibility. You can do things if something happens with one of the coroutines. Now, this coroutine context here you need to pass first what kind of work we're gonna do. So this is what we're doing with the coroutine context. We're saying to the coroutine scope what kind of work we're going to do and on which thread we want to do that work. So we have a few options. First is the main. So if I type main, now let's press Alt Enter, and we have this main.kotlin.js coroutines. Main means that this coroutine scope is gonna work on the main thread, but this main that we have here only works on an Android program, but now we have only IntelliJ, so we cannot use main. The next one is IO, and IO means input output, and this is used for getting data from the internet or querying a database. So this is when you should use IO. And you also have default. Default means doing heavy work. So if I put here default, you see that we have dispatchers.default. You can press enter, and basically what this means is that this coroutine scope is gonna do some heavy work, and it's gonna use it depends on the coroutine what kind of thread it's gonna choose from the thread pool. Next, you still have this error here because we need to launch the coroutine, we need to create the coroutine, and to do that you put dot launch. And if you feel confused by what I talked about here about the default and main, don't worry, because in the next videos I will go into much detail about them. So we put dot launch, and now this creates the coroutine. As you can see, it's this coroutine scope. Now if you run this code, you're gonna see something interesting. We get main program starts, and then you get main, the name of the thread, then you get main program ends, and you get the name of the thread. but we don't get our fake work starts and our fake work finish. Why? This is because by default, the program does not wait for the coroutine to finish the work. In comparison with the thread, as I said, for the thread, the application waits to finish its work, but for the coroutine, it's not doing that. So what we can do? What we can do is that we can type here thread dot sleep, and we can put here to 5 milliseconds, and now this will make the thread to sleep for 2.5 seconds, and because this only takes 2 seconds, we'll get our output in the console. So if I run this now, but this is not recommended to do in a real app. So you get default dispatcher worker 1 and get main program ends. So now our output works, our program works. So you get main program starts, then you get our fake work. So you get our work on the, which is on the coroutine, and then we get main program ends, and then the process. So now it's waiting because we said here explicitly to pause the thread for 2.5 seconds, and because this works takes only 2 seconds, then it will have enough time to finish this. But as I said, by default, it's not waiting for the coroutine to finish. But if you think about this, is not a solution, because if instead of thread.sleep, because here you pretending to do some work, you have a function which is getting some data from the internet, you will have no idea how much time that it will take. So what we can do in that case? In that case, we will need to use something else, and I'm going to show you what you can use instead of thread.sleep here to wait for the coroutine in a short time. So now let's think about this thread.sleep that we have here. So if you think about our discussion when we discussed in our introduction about threads and coroutines and how they work, if you have a bunch of coroutines inside this coroutine scope that we created, because we have here thread.sleep, this will make the entire thread to pause for 2 seconds. And if you have 3 or 5 coroutines, all the coroutines will be stopped because the thread will be paused. So you need to use something else instead. So to use something else and to use to not block the entire thread, so the other coroutines can do their work, we're gonna use delay. And delay is used because it will only pause that specific coroutine. It's not gonna pause the entire thread, so the other coroutines can do their work without being stopped because the thread was paused. So if you use delay means just pause this specific coroutine, not pause the entire thread. Let the other coroutines to do their job within that thread and just pause this coroutine. So this is what it means. So if I run this, now we get main program starts main, then we get fake or starts, then we get our pretending work, which is this, which delays the coroutine for 2 seconds, and then we get main program ends. Now, as I said, in a real app, you'll not know how much time it will take for the coroutine to finish its work. So you cannot use thread.sleep and pass a specific number here, because you'll not know how much time it will take to do the work. So what we can do instead is we can delete this. So if you go up here and we press and hold Ctrl over the launch, and if you click, it's going to take us here, and we're going to see that this is an extension function and it returns a job object. And what is this job object? This job object basically allows us to have some control over a specific coroutine. So if I type here val, I'm going to call this variable parent job, because this is where this is the parent coroutine, if you want, because as you'll see later, we're going to add some child coroutines inside our coroutine scope that we created. Now, what we can do down here, because let's type parent here, because this job is offering us some control over the coroutine, we can, instead of typing thread.sleep and waiting for a specific time, we can say to the compiler to wait for the coroutine to finish its work, and then finish the program. So I can type it parent job, and to make the compiler to wait for the coroutine to finish, we type parent job dot join, and this basically is gonna say to the compiler, hey, wait for this coroutine that was defined here, wait to finish its work, and only after that finish the application or the program. But we have a problem here, and if you hover over here, it says suspend function join should be called only from a coroutine or another suspending function. Anyway, this is also a suspend function, as you can see if I hold control on it. Now, what are suspending functions? Suspending functions are functions which are marked with the suspend modifier, and they are not coroutines, but they can only be called from a coroutine. You can never call a suspend function not from a coroutine. So as you can see, this delay is a suspend function, has the suspend keyword there. And now what we can do here because here we're not inside the coroutine, so we cannot call join, because you can only call a suspending function from a coroutine. Here we can use what is called a run blocking, and run blocking creates a coroutine, and we can put now this code here and paste it here. I typed run catching, not run blocking, so let's change this to run blocking. And now the error disappeared, because now this creates a coroutine, this run blocking. The problem with run blocking is that the run blocking also blocks the thread, but this is the only way in which I can present the code. So in a real app, you're probably gonna just type parent job.join, and that is gonna work. But here you need to call this from within a coroutine, because this is a suspending function, and a suspending function can only be called from a coroutine. Now, if I run this code, look what happens, because now you said to the compiler, you said to the program, hey, wait for this to finish. Now we get main program starts main, fake word starts, and we get our thread on which the coroutine is operating, and then we get also our thread on which the code is operating. Another important thing to know is that even though the coroutine is operating, let's say, on this thread when it starts, it may happen that when the coroutine ends, so when you execute this line of code to do the work on another thread. So this is also important to know. And now if I change this to, let's say, 5 seconds, and if I run now, because here it said parent job.join, so wait for this coroutine to finish its job, it's gonna wait 5 seconds, then it's gonna say fake word finish, then it said main program ends, and we get main. Now I'm gonna close the console, and I'm gonna continue our discussion in the next video. Now it's time to start a discussion about coroutine builders, and also in this video I'm gonna show you how to create your own suspending functions. So what are coroutine builders? As the name implies, coroutine builders are some functions with which you can create coroutines, and there are 3 coroutine builders that you are gonna use, and those are launch, the one that we have here, the async, and the run blocking that we have here. And we're gonna look first at launch, but first I'm gonna create a few suspending functions. Now, to create a suspend function, just type I'm gonna make this function private suspend fun, and I'm gonna call it get data1, and this is gonna return a result, gonna mimic the behavior of getting the data from the internet. So I'm gonna add a print line here. Actually, let's define an argument here, call it let's call it thread name. It's gonna be of type string, and we're gonna add here print line, and I'm gonna type fake work 1 starts $, and the thread name. So it should be thread name here. Alright, Then we're gonna delay this suspending function. So we're gonna delay because this is gonna be called from a coroutine. We're gonna delay the coroutine for 2 seconds. Then I'm gonna add another print line, which is gonna say that the fake work 1 finished and the thread name. And I'm gonna create another function, but first let's return something because we need to return. I'm gonna return the string result1, right? Now I'm gonna create another function. So I'm gonna copy this, but this is gonna be called getData2. So I'm gonna paste here. I'm gonna call it getData2, and it's gonna be called fakeWork2, fakeWork2, and it's gonna return result2. Now let's delete the code that we have inside our coroutine scope. So let's delete the code that we have inside our coroutine scope, and first we're gonna look at the launch coroutine builder. And to use the launch coroutine builder, you just type launch, and then we have the lambda expression, and here we're gonna use our code, and I'm gonna call our get data1 function, and here I'm gonna type thread that current thread dot name. So because this function expects an argument, a string, and I'm gonna pass the current thread on which this coroutine is working, and I'm gonna put here val result1 because this returns a string which is called result1, and I'm gonna add here print line result1. Now I'm gonna create another coroutine, so with also the coroutine builder launch. So I'm gonna type launch and have a suggestion, press enter, and I'm gonna type here val result2 equals get data2, and here we're gonna type again thread that current thread that name, and we're gonna output in the console the value which is returned by the result2. Let's press Ctrl Alt L to format the code, and let's run our code to see what we have in the output. So this is how you can create your own suspending function. This is how you can use them inside your coroutines, because this coroutine builder launch creates coroutines. So we have 2 coroutines here, and as you'll see, they are running in parallel. So as you can see, they start both at the same time, and they also end at the same time. So we have on the output main program starts main, then have fake work 1 starts, and we have default dispatcher worker 2. Then we get fake work 2 starts, so our second function is called, and we have a different name for the thread. So we have default dispatcher worker 3. After that it says fake work 1 finished, and we have the name of the thread, then we have result1, this value here printed. After that we get fake work 2 finish, and then we have the name of the thread also from here, and then we have result2, which is returned from our second suspend function get data2, and then we get main program ends, and then we get process finish with x equals 0. So our application finished there. And what we have here is, first we have a parent coroutine, which is this coroutine that we define here, so this one, and inside this parent coroutine we have 2 child coroutines, this one and this one, and those coroutines are non-blocking in nature. And what that means is that they launch a new coroutine which is not blocking the current thread. In contrast with the run blocking builder coroutine, this is blocking the main thread. But those coroutines, which the coroutines created with the launch coroutine builder, they create a coroutine which is non-blocking, which is not blocking the current thread. And if you press Control here, because we already looked at this returns a job object, and with that job object we can have control over the coroutine. So I'm gonna type here val, and I'm gonna call it job1. I'm gonna put equals because that function returns a job object. Then val job2, I'm gonna put equals launch. So now if you hover over here, you see that this is of type job. This is because the launch coroutine builder is returning a job object. And now you can have control over the coroutines. You can also, as we saw with the parent job coroutine, we can join, then we can wait for the coroutine, but you can also cancel the coroutine. So if you want to have those coroutines that we have here, the job 1 and job 2, to run in sequence and not in parallel, you can just type here job 1 .join, and this now will wait for the first coroutine to finish execution, and then after that is gonna execute the second coroutine that we created here. So if you run this, look at the output. You get fake work 1 starts, then you get fake work 1 finish, and get the result returned. So you get the first one, the first coroutine, and then it executes the next coroutine. So they are executed in sequence. And to show you this more clearly, I'm gonna create a variable here. I'm gonna call it val start time, and I'm gonna get the current time in milliseconds. I'm gonna type system.current time in milliseconds, and that is gonna give us the current time in milliseconds. And at the end here, I'm gonna type print line. I'm gonna type total time colon $. I'm gonna type system that current time in milliseconds minus start time, and that is gonna give us the total time that it took to finish for the parent job to finish the work which is done by the coroutine's child inside. So now if you run this, get fake work 1 starts, so you get them in sequence, you get the result 1, and you get the total time is 4 seconds and a few milliseconds there. This is because they are running in sequence and not in parallel. But if I delete the job 1.join, so we're not saying to wait for the first coroutine to finish, we're by default they are gonna be started at the same time. And now look at the time that is gonna be show here. So now they both start at the same time. We get fake work 1 starts, fake 2 starts, then we get fake 1 finish, we get result 1, then we get fake work to finish, and we get the name of the thread, and then look at the time, we get only 2 seconds this time, even though the total time for both coroutines is 4 seconds. We get 2 seconds because they are started at the same time by default. So because I didn't put job 1.join, they are started and executed at the same time. So this is why I get only 2 seconds here, even though inside the suspending function we have 2 seconds for the first one and 2 seconds for the second one. Because they are started at the same time, you only have 2 seconds. So this is the launch coroutine builder. Next, we're gonna look at the async coroutine builder, and the async coroutine builder is very similar with the launch coroutine builder. The only difference is what the async coroutine builder is returning. Because with the launch coroutine builder, the value which is returned by this function getData1 and by the function getData2 is stuck inside the coroutine. So we cannot get that data outside of the coroutines. But with the async coroutines, as you will see, we can get that data outside. So we're gonna look at that now. So now let's look at the async coroutine builder, and for that I'm gonna hide the console, and we just change the launch to async. So if I type async, we have a suggestion and we fill that. And we do the same thing here. Also async. And now if you run this, you'll not see a difference in the output, but I'm going to show you how with the async you can get the data, we can get data outside of the coroutine. So we get the same output, no big difference, so they are very similar. I'm going to hide the console, but what we can do now, instead of adding the print lines inside the coroutine and getting this data inside the coroutine, what we can do with async is that we can return this value. So the last line of code, which is inside the async coroutine, is going to be returned back here. So let's change this. Let's press Ctrl Alt L. Now, because this getData1 function is returning a string, that string is going to be returned in this variable job1. And you can see this is now of type deferred string. So let's put that. Let's call it job deferred. And it's going to be of type deferred. And this can be a generic type. And we're going to type string here. And we're going to do the same thing for this. Job deferred. And it's going to be of type job deferred 2. And it's going to be of type deferred, the generic string. Alright, let's call this actually job deferred 1. And now the value which is going to be returned by the getData1 now is going to be stored in this job deferred 1. So if I hover over here, you can see that this is of type job deferred. It's of type deferred string, the same here. Now, how we can use that data? To use that data, we can now, outside the coroutines, we can add a print line here, and we can use what is called the await function. So we can type here job deferred 1 dot await, and that is gonna give us the value which is returned by the getData1 function. And I'm gonna add a plus here. I'm gonna put quotation marks, forward, a backslash n to add a space. I'm gonna put $sign to get the data for the job deferred 2. So I type job deferred 2 dot await, and that, if you hover over this, or if you press what this is gonna do is gonna return us the string. This is gonna return result 1. This is gonna return result 2. So now if you run this, look at what you get in the output. So they also start at the same time, they finish at the same time, as you can see in the output. So we have this fake work 1 starts, fake 2 starts, fake work 1 finished, and fake work 2 finished. Then we get result 1 and result 2, and the result 1 and result 2 is from this print line that we have here, and this is given to us by the job deferred.await, and that is going to give us the value which is returned. Then we get the total time, which is almost you have 2 seconds and a few milliseconds there, and then we get main program ends, and we have process finish with x equals 0. So this is how we can, with the async, you can get the data outside of the coroutine, and the data is the last line of code. So if I type here 12 now we have an error, because this is, we define here deferred of type string, and we're returning an integer. So it says type mismatch, required deferred, it should be required, it's correct, required string, and it found int. So if you change this to int, there is no problem. So the last line of code inside your coroutine created with the coroutine builder async is going to be the value which is going to be returned back to the variable here, and it's going to be the value which is going to be here. So let's change it back to a string. Let's delete this, and now we have no problem. So this is how you can use the launch coroutine builder, and this is how you can use the async coroutine builder. And next we're going to look at what is global scope and why using the global scope is discouraged. And with job deferred, we can also use the join and cancel function. At cancel function we didn't look yet, but we're gonna look in our next videos, because this deferred that we have here is inheriting from the job class. So because it's inheriting from the job class, you can use the join and cancel function. So you can type here job deferred 1 dot and have join cancel, and so you can use those if you want. And there is another interesting function that we can use using the job object, and that is the invoke on completion. So what you can do down here is you can use our parent job and put that and type invoke on completion. And this function is going to be called when the parent job finishes the work. So when all the child coroutines are finishing their job, and the parent job also finishes the job, this function is going to be invoked. And as you can see, you have a Lambda function. We have it throwable, so we can type here it question mark dot let. So if there is a throwable, so if there is an exception, we're going to say print line, and we're going to say parent job failed, and we're going to put colon, $, and it dot message, because we're going to get the message, the error message. Otherwise, we're going to put the Elvis operator, so we're going to put question mark, and colon. And if there is no, if the throwable is null, we don't have any throwable, that means that the parent has succeeded. So we type here parent job success with 2 s here. Now, if you run this code, look what happens. We get our 2 coroutines starting and finishing at the same time, get result 1 and result 2. And we also get parent job success because all of our child coroutines finish their work. The parent job also, because of that, finished execution, and it finished with success because we didn't have any error inside in one of our childs. We're gonna look at how we can have errors in the childs and what you can do with in a rapport with the parent if you have an error, and so on. But for now, just know that this invoke on completion is called when the parent job is completing the work. So when all the child coroutines are finishing the work, the parent job also finishes. And we get result on, and you get parent job success because there is no error. So this is also an interesting function to know about. And next we're gonna look at the global scope and why the global scope is discouraged to use. Now, what is global scope? First, let's say that you launch an application and you are currently, let's say, in the login screen. And within this login screen, you launch a coroutine, let's call it coroutine 1. And then you navigate to another screen called home screen. And within this home screen, you launch another coroutine called, let's say, coroutine 2. Now, if you navigate now back from the home screen to the login screen, the coroutine 2 is going to be destroyed when the screen 2 is going to be destroyed. And this happens because the coroutines in the way that we launch them here, they exist only locally. So they exist bound to the activity or the screen where they're launched. So when the screen gets destroyed, the local coroutine also gets destroyed. Now, if you launch a coroutine globally, no matter from what screen you launch that coroutine, it will survive the entire lifespan of the application. So even though if all the screens are destroyed, the global coroutine will still work in the background. So this is the difference between launching a coroutine locally. So if you launch it locally, it's bounded to the screen from which it's launched. And if you launch it globally, it's not bounded to the screen from which it's launched. It can run in the background the entire lifespan of the application. Now, the question that may arise is when to launch a coroutine globally, so when to use global scope, and when to use local scope. And the answer to the question is that it depends. And let's say that you click on a button to download the file. And if you want to download the file, you should download the file in a coroutine which is started globally, because you want to start downloading the file, and then you want to move on with the ongoing activities of that specific app. So that downloading the file should not interfere with the ongoing activities that you are currently doing in that app. Or another example is playing some music. You just start the music and you want to have that music playing in the background, and it should not interfere with again with what you're doing in that app. And in those cases, you should use global scope. You should use local scope when you want to do a thing and you want to end that thing there. Let's say that you want to log in a user. In that case, you log in the user and then you move on to let's say to the next screen, and you end that coroutine there. In that case, you should use local scope. So this is when, and I'm gonna show you how to use global scope. You just delete this here, and instead of coroutine scope, we type global scope.launch, and this is how you start a global coroutine globally. And let's press Ctrl Z to undo this. And you can also do the same thing here. So instead of async, here you can type global scope. So you can type here global scope.launch. But now we have an error because this here we said that this type returns something, and the global scope is not returning something. So let's press Ctrl Z. So this is how you will start a coroutine globally. And I'm gonna end the video now, and in the next video we're gonna look at cancellations, exceptions, and timeouts. So see you in the next video. So now it's time to start a discussion about cancellations, timeouts, and exceptions. And we're gonna look at the first one, and that is cancellation. And the question that may arise now is why we want to cancel a coroutine in the first place. And the answer to that question is that you want to cancel a coroutine, let's say, when it's taking too much time to do some specific work. In that case, you will need a mechanism to cancel that coroutine. Secondly, let's say it may happen that you no longer need that result that the coroutine returns. In that case, you also need a mechanism to cancel that coroutine. And another very important thing is that in order to be able to cancel a coroutine, that coroutine has to be cooperative. And that means that the functions which are used inside the coroutine have to be part of this package, Kotlin-x.coroutines. And if the functions which are used inside that coroutine are not part of this package, you're not going to be able to cancel the coroutine. Now, I'm going to change this now a little bit to a launch and not to async. So let's type launch here. Let's change this to job 1. Also here. And we're going to output the result that this function returns in the console. So I'm going to add directly this in the print line. So I'm going to add this directly in the print line. Also here. Let's change this to get data 2. And let's comment this line of code because we don't need this code anymore. And let's run our code the way it is now to see what we get in the output. So we get in the output fake work 1 starts, fake 2 work starts, then we get fake work 1 finish, we get result 1, then we get fake work 2 finish, and we get result 2, parent job, success, total time 2 seconds. So our output works well. Now let's say that I want to cancel the first coroutine, which is returning the variable job1. So I can type here job1 dot, and to cancel a coroutine, you type cancel. Now I'm also going to type job1 dot join, because if the coroutine is not, let's say that the code is not able to cancel the coroutine, then I'm going to wait for the coroutine to finish. And those functions are so used in conjunction that there is a function which combines those two, but I'm going to show you this after I run this code. So let's run this code now. So now we cancel the coroutine 1 immediately after we launch it. So let's see what happens. We get fake 1 work 1 starts, fake work 2 starts, and get now fake work 2 finished, and we don't get fake work 1 finished because it was cancelled. And very interesting, we get result 2, but we don't get result 1 because our coroutine was cancelled. And we get parent job success, and this is also very interesting to see how the cancellation is propagating to the next coroutine, respectively the coroutine 2, and how it propagates to the parent coroutine. So the parent, even though we cancel this coroutine, the parent is not throwing an error. It says that it's success, and it took also 2 seconds. Now, as I said, let's change now this delay function, and this delay function is part of that package that I talked about, and I'm gonna change it to thread.sleep. So let's see if now I can cancel this coroutine, because that thread.sleep is not part of this package. So in theory, I should not be able to cancel the coroutine, because the code that we have here is not part of that package. So our coroutine is not cooperative, and we can't cancel the coroutine. So if you run our code now, as you can see, get fake work 1 starts, fake work 1 finished, result 1. So if again we get fake work 2 starts, so we get our fake work 1. So our first coroutine was not cancelled because it's not cooperative, and that means that the functions which are used inside that coroutine are not part of this package, and thread.sleep is not part of that package, but delay is part of that package. So if I change this back to delay, and if I run this code, get fake work 1 starts, fake work 2 starts, and get fake work 2 finish, and fake work 1 we don't get that it finished, and get only the result 2, and get parent job success. So now our coroutine is cooperative, and that means that it's cancelable. And you can also combine those functions in one function, because the join function is gonna work only if the cancellation fails. So we can combine this in one function called job1 cancel and join, and this will give us the same output. So if you run this code, we get fake work 1 starts, fake work 2 starts, and we get only the result 2 because the first coroutine was cancelled, and we don't get any result back. And the cancellation didn't propagate to the parent, so it didn't cause the parent to also fail. And it also didn't cause the second coroutine to fail. The second coroutine it worked independently. It wasn't affected by the fact that this was cancelled. Now there is also a boolean flag called it's active, which is going to return true if the coroutine is active, and it's going to return false if the coroutine has been cancelled, so if the coroutine is not active. And to access that boolean flag, you can type here if, I'm going to put not, so if it's not active, then return, so return to the launch. That means that it's gonna break this coroutine. So if you run this code, we get fake work 1 starts, fake work 2 starts, and then you get result of parent job success. And so our code works well, and this flag, even though it's not showing very clear here what it's doing, but if you have some work, you can say you can put a if check, and if that is not active, you can break that work which the coroutine is doing. This is very powerful to have this internal boolean flag to check whether the coroutine is active or not. Next, we're gonna look at how to handle exceptions, because when you cancel a coroutine, what is actually happening is that the function, respectively the delay function, is gonna throw an exception. And to show you that, I'm gonna wrap our our code into try catch, and I'm gonna catch here cancellation exceptions. I'm gonna put curly brace, I'm gonna put here a print line, and I'm gonna type exception cut safely. I'm gonna also add a finally block, and I'm gonna add a print line here, which is gonna say resources closed safely. So let's put our code, which is gonna throw the exception. Let's press Ctrl Alt L, and let's put here $x dot message. Now if you run this code, we get exception caught safely, standalone coroutine was cancelled, and get resources closed safely. And so we can wrap your code in try and catch to catch the exception. But what if you cancel the coroutine too? And as you'll see, if you throw your own exceptions, what you're gonna do if you have job 1, job 3, job 4, job 5, what you're gonna do in that case? You cannot wrap, actually you can wrap all of that coroutines in a try catch, but the code is gonna be very messy. And for that we have something else about which I'm gonna talk a little bit later. For now, you just need to know that the cancel, when you cancel a coroutine, that is going to throw an exception. You can catch that an exception in a try catch, as you saw in the output here. So, right. But before we move to the next section, let me show you how you can use your own cancellation message. So I can put here cancel. And as you can see, this expects as an argument a cancellation exception. And let's put here job1.join. So here I can type cancellation exception, and I can put a message here, my own error message. So now if you run this exception is gonna be catch by our try and catch here, and you're gonna see when it's gonna read this line of code x.matches, you're gonna see our message. So if you run this, so you can see exception caught safely, my own error message. So the exception was caught by our try and catch, and it outputted the message that we typed here. So this is how you can type your own message for the cancellations. So I'm gonna close this. Now let's look at timeouts, and let's say that a coroutine is taking more time than expected to finish some work. In that case, you can use timeouts, and you can specify an amount of time that you think that coroutine should finish the job, and if not, then that coroutine is gonna be cancelled. And we have two coroutine builders, two coroutine timeouts builders, and that is timeout with timeout and with timeout or null. But first, let's delete this code. So let's delete this code because we don't need this code now. This also. And we can, so with timeout is also coroutine builder, with the difference that it will receive, as you can see here, a parameter of milliseconds. So let's put here, let's say 1000 milliseconds. And because our coroutines, our get data one, it will take more than 1000 milliseconds, it will take 2000 milliseconds. That is gonna fail, it's gonna throw an error. So if you run this, and this also, as you can see, a coroutine builder, but with this difference that has this here. So get timeout waiting for 1000 milliseconds. So it says parent job failed. That's because our coroutine takes more than 1 second that we pass here to finish the work, and for that it failed. So, and because of that it failed. But if I change this to, let's say, 3000 milliseconds, and if I run this code, now everything works fine, because the time that we pause for our with timeout is longer than the time it took for the coroutine to finish its job. So this is with timeout, and let's look at the next timeout, and that is with timeout or null. So we type here with timeout or null. We also pass milliseconds here. Let's put 1000 milliseconds, and now if you run this, now we get in the output fake work 1 starts, fake work 2 starts, but we get only result parent job succeeds, and we get 3 seconds here. And with the difference with timeout or null is that timeout or null is not going to throw any error, but with timeout or null can return a value. So if I put here 12, this value now is going to be returned in this variable. So you can see now job 1 is of type int, nullable int. And you can use that variable in your code. So you can put here print line job 1, and that is our 12, our value that is returned there. And if this times out, so it basically didn't finish in the time that we pass here, then it's gonna return null. So if I put here a print line, and if I put job 1, because this is only 1000 milliseconds and our work takes 2, that is gonna return a null in our variable. So if you run this, as you can see, we have null, that is the print line that we have, and we have the output that we have here. So this is how you can use timeouts. Next, we're gonna look at how you can throw your own exceptions, and how those exceptions are gonna affect the child coroutines and the parent. So I'm gonna delete this code. I'm gonna change this back to launch. So now it's time to look at how we can throw exceptions inside our coroutines, and how those exceptions are gonna affect the other coroutines, and how it will affect also the parent coroutine. So how it will propagate to the parent coroutine if one of the child coroutines it throws an exception, how it's gonna affect the other child coroutines, and also how it's gonna affect the parent. And for that, I'm gonna go down here, and I'm gonna create another private suspending function. I'm gonna copy this one, and I'm gonna call it getData3. So let's paste it here, and let's call it getData3 fake work 3 starts and fake work 3 finished, and let's return result 3 here. Now let's go up here, and let's create another coroutine here. So we type val job3 equals, and we're gonna create a coroutine using the launch coroutine builder, and we're gonna add a print line here, and we're gonna type get data3, and now for the parameter thread name, I'm gonna type thread dot current thread dot name, and that is gonna give us the name of the current thread. Now if you run this code, we get all of our coroutines starting at the same time, and we get then work 1 finished. Actually, let's go down here, because I think I missed something. So get work 1 finished, work 3 finished, then we get work 2 finished, we get result result 3, result 1, result 2. So our code works okay, and we have only 2 seconds for all of our coroutines, even though they together, if they are executed sequentially, will take 6 seconds, but because they are starting at the same time, we only have 2 seconds. Now let's say that I throw an exception inside the coroutine. So let's say that I throw an exception inside this suspending function. So I'm gonna type here throw. So this is how we can throw an exception, and I'm gonna throw a generic exception. So exception I'm gonna type here, and I'm gonna type the text error while getting the data in get data 1. And I am curious about how this is gonna affect the other coroutines which are currently running inside our coroutine scope, and how is that gonna affect our coroutine parent. So what I'm interested in is if the parent will fail or the parent will say that it has succeeded. So now if I run the code, let's see what happens. So now we get an exception, and we get main program start, fake one more starts, and we get an exception, and we get our message error while getting data in get data 1. So we get the message that we typed here inside our exception, and that exception is the message we get it from here. So we get here. Actually, no, not from here. Let's go down here. So we get here parent job failed, error while getting the data and get data 1. So this is the message that we get here from here. So the parent, because first what happened, because we throw an exception in the job 1, it also caused the other jobs, job 2 and job 3 to fail, to not work, and it also caused the parent to fail. And we know from the previous video that you can surround this in a try and catch. So we can type here try catch, and we can type here x, and we're gonna catch exception, the exception that we throw in the child, and we're gonna put curly brace in the print line here, and we're gonna type exception session cut safely, and we're gonna put $sign x dot message, and let's change this to cut because that is bad English. All right, let's also add the finally block here, finally, and let's print line, let's say sources closed safely. All right. Now if you run this code, because now we are actually I should put this inside our try and catch. So let's so you get the same error because I didn't put the code there. So let's copy our code which generates the exception. Let's paste it inside the try. So what we're saying now, hey, I know that this can potentially throw an error. I know what the error is. It's this exception that we define here, but anyway, try to run that code, and if an error occurs, just catch that exception and execute the code. And what I'm curious about is if the next coroutines are gonna run and if the parent is gonna fail or succeed. So if I run this code now get fake work 1 start, fake, let's actually go up here to see the output. So get main program start main, fake one starts, and we get exception cut safely error while getting get data 1. So it caught the exception that we thrown in our get data 1 function, and then it says resources close safely. So this is the message from the finally block. And then we get our fake work 2 start. So our second coroutine, now it's working. It's not affected by the fact that it was an exception throw in the first coroutine. And we get also fake work 2 starts, and we get the results for fake fake work 1 and fake work 2, and also for fake work 2 and fake work 3, because we get result 3 here, result 2 here, sorry, and result 3 here. And very important, the parent job succeeds. So we get parent job success. So the parent didn't fail now. So the error didn't propagate to the parent, and it made the parent to fail. So this is one way to avoid that error. But let's say that now I throw an exception in the in the second function, what can I do? So let's say that I type here throw, also exception, and let's say that's gonna say error, so quotation marks, error while getting the data in get data 2. Let's see what happens now, because as we saw previously, now if we run our code, it's gonna make our program to crash, and we can again surround this in a try and catch block, and so we can type here try catch, and we can type here x and exception. We can add a print line here, which is gonna say exception safely. So we're gonna type here $sign x dot message, also the finally block. So finally, also print line, which is gonna say resources closed safely. So the finally block is gonna be executed no matter what happens here. So let's move the code that we have here inside our try. Let's paste it here. Now let's run our code. And because we've surrounded our code with a try and a catch block, it also didn't cause the third coroutine to fail, and it also didn't cause the parent. So we get here parent job success, and we only get result 3 because the other coroutines for the other coroutines we get so we get here error while getting the data and get data 1, and then we get exception cut safely error get and while getting the data and get data 2. So we only get the result for our coroutine 3. So but if you look at this code, it's kind of messy, because imagine if I have 10 coroutines or 20 coroutines, then what can I do? I can surround them with all of them with try and catch. I can do that, but that is gonna look messy. And there is another way to handle all of this using what is called the coroutine exception handler and a supervisor job. So what we can do instead of surrounding our code with try and catch, we can delete this code that we have. So we can delete this. Let's delete this. Let's delete this also. This is also. Let's press Ctrl Alt L to format the code. And now if you run the code, you get our app is gonna crash. So our app crashed, and also the parent failed. You get error while getting the data and get data 1. Now, instead of surrounding our code with try and catch, we can create what is called the coroutine handler. And to create a coroutine handler, we can type here val, and we type handler, and we have a suggestion for the time, coroutine handler, and we put equals coroutine exception handler, and this is gonna be a lambda expression, and for the first argument we're gonna put underscore because we're not gonna use the first argument. We don't need that argument. And for the second argument we type exception. So we type exception, we put the arrow sign, so because it is a lambda expression, and we add a print line here, which is gonna say print line error in one of the children, and we put colon, and we put $sign exception that message. Now what we can do now, instead of surrounding surrounding each particular child coroutine in a try and catch block, we can pass this handler that we created here to the parent coroutine, and if an exception is thrown in one of the children, that exception is going to be handled by this handler that we created now. But this only works if we use our handler with the supervisor scope in conjunction. So if I only pass here, if we put here parentheses, and if I type here handler, so this now is gonna handle if there is an exception thrown in one of the child coroutines which are inside the coroutine scope. So now if you run this code, now we'll get an error and the parent will fail, because we also need to use the supervisor scope. So we get error in one of the children. At least our app didn't crash, so we didn't get the exception, but we get error while getting get data in get data 1, and parent job failed. So our parent job failed, and it also caused the other coroutines to fail. And to use to make use of this handler, we can type here supervisor scope. So supervisor scope, we choose this one, lambda expression, press enter, and we move our code which we want to supervise if you want. So you want to look at this code, at those coroutines, at those child coroutines, to see if they throw an error. And if they throw an error, that error is going to be handled by our handler that we created up here. And it's gonna show this message, error in one of the children, and it's gonna say exception. It's gonna output the message for the particular coroutine. So we surrounded our child coroutines with the supervisor scope lambda expression. We pass our handler to the coroutine parent, and now we're saying, hey, if an error is thrown in all of the child in all of the child coroutines, then handle this error and make sure that it's not propagating to the next coroutines, and it's not affecting the parent coroutine, the coroutine that is which is the parent for the child coroutine. So now if you run this code, look what happens. So previously we got that the parent failed, and now we get that error while getting the data in get data 1. So we get error in one of the children. So we get the message that we have up here, error in one of the children, and we get exception that message. So we get this message, and then we get fake or to starts, and this suspending functions, this coroutine also throws an exception. So we get again error in one of the children. Now we get error while getting the data in get data 2. Then we get fake work 3 starts, so our third coroutine starts, and we get fake work 3 finish. So now our third coroutine is not affected by the fact that the first and the second coroutine. So our third coroutine is not affected by the fact that our first and second coroutine failed. And we also get result 3, and we get parent job success. So the parent now is success, is not showing an error. So this is how you can throw exceptions, and this is how you can handle those exceptions using the handler, the coroutine exception handler. You can pass it here, and you surround your code, your child coroutine with the supervisor scope, and it's going to be handled by that, instead of surrounding each individual coroutine with try and catch, and that's going to look messy. You can just type this, and that is going to take care of the errors, so that the error is not propagating to the next coroutines and to the parent coroutine. And you can also throw another exception, which is called a cancellation exception, and that's a special exception. And if you throw that exception is not going to cause the other coroutines to fail. So there is another exception that you can throw, and that exception is not going to propagate to the other coroutines which are currently working in that coroutine scope, and is also not going to propagate to the parent. And let me show you how you can use that. So let's comment this code. And instead of exception, we can type here this special exception called cancellation exception. Now, if I remove the supervisor scope, let's say, and also the handler, as I said, this is not going to propagate to the other coroutines, and it's not going to affect the parent. Alright, so if I run the code now, let's press Ctrl+L to format the code. So we get all our 3 coroutines starting, and we get work to finish. So work 1 didn't finish because it threw that cancellation exception, but it didn't cause the other coroutines, respectively coroutine 2 and coroutine 3, to fail, and it also didn't cause the parent to fail. As you can see here, the parent is success, so even though we didn't use any kind of try and catch or the supervisor's job with the handler. So this is another session that you can throw in our code. And I'm gonna end this video, and in the next video, I'm gonna look at how you can execute coroutines sequentially, concurrently, in other words, in parallel, and lazily. Now it's time to see how we can execute our code sequentially, concurrently, and lazily. And for that, I'm gonna delete the supervisor scope because you don't need this. I'm gonna delete the handler because we also don't need this. Now, we already touched a little bit on this, on how to execute our code sequentially and how to execute our code concurrently in parallel. And to execute by default, the way we have the code now, this code is going to be executed. But first, let's go down here to see if I have an exception. Yeah, I have this exception. So let's delete this. So by default, the way we have our coroutines defined here, they're going to be executed in parallel. So by default, they are going to be started in parallel, and you saw that when you look at how much time it took to launch and finish their work. So if you run this code, those coroutines are going to be executed in parallel, as you saw in the last video. So you can see they start all at the same time, and we get result 2, result 3, result 1, parent job success, and we get total time 2 seconds, even though if you add the time of all of our suspending function is 6 seconds, but because they are started in parallel, so they start at the same time, it only took 2 seconds to execute all of them. Now, if you want to execute them sequentially, so one after another, and in that case you're going to have 6 seconds, you just type job1.join, and that means that wait for this coroutine to finish and then execute the next coroutine. And let's do the same thing for job 2. So job2.join. So what we are saying now is, first wait for the first coroutine to finish and then execute the second coroutine, and also wait for the second coroutine to finish and then execute the third coroutine. And now if you run this, pay attention at the total time that it took to execute all of them. So if you run our code, and if you look at the output, as you can see, it says fake work 1 starts, fake work 1 finish, result 1, fake work 2 starts, fake work 2 finish, fake work 3 starts, fake work 3 finish. So they are executed sequentially. So you get result 3, parent job success, and the total time is 6 seconds. So this is because now they are executed one after another. So one finishes, the next starts. The second finishes, the next one starts. So the total time, this is why the total time now is 6 seconds. So this is how you can execute the code sequentially. The next way of executing our coroutines is lazily. And lazily means that we're gonna execute our coroutines only if we use the result that the coroutines gave us back in the code. So let's delete this because you don't need this. And I'm gonna change the launch to async because it's gonna illustrate better how that is gonna work. So I'm gonna change this to async. So async. So this is just a different coroutine builder. We looked at this in our video was about coroutines builders. Async, also async. And I'm gonna delete this, because now this value is going to be returned in the variable job3. Also here, because the function get data 1 and get data 2 and 3 return a value, and that value is going to be returned in those variables. So as you can see, we have variable first it's of type def first thing. I'm not going to type the type again because it can be inferred. Now I'm going to uncomment this code, and I'm going to type job 1.await, job 2.await, and I'm gonna put back a plus, I'm gonna put quotation marks, forward slash, and I'm gonna type job 3 $sign actually, job 3 dot await. And if you press shift control P, as you can see, this whole expression is of type string. So this is going to return the value that is going to be returned by those functions. So it's going to return result 1, result 2, and result 3. So we're going to get this back that we have here and here and here. Now if I go up, if I comment this code, let's say, and I don't use the result in my code, and I run this code, look what happens. So now I'm not using the result that the coroutines are given back in my code, but they are still executed. So as you can see here, they are still executed, and we get work 1 finish, work 2 finish, work 3 finish, and we get parent job success. But we don't use the results, so we don't use what those coroutines are giving back, their work. You don't use that in our code. So it doesn't make sense to have them executed. And in that case, you can have the coroutines starting lazily. And starting lazily just means that is gonna start the coroutine only if you use the result that coroutine gives back in your code. And to start a coroutine lazily, you put parentheses at the end of the async. So you put parentheses and you type star. So this is a name argument, start equals coroutine start, and we choose this one, coroutine start.lazy. And now that coroutine is going to be started lazily. It's not going to be started if you don't use the result in our code. Also here we're going to type the same, start equals coroutine start.lazy, and also here start equals coroutine start.lazy. Let's press Ctrl Alt L, and let's actually put this in a more concise way. So this is more concise. So if I put this like this and this, not this. All right, and let's put let's add the space here. Now, if I run this code, now you're not gonna see that the coroutines are started because we're not using them. You're not using the result in our code. You only get main program starts, so we get main. Now the problem is that because we have here parent job.join, this never finishes. So let's comment this also. So comment with line comment, I don't see where it is. So let's run this again. So get main program starts, total time, and get main program ends. So now we don't get our coroutines started because we don't use them inside our code. But if you use them inside our code, so let's uncomment this. So let's go to code and let's comment with line comment. That is gonna undo. Now, if I use the result in our code, so if I type print line and job1.await, job2.await, and job3.await. Now because I'm using them inside our code, I'm using the result that they are giving back. Now they're gonna be started. So as you can see, now they are not grayed out. So now if I run this, we get main program start, get fake one start, fake one to finish, and so on. and then we get result 1, result 2, result 3, and parent job success, total time 6 seconds. So now our coroutines are started, because here on this line of code we are using the result that the suspending function are giving back to the variable that we define here, because you use them inside our code. Now they are started, but if you don't use them inside your code, they're not going to be started. They're going to be staying there and going to be started only when you use them in your code. So this is how you can use start a coroutine lazily. And now I'm going to end the video, and in the next video I'm going to talk a little bit more about coroutine scope. So now it's time to look at the with context function, and to understand why you need to use the with context function and how to use the with context function. And for that I'm going to create a new function called a new suspending function. So I'm going to type private suspend fun, and it's going to be called set text on main thread. It's going to have a parameter called input. It's going to be of type string. Now we use the with context function when you want to switch the current thread in which we are currently in to another thread. So if we are specifically with this function, if you are now doing work in a background thread, and let's say that we want to update a UI component, like a text view or something. If you try to update that UI component from the background thread, the app is gonna crash. And what you can do in that case is that you can switch the context, so you can switch the thread from the background thread from which you are currently in to the main thread, because you can update the UI only using the main thread. So you can type with context, you type main. So basically what you're saying here, hey, switch the context, switch the threads from the background thread that I am currently in to the main thread, because I want to do work on the main thread. And we select the first one, so we press Alt Enter, and we put curly braces, and here you add your code to update, add code to update the UI. And I'm gonna bring Android Studio to see how this looks in a real example. So as you can see here, I have a button, I have a text view, and so on, and this code is similar to what you have in our IntelliJ. I have a coroutine, and I start the coroutine using IO, which means input output. Then I have a function, a suspending function, get fake data, and I have two coroutines, and here I have this function set text on main thread, and I have this job data await, and this is gonna return a string value. If you press shift control P on this, as you can see, this is a string. So if you press control and if you go where this function is defined, this takes as an input a string and is switching the context to the main thread, because on the main thread are our UI components, the text view and the button. And we take that input, we append it, and then we assign that text to our text view. And for whatever reason I can't run the virtual phone, but if I go here to activity.main, and if I go to code, let's put some text here, let's say for the text so text, just to show you how this will look. So now this UI component that we have here, text, is gonna be updated with the text that is given us as an input here from inside our coroutine. And because you're inside our coroutine and we are on a background thread and we want to update the UI component, we switch the context. So we switch the thread, say with context, switch the context to main thread, and then update that UI component. Because if you don't do that, the app will crash, because you cannot update the UI components from the background thread. So this is the with context function, and this is how you can use it in a real app. Now it's time to download and install SQLite database for Windows. But first, what is SQLite? SQLite is an embedded database, and what that means is that you don't require any server to create the database or to communicate with the database. You can directly create the database on your computer, and you can directly communicate with the database using SQL queries. And I'm going to see what those are in the next videos. But first, let's download the SQLite database. So I'm going to open my browser. You should open your browser. I'm going to type www.sqlite.org. Click enter, press enter. Go to download, click on download, and we go down here where it says Windows, and we choose this one which says a bundle of command line tools for managing SQLite database files, including the command line shell. So click on this link. Now the downloading will start, and it was immediately finished because it's a small file. Now I'm gonna go inside our downloads file. We go here. And here we're gonna extract this file. So I'm gonna extract this file, and I'm going to extract this file here. So you extract the file, you can extract it wherever you want, but I'm going to extract it here, and it opened the file for us. And if it didn't open the file, just double click on the file, because you're going to copy that file inside a folder. So I'm going to right click here. So right click, let's copy this, and we're going to put this file inside our local disk C. So I'm going to open my computer, go to local disk C, and I'm going to paste this file here. And I'm going to change this name to SQLite3. So I'm going to type SQLite3, and I'm going to go inside the file, and here we have 3 folders. And what next we need to do is that we need to set up the environment variable for SQLite3, so that when we run the command SQLite3 on our command line, it's going to be recognized from any folder. So for that, we first need to copy this location. So copy this, so Control C. We go back, and here we go to properties inside our my computer. So inside my PC, go to properties, and if we have a different version of Windows, what is important is to find this setting, this option which says Advanced System Settings. So click on this, and we go to environment variables, because here we're going to set up our environment variable for SQLite3, and make sure to have path selected here. So you choose this one, path, and we click on edit. And here we have there is the SQLite. Here is the path that I added previously, because I did this once, but I'm gonna delete this. And what we need to do here is just click on new, and it's gonna go to the next line, and I'm gonna paste the path that we copied previously here. So we paste it here, we click on OK, OK, and we exit. And now we're gonna open our command line to see if everything works fine. So I'm gonna type command line, and here we type now SQLite3. And as you can see, now everything works fine. We have SQLite version, and we have this connected to a transit in memory database. So our database was opened, and it's ready for working. So everything works fine. And if you have any problems, just leave me a comment, and I will help you to solve it. So see you in the next video. Now I'm gonna tell you how to use SQLite database on a Mac. And to use SQLite database on a Mac is very easy, because on a Mac SQLite database it's already installed. And I can show you here because I have Windows, but on a Mac you just need to open your terminal. So open your terminal and type in lowercase letters SQLite3, and that is gonna open the SQLite3 command line shell for you. Now I'm gonna show you how to use SQLite database on Linux Ubuntu. And to use the SQLite database on Linux Ubuntu is very easy, because on Linux Ubuntu SQLite database is already installed, and the only thing that you need to do is to open the terminal. So I'm gonna open the terminal. And now we need to open SQLite3 command line shell, and for that we type in lowercase letters SQLite3 and we press enter, and this opens the SQLite3 command line shell for us. And it also shows here the version. This version can change with time, and now we're ready to go. Now it's time to create our first table, and we're also going to see how we can populate our table with data. But first I'm going to open the SQLite database, I'm going to open the command line, and I'm going to type SQLite3, I'm going to press enter. Now to create our table, we type in uppercase letters, create table, and by convention, now we need to specify the name of the table, but by convention the name of the table is typed in lowercase letters. So I'm going to type here books, this is going to be the name of the table, and you put left parenthesis, right parenthesis, and we put a semicolon at the end. Now inside the parentheses we need to specify the rows which are going to represent each individual book. And first is going to be the author name, so I'm going to type author, so this is going to be the first field, and it's going to store text. So in uppercase letters we type text, then we put a comma, next we type title, and this is going to store also text because this is going to store the title of the book. Now everything will work fine if I go at the end here and I press enter, but now we're missing something which is extremely important, and that is that each row should have a unique ID, so that later when you want to update, let's say that a specific row in our table, or to delete a specific row in our table, you can use that ID to identify that specific row, and you can delete it or do whatever you want. And for that you go at the start here, not here, inside the parenthesis, you type ID, and we type here integer in uppercase letters, primary key. So what we're saying now to the SQLite database that it should treat this ID as the unique identifier for each row. This is what we're saying by typing here integer primary key in uppercase letters. Now I go at the end here, and if I press enter, and if you see no suggestion and it just goes to the next line, that means that everything worked fine. So now we have our table, but now our table is empty, so we need to insert some data on our table. And to do that we need to use another statement, and we need to type here insert, to insert some information into the name of the table on which you want to insert data, books. And now we need to specify the fields for which you want to provide the data. So I'm going to type ID in parentheses, author, and the title. So for those are the three fields for which I want to provide data. And we close it with the right parentheses, and then we type in uppercase letter values. So now I'm going to pass the actual values for the fields that you have on the left. So first is going to be the ID, I'm going to type 1, and the name is going to be Fyodor. And I'm going to type Dostoevsky, and as you can see, this now the name is in quotation marks, and this is because we said here that this is going to be a text. And next we are going to specify the title of the book, and the title of the book is going to be The Idiot. So The Idiot. I'm going to close it here with a quotation marks, a double quotation marks, parentheses, and then you put a semicolon here. Now if I press enter, you don't see no errors, and that means that we have our data inserted into the table. Now I'm going to insert another data, so I'm going to type insert into books, left parenthesis. Now I'm not going to provide any value for the ID because I want to show you something. So I'm going to type here only author, title, and now for the values I'm going to type values in uppercase letters, and here I'm going to type first for the author name, and the author name is going to be Lev Tolstoy, and the name of the book is going to be in quotation marks, we put a comma there, Anna, in double quotation marks we type Anna Karenina. So this is our second book that we insert inside our books table. So I'm going to put here at the end a semicolon, and I'm going to press enter. And because you don't see no suggestion, that means that everything works fine. Now, how you can see this data? How you can get this data back to see it that you have it as the data it was actually inserted in our table? To do that, we need to use a select from statement. So we type here at the end select, and I'm gonna talk more about this in the next video. But just type here select from, but we put an asterisk sign, and we put from in uppercase letters, and the name of the table from which you want to select the data. For select from books, and we put a semicolon, and if you press enter now, it's gonna return all the rows with the corresponding values to us. So I'm gonna press enter, and as you can see, it returned 1 and 2, and this is interesting. Even though we didn't pass here 2, this 2 was added automatically by the SQLite database, because we said here that this is going to be an integer primary key. Even though here we didn't specify the ID, it knew because we said that it's going to be an integer primary key, it knew that it has to increment that value, and it has to add that value by default for us. So it put it added here too. Then we have Lev Tolstoy, Anna Karenina. So we have our two authors and with their two corresponding books. So this is how we can create a table. This is how we can insert data in a table, and this is how we can also select that data from a table. We can use a select from statement. And see you in the next video. Alright, so now it's time to see how we can update and delete items from our books table. And we're going to start with the update. And to update an element from our books table, just type in uppercase letters, update. Next, we need to specify the table on which you want to perform the update. So update books. Next, we type in uppercase letters, set. And now we need to specify which field we want to have updated. So that can be the ID, the author, or the title. And I'm going to choose the author. So author, and put equals, and you put in quotation marks the new value that I want to assign to the author. So I want to assign an empty string, let's say, for the author. Now I can put a semicolon here and I can press enter, but if I do that, all the rows or the author rows in our table are going to be updated. So if you have thousands, hundreds of thousands, or maybe millions of rows, it will update all of them. Now if I press enter, what you need to do is to update only a specific row from our table. And to update a specific row, you need to use something to identify that row, something which is unique to that row. And I'm gonna use, of course, the ID, because the ID is this is different for each row. So, and to use the ID, and we're gonna use the ID with the where clause. So we type here where in uppercase letters, ID equals 1. So what we're saying now is, hey, update the books table, or update the author name to an empty string where the ID is equal to 1. So now if I press enter, and if I type now select from books, and if I press enter, now as you'll see, the name Fyodor Dostoevsky was updated with an empty string. And if I want to have that back, you just type update again, books, set author equals to Fyodor Dostoevsky, where, and this is very important, ID equals to 1, and semicolon, and press enter. Now if I type again the select statement to get the data back, to get the data displayed here, select from books, and put a semicolon and press enter. Now we have Fyodor Dostoevsky updated back. And we can also delete an item from our table. And to delete an item, it will be similar, but we're going to use a different command, and the command is delete. So we type here delete from books, and again we need to use the where statement, because the where clause, because we need to specify which row we want to have deleted, because if you don't do that, it will delete all the rows. So it will delete all the data in our table. So where ID, let's say, equals to 2. Let's put a semicolon and let's press enter. And because it's not showing anything, that means that it works. And to check, we're gonna type a select from books, semicolon, and press enter. And now if we only have one row, and that is the Fyodor Dostoevsky and the idiot, and the book that that specific author wrote, because the delete statement deleted our second row, which was the Tolstoy. Now you can insert it back if you want, and that is very important to use the where. So now I'm gonna end the video and see you in the next video. Alright, so now it's time to start a discussion about joins, and in our introduction video we talked a little bit about what is a join. And a join is basically a statement which can group different data from multiple tables together. And in order to be able to group data from multiple tables together, it needs a link. And the link is usually the unique identifier, the ID. And let's now see how you can use the join clause. But first, let's create another table. I'm going to call it reviews. So I'm going to type create table reviews. And it's going to have an ID. So we type here ID, integer, primary key, and we also type auto increment to make sure that it's incremented. Next we type name, the name of the person who wrote the review, a text, the review, also text, and the book on which this particular review was added. So I'm going to type here book underscore ID. Close the parenthesis, semicolon, and press enter. And now we created another table called reviews. Now let's insert some data in our table reviews. So I'm going to type here insert into reviews, and here we're going to choose name, review, and book ID. Then I'm going to type here values, and for the values I'm going to put Alex. The review is going to be great book, and the ID for which I will add this particular review is going to be 1. So I'm going to add for the Fyodor Dostoevsky idiot the review. Then I'm going to close the parenthesis and I'm going to put a semicolon. And then I'm going to close the parenthesis, I'm going to put a semicolon, and I'm going to press enter. And now we have inserted our review into the table reviews. Now I'm going to type another insert into reviews. And here we're going to type amazing book. For the review, I also love the movie. And let's put an ID here, and I'm going to put the ID 2. So this review is going to be added for our Anna Karenina book by Lev Tolstoy. I'm going to press enter, and now we have inserted the data inside the reviews. Now let's select those reviews. Let's use a select from statement. So I'm going to type select from reviews to see the reviews, and have Alex, which wrote the review great book, and Anna, who wrote the review amazing book, and Alex wrote the review for the book which has the ID 1, and Anna wrote the review for the book which has the ID 2. Now let's say that I want to get back the title of a book, the review which was, or the name of the person who wrote that review for a particular book, and the review. And to do that, we need to use the join clause. And I'm going to type here select, and what I want to select. I want to select book that title. So I want to select the title of the book. It should be books actually. Books that title. Reviews that review. So I'm going to get the review. So now I'm using the second table reviews, and reviews that name. So I'm going to get also the name from books, And now we type join, and we type here reviews. So we are going to join the reviews on, let's go back here, on. So we type on in uppercase letters, and here we type on books dot id equals reviews dot book underscore id, put a semicolon. Now if I press enter, I get an error. It says no such table called books, and that is because here you should type here books, not book. And to have that statement, to not type that statement again, we can just press the up arrow key, and you're gonna have the statement added back. So if I press the up arrow key, this on Windows works. I have the statement back, and now if I go here and change this to books and press enter, let's go at the end to press enter. Now we get idiot, we get the review, great book, and the name of the person who wrote the review. Then we get Anna Karanina, and we get amazing book, I also love the movie, and we get the name of the person who wrote the review, Anna. So this is how you can use the join clause to join different tables and to group data together. And see you in the next video. Alright, so for this video I created a new table called groceries, which has an ID, primary key, a name, text, and a quantity integer. And below I inserted some groceries inside our groceries table. And I did that because in this video I wanted to show some aggregate functions. And the first one that we're gonna look at is sum. And sum, it can be used to sum the rows of a specific table. So in this case we can sum, let's say, the quantity of our groceries to see in total how many groceries we have. So we can type here select sum in uppercase letters, open parentheses, and here we type quantity. So we want to sum the quantity. We close the parentheses from groceries, and here we put a semicolon, and we press enter, and we get 16. So this is the total, the sum of all the quantities that we have. So those are the number of elements that we have in our table groceries, and this is the sum function. And you can also get the maximum value, the maximum quantity in our from our table. So we can type here select max. We also need to specify a row here, so we specify quantity here. So select max quantity, you close the parenthesis from groceries and the semicolon, and you press enter, and we get 6. And we get 6 because this is the row which has or this is the element which has the highest value. And we can also get the minimum value. So we can type here select min quantity, so we specify the row from groceries, semicolon, and press enter, and we get 1. So this is the minimum value. So those are some functions that you can use in your SQLite statements, and you see what they can do. You can sum, you can get the maximum value, you can get the minimum value, and so on. So see you in the next video. Alright, so I created a new table called exercise underscore logs, and I created a few fields: the ID, which is an integer primary key auto increment, so that is going to be added and incremented automatically; the type of the exercise, which is a text; the minutes, how much time it took to do that exercise; the calories, how many calories you burn doing that exercise; and the heart rate, so how up our heart rate did go when we did that exercise. And down I inserted some data in our exercise underscore logs table. Now let's say that I want to get all the exercises which burned more than 50 calories. To do that, I'm gonna type here select, and I want to have them order by the calories. So I want to have them order ascending from the list, from the smallest from the one which has who burn the smallest calories to the biggest one. To do that, we type here select from exercise underscore logs where calories, so we type here where the where clause, where calories greater than 50, and now we type the order by clause. So we type here order by calories, and we type in which order, ascending or descending. We're gonna type ascending, so from the smallest to the biggest. Then we put a semicolon and press enter, and we get biking and dancing, and those are the ones which burned more than 50 calories. And next, let's see how we can get all the exercises who burned more than 50 calories but which took less than 30 minutes. In this case, we need to use the AND operator. So I'm gonna type here again select from exercise underscore logs where calories greater than 50. Now I'm gonna use the AND operator to combine two conditions, and minutes less than 30. So now, and let's put order by calories ascending. Let's put semicolon and let's press enter, and we get, of course, dancing, because dancing is the one which took 50 minutes to do, and it's also the one which burned more than 50 calories. So our select works. So this is how you can use the order by to order your data, and this is how you can use the AND to combine two conditions in your select statement. And see you in the next video. Now it's time to download and install Android Studio. And Android Studio is the program that you're going to use to create Android apps. So open your browser. I'm going to open my browser. I'm going to type here download Android Studio. Press enter. We click on this link. Click on this green button to download Android Studio. Here we have the license agreement. I'm going to go scroll down, and you should read the license agreement. I'm going to accept, and I'm going to click on download Android Studio. Now the downloading is starting here on the top right hand side, and if you have a different browser, you will see this in a different place. Once the downloading is finished, just open this file. I'm going to close the browser. Now it's asking us if you allow this app to make changes to our device. I'm going to click on yes. I'm going to click on next. Here I'm going to click on next. Make sure to have this checked. This is the folder location where Android Studio is going to be installed. If you want to, you can change this location. So you can click on browse and you can specify a different location, but I'm going to keep the default location. So I'm going to click on next. And here I'm going to click on install. And now Android Studio is going to be installed in my computer. Now I'm going to click on next because the installation is completed. And I'm going to click on finish, and we have this start Android Studio checked, and that is going to start Android Studio. So I'm going to click on finish, and now Android Studio is going to open. Alright, so this is the welcome window of Android Studio. This is the place from which you're gonna create our projects. One thing that I want to do is I have here a shortcut. I assume that it didn't add a shortcut here, but if for whatever reason you don't have a shortcut for Android Studio, just search Android Studio, and right click on it and click pin to to taskbar. In my case, it's unpin from taskbar because it's pinned to taskbar. Because in that way you can easily access Android Studio. So I'm going to open Android Studio again. And here, if you have you'll probably have a different theme, because in my case it added this material oceanic theme, which I added in a previous version of Android Studio, and it implicitly imported the settings. But if you don't have this, I'm gonna use IntelliJ Lite theme, because this is better for tutorials. And again, you will not have this material oceanic theme, because that's a theme that I added in the previous Android Studio that was installed in my computer, and it implicitly imported those settings for me. And I'm gonna choose IntelliJ Lite for the course, because again, this is better for tutorials. So click on customize, and you can change the theme here. And if you want to add more themes, like the theme that I had previously, which was that material oceanic theme, this is darker. I will show you in a separate video how to do that. It's very easy. Now I'm gonna click on the left hand side on projects, and in the next video I'm gonna create our first project, and I'm gonna look at Android Studio to see what we have there. So see you in the next video. Now it's time to take a look at Android Studio to see how it works. Therefore, I'm gonna open Android Studio. You should open your Android Studio. On the left hand side, make sure that project is selected. I'm going to click on this plus button to create a new project. From those options that we have here, select empty activity, click on next. Here we need to give a name to our project. I'm going to call it app. This is the package name. We're going to look at packages in the future videos. Next, we have the location where the project or the app is going to be created, so you can change this if you want, but I'm going to keep this default location in D. Next we have the language, so on which language you're going to create this project. So we have here Java or Kotlin. I'm going to choose Kotlin. Next we have menu SDK, and by default we have this API 21 Android 5.0 Lollipop, and it says here that this app will run on approximately 98.8% of devices. So we're gonna keep this default selection. So I'm gonna click on finish. Now our project is gonna be created. Alright, so now it's working, it's building our project. Alright, so we have this tip. You can keep these tips, like I said in the discussion about IntelliJ IDEA. You can keep these tips because they are very informative if you want, but I'm gonna close now this, but I'm not gonna check this do not show tips because they are very, very informative. So I'm going to close this. And here we have what is called main activity. We're going to see what activities are. And here on the left hand side we have activity main.xml. We're going to look at that immediately, but we need to wait a little bit until our project is creating, until it finishes, because now here it's still working, and depending on what system you have, it will take more or less time. Alright, so now our project is created, and on the left hand side we have the project pane, and we have some folders generated for us. And here we have this thing called manifest. You can open this. You have these resources, so if you open this you have drawable, layout, minimap, values, you have XML. And we're gonna look at all of those individually in the next videos. For now we're gonna look just at a few things. So let's close that back. Now what we have now here is called the main activity, and here we're going to put all of our code. Here we're going to define our logic. Here we're going to define the code which is going to interact with the UI components. And the UI components are in this file called activity main.xml, and XML is it's some code. So if you click on this activity main.xml, you see that we have here a preview of your app, and we have in the middle we have this this is called the text view. We have a text view which says hello world, and this is the preview. And here you can go here where on the right hand side on the top, and you can click on code to see the XML code which corresponds to the UI components that we have here. In our case, we only have a simple, we're gonna see what all of this, what the image view, what a recycle view that we have here is what a text view, what an edit text view is. For now, all we need to know is that this is the preview of the app, and here we can drag. So if I can delete this, so I'm gonna yes, I can delete this. And as you saw, that was constrained. It had those lines that were there. So now I can take from here at text view. So you can click here text. Let's see, we already have a text view. So on the left hand side here we have text, and I can take a text view here, and now I can put this text view here and a text view. And while I'm doing that, as you can see, this preview is showing me where is the center. So I'm gonna put it here, and now we have those things that are here, and those are for constraining this text view so that it not goes down, up or down, or on the left or on the right. So you can constrain that thing to stay in the center. And if you let it like this, the way we have it here, it will go up or down or on the left. Not in this order, but the idea is that it's not gonna stay in the center. So what you need to do is to constrain this. And what we are doing now is that we are adding the UI components directly. As you saw, I took the text view. Again, we're gonna see what a text view, what an edit text view, what a password. We're gonna look at all of those. All of those are. For now, a text view, you just need to know that is something. It's a UI component with who you can display text. Again, let's come back to what I said previously. So now this is not constrained, so it will not stay in the center, even though I put it here in the center. What you need to do, you need to constrain it. And to constrain this, we click on this this circle, and we push this up. So we're gonna go here. As you can see now, it's go up. Now I'm gonna constrain it down. So I'm gonna push on that circle. So I'm gonna constrain it down. So now it's constrained up and down. So now it will stay in the vertical line. It will not go up or down, but it will go left or right. So you need to constrain it also left or right. So I'm gonna constrain it on the left, and I'm gonna constrain it on the right. And now, no matter what we do, this text view will always stay in the center. All right. Now let's see what we are doing now. Here is we are adding the UI components directly in this preview, so you don't use the what is called the XML code. And here we have constraint layout, and this is basically, as you see, when I click on this, you have those selected. This is because inside the constraint layout is the text view. So inside the constraint layout is the text view, and the constraint layout is like a container which has some specific properties. Now let's look at the XML code to see what the XML code looks, because we're gonna also work with the XML code. And while we're gonna progress in this course, I'm gonna let you choose to either create your UI components directly here using the preview and the panel that we have here, or to use the XML code. Now let's see the XML code. To see the XML code, we click here where it says code on the top right hand side, And now we have the XML code here, and this is the XML code, and I'm gonna see what all of this is, how this works, what all of those properties are doing. Now, as you can see, first at the top we have the constraint layout, so it's starting here and it's ending here, and within the constraint layout we have this text view that we added previously, and this is the XML code, and we're gonna look at how to work with XML code in the future videos. Now I'm just give you a little introduction to see how all of this works. Now we're gonna go back to design to see the preview, so I'm gonna click on design. And we're gonna go back in the main activity where we're gonna put our code, which is gonna interact with the UI components that you saw previously. Now, let's see how we can run our program to see how it looks. And to run our program, we click on this run button, but now we have no devices, and here we need to create a device. You need to create a virtual device, and a virtual device is simply a virtual phone on which you can see your app. So I'm gonna select, I selected the device manager, and you choose virtual, and you click here where it says create device. Click on create device, and now I'm gonna create a device. We're gonna choose a phone from the left hand side here. I'm gonna click on next. And also you need to select here what kind of phone. I'm gonna choose, let's say, let's choose this Pixel X Pro. So you select on the left hand side phone, and we select Pixel X Pro. So this is the virtual device, this is the virtual phone that is gonna be created on which you're gonna run our apps. So I'm gonna click on next, and that now is gonna create our virtual phone. We let this R selected here. I'm gonna click on next. And here, this is the name of the device. So I'm going to click on finish to create the device. So now the device is created. The only thing left is to run our device to see how our app looks. And to do that, we click on this run button that we have here. And now we wait a little bit. Alright, now it's connected to the emulator, to the virtual phone. Alright, now our virtual phone is starting. Alright, so now our phone started, and we have our app opened, and we have our text view here in the center. And as I said, it's in the center because we constrained it, so it will always be in the center. So if I go on the left hand side here on activity main.xml, and I go, let's actually, to hide the emulator, just click here where it says emulator on the right hand side. So I'm going to click on emulator. So if I don't constrain this, so let's delete the constraints. You don't need to do this. I'm gonna do this because I want to show you how, because you don't constrain this, it will not stay in the center, even though you put it here, let's say, in the center. Now let's go back to main activity. Let's click on the right hand side on the emulator. Now let's rerun our app. So click on this button that we have here to see where our text view is now. So now our text view is here on the left hand side on the top, because now it's not constrained. So let's constrain it back, because I want to show you also another thing. So let's click on the emulator to hide it. So let's constrain this vertically and horizontally. I'm gonna go back on main activity, click on the right hand side on emulator. Now, this emulator, you can have this emulator showed in, let's actually rerun our app to have the text view in the center. Click on terminate. Now, this emulator that we have here, this virtual phone, we can have it on different places on our Android Studio. And to see how we can change the place where the virtual phone is showing, we can go here, up here, and click on this settings icon. So click where it says show options menu. And here we have a few options, and we have here view mode. So we go here where it says view mode, and the current mode is dock pin, and you can select another one, let's say dock unpinned, and that didn't do much. So let's choose another one. Let's choose window. So if you choose window, you'll have it in this way. And let's go again to view mode, and you click again on dock pin. So now we have on the right hand side again. Let's click on the view mode again, and you also can have it floating. So you can have the emulator floating. So if you close Android Studio, actually it will be shown Android Studio. So you can have it here floating. So you can move this, as you can see. But it's up to you what do you prefer. I prefer to have it dock pin on the right hand side. So this is our discussion about how Android is not comprehensive discussion about how Android Studio works, but this is an introduction on about Android Studio, what is XML, and we're gonna see what all of those folders that are here. I'm gonna look individually at them. I'm gonna look at how we can write XML code. We're gonna see how we can add the UI components directly, and we're gonna see what is better. You can choose what option you want. Also gonna look at this Gradle to see what is this Gradle that we have the manifest and all of this. But we're gonna do all of that in the next videos. Therefore, now I'm gonna end the video and see you in the next video. Now it's time to take a deeper look at Android Studio, and particularly gonna look at the project pane on the left hand side and the folders which are within the project pane. So if you don't have this opened and you have something like this, just click on the left hand side on project, that is gonna open, and we're gonna click on this greater arrow in front of app, and here we have a few folders. The first folder that we have here is called manifest, and if you open this, so if you press on this greater than sign and you go inside this file, here we have some code, and I'm not gonna talk about this now, but we're gonna talk about this in the future videos. So I'm gonna close this. Next we have Java. So again, click on the greater than sign, and here we have a few packages. We have com.example.app, we have com.example.app Android test, that is for testing, and we have com.example.app. So I'm gonna click on the greater sign in front of that, and we have our main activity, and the main activity, and that is inside this package, is the place where we're going to put our logic, our code that is going to interact with the user interface. Now if you go down here where it says resource, or it says res, this stands for resources, and if you click on this, you have a few folders here. You have drawable, layout, meme map, values, XML. Let's start with the first one, drawable. And drawable, this is the folder on which you're gonna put all of our images, because when you build an app, you will have images which are gonna be showed in our app, and this is where you're gonna put your images. So I'm gonna close this. So this is where we put our images. Next we have layout, and layout basically means what the user is gonna see. So we have single layout here, activity.main. So this is the layout which corresponds to the main activity that we had here, and which is this layout that is here. So if I double click on it, it's gonna open it's gonna open this thing that we saw in the previous video. And if you go to code, here we have the code of the activity.main layout. So the layout is what the user sees, and here we're gonna put our layouts. Here we can have multiple layouts. Now I'm gonna go back to design. So here we have our text view, so it's centered. Right, so I'm gonna go to code. Let's go back to main activity. Now, next we have another folder, which is interesting, called meme map. And here we have IC Lancer, and you click on this greater sign. And if you double click on this, we have this icon. And this is the icon which you're gonna see when you download the app. And you have multiple icons here because they have different sizes. So actually, let me run the code to show you how that icon looks. So I'm gonna run this. Alright, so now the app started, and now if I close this app, and if I look at the apps that I have in this virtual phone, you see that we have this icon here, app, which is our app that we created. And that icon is the icon from this place. So that's the icon that we have there. Alright, let's bring this back. Now let's go down, and we have another folder here called values. And if you click on this, you have colors and strings. Colors, here inside the colors, we're going to define all of our colors that we're going to use in our app to give it a more beautiful look. And here we have a few colors. They are we have this hashtag, and we have the hex code of the color. And you see that we have the color. And here you can add more colors, and you're gonna see how we're gonna do that in the future videos. So I'm gonna close this. So here is when we put our colors, which are gonna be used in our app. Next we have strings, and here is the place where we're gonna put all of our strings, all of our text that is gonna be displayed in the app on many places, and that is gonna be added here, and gonna use that. Because actually, let me show you. If you go inside this manifest file, you see that here we have Android label, and we have at string app.name. So if I hold control on this, and when I hold control and I press enter, it took me inside the strings, because this string, the value that is defined here, because as you can see it's using this address to get the string that is defined here. So this is where we're going to put our colors. So let's close this, let's close the manifest file, and let's go down. And next we have themes, and this is where we're going to define the theme, which is going to be the theme of our entire app. So we have here some things, and here we define let me hide the emulator, and here you're going to define your theme. And as you'll see in the future videos how we're going to create, how to personalize our app to make it beautiful. So we have themes here, and let me close a few folders from here because it looks so let me close this. And next we have these Gradle scripts, and those folders we're gonna look in the future videos, because now we're not interested for now in this. So this is what Android Studio has here on the left hand side. This is what those folders this what those folders are. This is what they are doing. Some are storing images, some are storing layouts, so what the user sees. Some one is storing the icon of the app, one is storing the values, which is colors and strings and so on. So this is our discussion about about the folders that we have on the left hand side of the project, and see you in the next video. So an Android app is divided into 3 parts when developing application. The first part is called the front end, and this is what the user sees. This is with what the user interacts, the actual app. The second part is called the back end, and this is the code, the logic that we wrote, so that we, the developers, can see. And when building an Android app, what you'll do is you'll use the Kotlin code to interact with the resources. So you'll have the code interacting with the UI components, with the drawable, with the layouts, with the values. This is what you'll do when you're building an app, as you'll see. Now let's take a look at the folder layout, because I want to talk a little bit more about what we have here. So let's open it actually from here. Let's hide the virtual phone because I don't need the virtual phone. And here we have the preview of the app. So we have a text view here in the center, and here we have a preview, but without the background and all of this stuff. So now we are adding widgets using the design mode that is selected here. And what that means is that we can take directly whatever widget we want, and you can add it, you can drag it here in the preview, and that is going to be showed in the app. So if I take this button and I drag it here, now it's going to be added here. Let's constrain this horizontally. So let's click on this circle. Let's drag that arrow. Let's drag this arrow on the right also, and let's also constrain it vertically. Now I want this button to always be above the text view, and in order for that to happen, we need to drag this arrow from that circle to this circle of the hello world here. And now, as you can see by the guides that we have here and here, now our button will always be above the text view. Now let's select the text view. So make sure that you click on the text view, and the text view is selected. And now on the right hand side we have the attributes of our text view. So here we have the properties that can be changed. The first thing that you can do is that you can move this up or down from here, and this is interesting. What you can also do is you can change the width and the height, and you can click here to match constraint, and now the width will be as big as the parent layout, so it will touch the margins. So let's change it back to wrap content. And wrap content means that it will be as big as the content in it, and the content is the text. So if the size of the text, if it has a lot of text, it will be big, then it will increase to match that text. So if I go down here now and I change the text, so I go down, I scroll, and I have the text hello world. So this is the text that the text view has. Let's go up because I don't know why it goes down. Let's select hello world. Let's select the text view. Now let's change this text to something else. So let's put some text here. Now, as you can see, this increased as the text that was added to it. So this is what wrap content means. So let's click back on the text view. Let's go down here and let's change it back to text view. So let's type here text view, and if it's not changing, just click here and it will change. Now we have text view. And this is fine. You can also add another widget. You can add an image here. So if I take this and I drag it here, I can put it here. And now it opened this drawable resources, and this allows us to pick an image because we drag there an image. So now it wants us to choose an image. So I'm going to choose this image and I'll click on OK. And now this image is added here, but so let's also constrain it horizontally first, then vertically. So let's push this down a little bit. Now if I want this image to always be above the button, we just drag this to our button circle here. So we drag that arrow there. Now let's push this a little up. All right, so what we did now here, we added a text view, a button, and an image view, and they are all added inside a constraint layout, and we added them using the palette. So using the widgets that we have here, we just drag them and we constrain them. We change their properties here on the right hand side. So this is one way to do the things. The second way, this is one way to add UI components. The second option is to go directly to code. And with the code, you can achieve the same thing, but you'll have to type the XML code in order to have what you had previously. So now, if I change this text view here at the text view, because this is the XML code for the text view that was displayed previously. If I change this to hello world, and now if I go back to design, as you can see, the text now is changed to hello world. If I go to code and I go to the button XML code, and as you can see here, you have Android text, so this sets the text of the button. If I change this to login button, and I go back to design, now the text is changed to login button. And you can also add another attribute here, so another property. So I can type here all caps, and I press enter, and by default all caps is set it to true. So the letters, the text that is going to be displayed on the button is going to be uppercase. So let's not uppercase the text, let's pass false. So now if you go to design, now the text is not uppercase. So the exact same thing that we achieved using the design and dragging them here, changing their properties from here, you can do the same thing here. So you can add a text view, you can add wrap content, so how was going to be the width, the height, you can make it visible, invisible, you can add text, you can constrain it. As you can see, here is constrained. And all of those views, all of those that are here, the button, the text view, and the image view, are inside this constraint layout. This is the parent layout. And for the image, I think, so for the image, you have here tools, src compact, and this is the location of the image. So if you hold Control and press enter, actually it didn't open, but anyway. And you can also change the image here to another image using the XML code. Now, I'm gonna end the video and see you in the next video. And this XML that we have here, and also the design component, the code component, you can use either the code to add directly the code and to add properties to your widgets, to your views, to your UI components, or you can use the design. What you find more easy, that is what you should use. But I should add here now that because in Android things are changing very rapidly, they release something called Jetpack Compose, which basically eliminates completely this XML and the design, and we create our widgets, our UI components directly from the code. But you're gonna look at that in a separate, in a future chapter. So I'm gonna end the video now and see you in the next video. And if you find this confusing, don't be. It's normal when you see this for the first time. Play with the properties that we have here on the XML, so from the code. Play with them with the design. Try to put another widget here to see what happens, constrain it, and so on, because this is how you learn. So I'm gonna end the video now and see you in the next video. Now let's look at other properties that we can use on our UI components. So let's say that I want to change the color of the text view. To do that, I'm gonna go on the right hand side, make sure that the view is selected, and I'm gonna go here, it says search, and I'm gonna type color. And while I'm typing, I have a few suggestions. You have text color hint, text color link. So I'm gonna choose this one, text color, and we click on this. And when you click on that, you have this palette, and now we can change. You can provide a different color here. Let's say that I'm gonna choose a blue color. So let's choose this one. Let's press enter now. And let's close this. And now our text view has the color blue. And let's go to the code now, because I want to show you what you can do with the constraint layout. And this constraint layout that we have here, as I said, is the parent layout, is the layout when which all of those child views are inside. So if I change here, let's say that I add another attribute for our constraint layout. If I type here background, and I'm gonna type here color, let's say, so we put at color, and let's go on our resources to now it's a good time to see how we can use the resources. So go to values and have colors, and we have here the color, let's say purple. So this is the name, so the color purple, and to get this color we need to reference this name in our XML code. So we type at color, we put forward slash, and we type purple, and we have our suggestion that the purple that we saw in the colors XML file. So I'm gonna press enter. Now if I go to design, now the entire background was changed to this color, and this was changed to purple. This happened because the constraint layout is the entire views, and all the views like the text view, the button, the image view are the child views, are inside of the constraint layout. So this is how we can do it using the code. Again, it's up to you what you can use. You can do the same thing using directly the design. So you can click on constraint layout, and you can change the color. So I'm gonna end the video now and see you in the next video. Now it's time to see how we can connect the code with the UI components. So how we can connect the code with the layouts, with the buttons, with the text views, with the images. And to do that, we need to use what is called r.java file. And this r.java file, what is doing is connecting the code with the UI component. This is basically what it's doing. And you probably noticed that you already have this R here, and what this R is doing now here is connecting this set content view function with the layout activity.main. So when our app is launched, when this function is called set content view, R is gonna go inside the layout and is gonna take this activity.main, and that is gonna be displayed for the user to see. Now let's see how we can let's first create a new layout. So I'm gonna create a new layout here. So I'm gonna click on this greater arrow in front of layout. I'm gonna right click, and I'm gonna create a new layout. So we go to new, and we select this layout resource file, and I'm gonna call this layout let's say new layout. I'm gonna press OK, and it's created a new layout. I'm gonna put a button here. I'm gonna constrain it. So I'm gonna constrain it horizontally and vertically. Now, what previously was that this layout and the set content view is gonna set the activity.main as the view that the user is gonna see when it launches the app. So when you go to is gonna see this, but I want to have this. I want the user to see this layout when it launches the app, and to do that, we change this activity.main. We change this, so we delete this, and we type here new layout. And now if you run this code, now you'll when this set content view is gonna be called, r.layout is gonna go inside the layouts that we defined here, and it's gonna set the new layout that we create. So now our app is creating. Alright, so our app launched, and now we have this new layout that we created previously, and we have the button here in the middle. Now it's time to see how we can connect the button that is inside our new layout with the code. And to do that, first I'm gonna go inside our new layout. I'm gonna hide the emulator because I don't need the emulator, and I'm gonna go to design. And one important thing to understand is that all the widgets that we have here, all the UI components, are objects. So we can represent them in code. We can create a button object and we can connect it with the button UI object that is here. So, but how to connect them? How we gonna connect them? Because here, when you connected the layout, here we use the air.layout.new layout. And to connect the button with the button object that you're gonna create, to connect the button object UI with the button object that we're gonna create, you need to give an ID. And I think by default that already has an ID. And this is the ID. The ID is button. So we're gonna use this ID to connect the button that we have here with the button object UI with the button object that we're gonna create here. So I'm gonna create here a button object, and I'm gonna type private later init var button. Now I'm gonna go down here, and here I'm gonna type button. And now I'm going to use a function called find view by ID, and this function is the function which is going to connect with using the r.java file. Is going to connect our button object that we created above with our button object that is inside our new layout. So I'm going to type here find view by ID. I'm going to type here r, so the thing that connects the code with the UI, r.id button. So we have our button here. So if I hold control and I press click on this, it took me inside here because it knows that we are referencing this button. So now the button that we created here, it's connected with the button UI that we have here. So those now are connected, and because they are now connected, now I can do, because it's an object, I can call functions on this button. So I can type here button dot text, gonna put equals, I'm gonna put here, let's say login button. So if we rerun this, select terminate, now we have the text login button, and we can call another function. We can say here button dot text or button dot color. I don't know what was that called. I don't remember how that was called, but you can call more function on this button, like changing the color and so on. So this is how you can connect a UI component object with an object that you create in your code using this function find view by ID and the R Java resource file. So this is our discussion about the R resources file and how we can connect UI objects with with the objects in our code. So see you in the next video. Now it's time to look at strings, but first let me show you how you can change the color of the text of the button, because previously I forgot how that function was called. So we go down here, we type button dot set text color, and here we type color dot, let's say, green. Now I'm gonna click not on this run app. I'm gonna click on this apply changes and restart activity, so that you don't rerun our app. So now we wait a little bit, and we get now the text login button green. So now I'm gonna delete this because you don't. I just wanted to show you how you can do this. So I'm gonna delete this. I'm gonna apply the changes now back. Now I'm gonna go. This is opened, but I'm gonna go inside the strings file. So I'm gonna click on values. I'm gonna create arrow, and I'm gonna go inside the strings. And here is the place where we're gonna define all of our strings. All the text that you want to have displayed in our app should be defined here. And now you may be wondering why. Let's say that you have this button text, login button, called in many places. And if let's say that you want to change the text, and the text is hardcore like this, so you type directly the code, you have to go in all the places where you type the code and type a different code. But if we put our code here, so we go down here, we add opening tag, we type string, and now we need to give an ID because we're going to use this ID to call this string later. So I'm going to call this button text, and it's going to have and here between those two I'm going to put the text, and the text is going to be, let's see what text we had previously here, login button. So I'm going to type here login button. Now I'm gonna go inside the main activity, and now instead of having this text typed here, I'm gonna delete this, and I'm gonna type get. So type get string, and now you pass the ID r dot, and now we are going inside the string XML files. So it's string dot button text. So now is going to use the text which is inside the string XML file that we defined. And now if you think about, if you are using this this text in many places, and you want to change the value of the text, if you hardcore the text, if you type the text yourself, you'll have to change the text in every place. But because we are using the text which is inside the string XML file, we only need to go here, we change the text here, and it will be reflected in all the places where we use r.string.button text. So this is why it's good to use strings in this way. So now I'm gonna end the video and see you in the next video. Now it's time to look at the manifest file. So I'm gonna go on the left hand side, I'm gonna click on this greater arrow in front of manifest, and I'm gonna double click on this android.manifest file. And this opened the manifest file for us, and what we have here is also XML, and at the root here we have manifest. Now what the manifest file allows us to do is to define the structure of our application, so we can define what our application can do or can't do. So this is what the manifest file basically allows us to do. And inside the manifest file we have this application, and inside the application we have an activity. And first let's look at the first property that we have here, and this is allow backup. And basically what this is gonna do is after you publish your app and it's on a real phone, that app can be backed up. So this is what this is doing by having true here. Next we have an icon, and the icon is as you can see on the left hand side here, the icon that we looked in our previous video when we look at meet map at this file, at this folder here. And next we have app, and this, as you can see, if I click on this, we have add string app.name, and if I hold control and press enter, it took me here inside this string that is defined here. So it's using the app text that is defined in this string XML file. So this is what that is doing. Here we have the round icon. So we have again the icon that we talked about, but we have the round icon. Next we have this thing, but we're not interested in this. And next we have this thing called Android theme. And this is basically the theme of the entire application. This theme is gonna be also the theme for all the activities that we're gonna create, because we can create more than one activity. We can have more activities, because now if I go down here, as you can see, we are inside the application node, and inside the application node we have another node here called activity, and inside the activity we have Android name and we have main.activity. So what we are doing here is we are registering in our application the main activity that we created. This is basically what this is doing. Next we have this thing called intent filter, and what this basically is doing, because here we have an action and then we have this Android.intent.action.main. What this is basically doing, because we have also here category and have Android.intent.category lancer. What this intent filter, which is inside the activity that we attach here, main activity, what this is gonna do, when you run your app for the first time and suppose that you have two activities, because inside the main activity, inside the manifest file of the where you have defined the main activity, you have this intent filter, and we have those specific action here, Android.intent.action.main. What this is gonna do is that is gonna open the main activity as the first screen, so it will not open the second activity if you have a second activity. And if you move this intent filter, and we'll do this in a future video, in another activity, it's not gonna open the main activity first, it's gonna open another activity. So this is what we have here. And also we have here metadata, but this is not, we're not interested about this now. And then we have the node closing, and we have our main activity here defined. So this is what the manifest file is doing. Another important thing that we can do in manifest is that we can ask for permissions. So I can go up here, and let's say that you want to use the internet connection. When you will do that, you will need to first ask for permission. So another thing that we can do is that you can ask for permissions, and the permission can be to ask for to access the internet connection, to access the camera, or I don't know, to do all kind of things. And in that case, you have to explicitly type here uses permission. So I'm gonna open a tag here and we type use permission, and I press enter, and now here we have a lot of options. So we have access course location, so you can use this permission to ask for the location. So you're gonna, and you saw probably when you used your apps on your phone that when it's using the location, it's asking you if you allow that app to use the location. And this is where we define those things. So in order for our app to be able to get the location, we need to define the permission here, and you also need to write some code, but we're gonna see how to do that in the next video. So we have a lot of things here, like network state, notification policy, surface string, Wi-Fi state, and manager, and many things. So this is our discussion about manifest file, and see you in the next video. But before we end our video, let's first see what this support TC-RTL is doing, because I did a search, and what actually that is doing is, if you look on Stack Overflow, somebody asked what that is doing. So what is the use of Android support TC-RTL equals true. And if you look at this answer, it's saying if you are building an app in Arabic, Urdu, or Hebrew, or any language that is written from right to left, you should set Android supporter cell to true. That's how you tell the layout to be from right to left, and the default value of this attribute is false. But in our case was set it to true. So this is what this support RTLs is doing. And if there are things that I omitted here, you can search, can do a simple search on Stack Overflow and you'll find an answer. So I thought that it's a good idea to also tell you what this is doing. So now I'm gonna end the video and see you in the next video. Alright, so now that we have an idea what a button and what a text view is, let's start building a little more complex app. And I'm gonna delete this code because I don't need this code, because we're gonna create another button, or we're gonna use the button from our activity.main.xml. So I'm gonna click on this, and it took me inside the code, inside the XML code. Let's click on design, and let's change this background. So let's click back on code, and let's delete this background because we don't need this background. So let's delete this background. So another thing is that you can see this I show you that you can use the design and the code, but you can also use split, and you can have both the XML code on the left hand side, and you can have the design on the right hand side. So this is nice to know, and this is very beautiful to have in this way. I'm gonna click back on design, and I'm gonna delete this image view, and you can delete it from here. So you can right click on it and delete, and now it's deleted. Let's press Ctrl Z to see if I can put it back. Okay, so we have it back. Or you can delete it from here. So you go here and we delete so here we have the opening tag, and we delete the image. So we delete this, and now when I go back to design, the image is gone. Now let's also make this text view a little bit more, so a little bit bigger. So let's type here size. Again, you can do this thing from the code, but I'm going to use the design. So we have text size, and the text size is 14 sp. So let's change it to, let's say, 24 sp. Alright, so now our text is bigger. We have our text here. Let's push this button a little bit down. Now I'm gonna go back to main activity, and I'm gonna go inside the strings because I want to change the text of the button. So I'm gonna change the text of the button to show. So we type here show, and now I'm gonna go back inside the main activity, and let's go back inside the activity.main.xml because we need to give some IDs to our buttons and to our text view, so that we can reference it. So we can also use again the code or the design. I'm gonna use the design, so I'm gonna click on the text view. So let's add an ID to the text view. So I'm gonna type here ID, and now the ID is this text view, and let's change it to my text view. So my text view. Alright, so this is the new ID, and let's also change the ID for the button that we have here. And now the ID for the button is this button 6, and let's change it to my button. Alright, let's go to code to see that we have. Click on refactor. I have to refactor and here you don't have my text view because I didn't click on refactor previously. So let's go to the text view again, and let's type here my text view, and we press enter, and now it's asking us if you want to refactor the ID, the name of the ID. So I'm going to click on refactor. So this is why it wasn't changed previously. Now I'm gonna go inside the main activity, and now I'm gonna reference the button and the text view, and I'm gonna connect the button object with the button widget and the text object with the text widget. So I'm gonna type here first private late init, so late initializer, my button is gonna be of type button, and here I'm gonna type again private late init, and I'm gonna type here my text view. And now it's good, this is gonna be a text view, so I'm gonna put the type text view. So type here text view. You choose this one. Now we need to connect the button and the text view, and to do that we need to use the find view by ID function to connect them. So I'm gonna type here my button. So type my button and put equals, and we type here find view by ID. And now we use the R to reference the ID, so to connect the resource with the resources. So r.id dot, and we have the ID my button. Let's also, there is a problem here. Okay, the problem is that this button that we have here is inside the activity.main XML, but here we are setting the content view for the new layout, so it can find this. This is why you have here an error. So if I change this now to activity.main.xml where the button is, now the error should disappear. So let's type again r.id.myButton, and so we still have an error. Alright, so now everything works. We didn't have the error, we didn't have the warning here, because now we connected, we referenced the activity.main layout where my button, where this button is. Now I'm gonna go down here, I'm gonna type my text view, I'm gonna put equals, and I'm gonna type again find view by ID, r.id dot my text view. Now I'm gonna go back inside the activity.main. Let's go back, let's go to design. I'm gonna click on the text view, and let's make the text view invisible. So let's type here visibility, and now it's set it to visible, but let's change it to invisible. So now our text view is invisible. And so now we created our button and our text view, and we have connected them with the UI components. So you connected them with the widgets that we created. And next we're gonna click on the button, and when we're gonna click on the button, we're gonna make the text view visible, and we're gonna change the text of the text view. We're gonna add some text to the text view, and we're gonna do that in the next video. Now it's time to see how we can handle clicks on our button, so that when you click on our button, a particular section of code is gonna be executed. In our case, when we're gonna click on the button that we have in activity.main.xml, this button, when we click on this button, we want to make the text view that is here visible, and we want to change the text of the text view, and this is what we're gonna do. And let's first change the text of the button, because now it says login button. And to do that, I'm gonna go down here, and I will type my button, press enter, we put equals, and now I'm gonna go inside the strings file, because there I declare the string, and we have this button text, the ID, and I changed it here the text to show, because previously you saw that here it was a different text. And now I'll go back to main activity, and now if I type here actually here it should say m.button.text, so you're setting the text of the button, equals, and here if I type r.string.button text, we have an underline and we have an error. and it says type mismatch, required char sequence and found int. This is because this is an integer address, so this is not the actual string, this is an address to the string, and in order to get the text that is at this address, we need to use the getString function, which is gonna get the string, the text at that address. So we type getString and we type here r.string dot button text. So now if I go in activity.main, it should anyway, this will be changed when you run our app. Now, how we can handle clicks on our button? To handle clicks on our button, you go on the attributes, you go on the right hand side and you go down, and while I'm going down, you go, and you see that we have this thing on click, and if here we need to define the name of a function, and when you're going to click on the button, the function is going to be called. So if I type here show message, now I will create this function inside the main activity, and when I will click on the button, this function is going to be called. So I'm going to go inside the main activity, and I will go down here, and I will type fun show message. It should have the same name that we defined in the design. So show message parenthesis, and now we're gonna say here my text view dot visibility equals view dot visible. So we make first the button the text view visible because it's invisible, and now we change the text. So I'm gonna type here my text view dot text, and now I'm gonna hardcode the text. I'm gonna type directly the code, but we're gonna create a string resource for this. So I'm gonna type here hello Alex. Now if I go back here, nothing happened because this code is going to be executed when you click on the button. And you also need to define here a parameter called view, because the button that we created is a view, and if you don't define here the parameter view, our app will crash. So look, if I run this, look what happens. So if I run this, alright, so now we have our button, we have our app opened, and if I click on the button, the app crashes because we didn't pass the view here. So if I put here view of type view, this one, now if I run this up again, now the app opened. Now when I click on the show button, look what happens. We have the text being visible, and then we have the text hello Alex here. So this is one way to handle clicks on the button. There is another way to handle clicks, and I'm going to show you how to do that now. So the other way of handling clicks on our widgets, because we can handle clicks not only on the button but on all the widgets. And why we can handle clicks on all the widgets? That is because if you go here activity.main, let's hide the emulator, all the widgets that we have here, the buttons, the text views, all of those, they are inheriting from a class called view, and the class view has a lot of functions, a lot of functions which the class which are inheriting, the derived class are having access to all of that functionality. So this is why you can handle clicks on almost any widget, actually on any widget. And what we can do here, instead of declaring this function here and doing in this way, what I can do is I can attach an event listener to the button. So more specifically, I can attach one click listener on our my button, and what that is going to do, when you're going to click on the button, the code is going to be in the, because we're going to use what is called actually we talked about this in our first part of the course. We're going to use a lambda in order to define the body of the listener. So I'm going to type here my button, and I type here dot, and I type set, and I have some suggestions on. So we type on click, so on click listener, and we choose this one which has this lambda that is here. So I'm going to press enter, and now when we're going to click on the my button, now the code which is inside this lambda is going to be executed. So this is this is the my preferred way of handling clicks, and this is my suggestion for you to use, because it's easier and more concise. Now I'll type the same code here. So I'm going to type here my text view dot visibility equals to view dot visible, and my text view dot text, and now I'm gonna create a resource string. So I'm gonna go inside the strings. I'm gonna create another string here. I'm gonna go down, I'm gonna open the tags, I'm gonna type string, I'm gonna call it text view text, and it's gonna say hello Alex. Now we go back inside the main activity, and here we type get string to get the string from the address. So I'm going to type r dot string dot text view text. So now if you run this, our app opened, and if I click on the show button, we have hello Alex, and so it's executed the code inside the lambda because we set on click listener. So this will listen to clicks on the button, and it's going to execute the code inside the lambda, which is to make the text view visible and to set some text to the text view. So this is our discussion. My suggestion is to use the set on click listener whenever you want to handle clicks on your widgets. And see you in the next video, where we're gonna take a look at another widget, very important. Now it's time to look at another widget that you can use in Android, and that is an edit text. And with an edit text, you can type text from the keyboard or from the phone, and you can get that text, you can do whatever you want to do with that text. So I'm gonna go inside the activity.main, and to add an edit text, we go here on the left hand side, make sure that text is selected, and we drag this one called plain text, and I'm gonna put it above the login button. But in order to stay above the login button, let's first constrain it horizontally and then vertically. So let's constrain it. So now it will stay always above the button. And let's change this text, because now it has this text name. So let's delete this, and let's add a hint. And the hint is what the user is gonna see. Is some gray out text which the user is gonna see. So let's type here, enter your name for the hint. So we have, right? So now we have enter your name. Now let's go back inside the main activity, and now we need to create an object. So I'm gonna type here private. Let's push this a little bit down. Return it var edit text, and we type for the type edit text. Also, let's give it an ID. So let's click on this, let's search, let's type ID. Okay, so let's change the ID to only edit text. let's put with uppercase T, and let's go back into, let's click on refactor, and let's go back inside the main activity. Now I'm gonna go down here because inside the onCreate function is we're gonna set up all of our widgets. So down here I'm gonna type edit text equals, I'm gonna type find view by ID r.id dot edit text. So now we have the edit text connected with alright, so now we have the edit text connected with the edit text that we created above here. So let's press Ctrl Z because I messed up the code. Alright, now what I want to do is because now if you run this, so let's run our app. Click on terminate. So we have our text and we have the hint, enter your name. Let's change the hint because I typed T 2 times there. So let's go here, let's type hint, let's delete a T, let's press enter. Let's go back, let's run our app again. Click on terminate. And we have enter your name. And now here you can type text. As you can see, you can type it directly from the keyboard or from here. So we type here Alex. Now let's see how we can get the text that we type here, and how we can display then that text inside our on our text view. And to do that, I'm gonna go inside the my button because we're gonna show the text, we're gonna get the text when I'm gonna click on the show button, and I'm gonna go here and I will type val. So I will declare a variable call input. So we're gonna get the input text, put equals, and here I'm gonna type edit text dot text. So now this edit text.text is gonna return the text that the user typed here. So whatever text you type here is gonna be returned and is gonna be assigned to the variable input. So now what we can do is that you can delete this get string and r.string.text you test, because we're not gonna get the text from our strings XML. I'm gonna assign the input that is passed to us from the keyboard or from. So now if I run this up, and if I type here Alex and I press show, now it's showing Alex. So it's taken the text which is returned by this, it's assigned to the variable, and then this is assigned to our text view text, and we see here Alex. But what I don't like is that if you hover over, it says that this is an editable, it's not a string. So we didn't run into a problem because we passed this editable and not a string. But I prefer to put here to string in order to convert that from the different format, from the format of editable to a string. So now if you hover over, now this is a string. Now if you run this up again, it will work the same. So if I type here again Alex, get Alex, but now we don't have that underline, and I think that was probably because of the editable. So now I converted that to string, so now it's a string. But our app has a problem. What if you don't pass anything? Not here, so not here. So let's press Ctrl Z. What if I rerun this app? click on terminate. And what if I don't type any text here and I click on show? What is gonna happen? So let's see. So when I click on show, nothing happens because we didn't pass any kind of text. We didn't type any kind of text here, so we didn't assign any text to our text view text. But a better way to write this code would be to check to see whatever the input is empty or not, and if it's empty, to say to the user to enter some text. So let's do that. And to do that, I'm gonna go up here and I'm gonna type if. I'm gonna type here edit text dot text dot to string. So the input, what the user typed, is empty, or is blank. You can use that one if you want. Is empty, and I'm gonna put the logical not operator in front. So if it's not empty, so let's press enter, and now we have an underline here because we can replace it with the negation. It's not empty, but let's leave it like this, or let's change it to it's blank. Is blank, and we have the same underline. So let's put this empty. So now what we're checking here is if the user types something there, then I'm gonna take this code and I'm gonna put it inside the if. I'm gonna take this code and I'm gonna put it inside the if, and I'm gonna add an else part. So else, so if the user didn't type anything, then I'm gonna create a string here. So I'm gonna create a string here, which is gonna be edit text or text view text message, and it's gonna say please enter some text. And now I'm gonna use this ID. I'm gonna go inside the main activity, and here we're gonna type text view text view, my text view dot text. I'm gonna put equals. I'm gonna type get string, and I'm gonna the string that we created previously. So I'm gonna type here r dot string dot text view text message. So let's hide the emulator to think about what we have here. So first we check to see if we have input from the edit text. This is what you're doing here. So if this is not empty, then we're gonna assign that text of the variable. I'm gonna make the text view visible, and you're gonna assign that text to the text view. Let's also make it visible here. Else, if we didn't type anything inside the edit text, we're gonna make the text view visible, but we're gonna so let's type here my text view. We're gonna make the text view visible, but it's gonna have the message that please enter some text. So that visibility, type here view that visible. So now if you run this, so let's first type Alex. So let's click on show. We have Alex. Now let's delete the text and let's not pass anything. So I'm gonna click on show, and now it's executed the else part. It made the text view visible, and it said please enter some text. And this is very, very beautiful. We have even though it's a simple app, we have something. So this is our discussion about edit text, and play with this, try to do different things and so on. So I'm gonna end the video now and see you in the next video. Now it's time to create an app which is gonna convert inches to centimeters. But first let's create a new project. So I'm gonna go here on the left hand side on the top. I'm gonna click on file, I'm gonna go to new and click on new project. We're gonna select an empty activity here. Click on next. I'm gonna call this inches to centimeters. And I'm gonna click on finish. We'll let the language Kotlin, and we'll let also this location by default. So I'm gonna click on finish. Now our program is gonna be created. Alright, now our project is ready, and the first thing that we need to do is to configure the activity main.xml to add the widgets for our program that we're going to create. So I will go inside the activity main.xml, and here I'm going to add first an image up here. So but first let's add the image here inside the drawable. So click on resource, on drawable, and actually we cannot add it from click on project manager, and here we have drawable, color, layout, minmap, and click on this plus button because we're gonna add an image from our PC. So I'm gonna click on this plus button, and we select this import drawable. So I'm gonna click on that, and we select this image from the desktop. So I'm gonna click on OK, I'm gonna click on next, and I'm gonna click on import. And now we have the image inside our drawables folder. Let's click back on projects. Let's go inside the resources and inside the drawable. And now we have our image here. So if you double click, you see that we have this image here. Alright, the first thing that that we need to do, let's delete this text view because I will add it later. Let's go inside the code to delete it because alright, so the first thing that we need is an image view. So we can search it from here, and we can type image view, or you can select it from here because it's here. So I'm gonna select this image view, and I'm gonna put it here. And when I did that, it opened this window for me, and it also selected the drawable folder because now we can add an image to the image view that we added there. So I'm going to select this image. I'm going to click on OK. Alright, so now we have our image. Let's make it smaller. So let's make this image smaller. And let's bring it up. Let's add the constraints. Let's constrain it also vertically. Alright, so now I have our image view. I'm gonna let it there. The next thing that we need is an edit text because we're gonna type our inches in our edit text. So we type here edit text, and we select this plain text. This is an edit text. We'll put it below here. I'm gonna constrain this also horizontally, and it's gonna be below this image. So let's push it down a little bit to constrain it. Alright. Next I'm gonna add a button, which is gonna be used to click to convert the input that we're gonna type the inches into centimeters. So I'm gonna take this button, I'm gonna drag it here, I'm gonna put it below the edit text. I'm gonna constrain this. Actually, let's constrain now this here. So it's always gonna be above our button. And let's also add a text view, which is gonna display the converted inches. So we type text view and have a text view here. Select the text view and add it here below. So we have our text view. Let's constrain it. So you constrain it to be below the button. Let's also constrain the button. For a teaser reason, so let me try to constrain the button again, but I can't. I don't know why. Anyway, I will leave it like this. I will push this text view up a little bit, and now this looks beautiful. We have our text view. Now let's look at the properties of our widget. So let's start with the edit text, and let's first change the ID to ID. Let's change the ID to edit text inches, and let's click on refactor. Let's delete the ID. Let's also change the text, because we don't need that text. So I'm gonna go down here. So we don't need this text name, but we want a hint. So what the user is gonna see when it's gonna open the app. So we're gonna see here, enter inches. So now we have enter inches. We have the button. Let's also click on the button to change the properties a little bit. So let's give it an ID first. So I'm gonna type here ID, and let's call it button convert. Let's click on refactor to refactor. Let's delete the ID. Now let's give it a different text, but let's go inside the values, inside the strings. So I'm gonna create a new string here, and I'm gonna call it button convert, and it's gonna say convert. Now I'm gonna go inside the activity main.xml, and here for the text, let me make sure that I have the button selected. For the text, I'll go down. So here you have the text, and here I'm gonna type add string, and I'm gonna reference our string that we created, button convert, and select this one. So now we have the text convert, and here we have the text view. And for the text view, let's see what we have here. Let's also give an ID to the text view. Let's call it so let's click here, let's type ID, and let's call it text view convert. So let's press enter, click on refactor, and now we have our widgets set up. Now let's run this to see how it looks. So I'm gonna run this. Alright, so we have our app open, but the button it's up because I didn't constrain the button. So let's constrain the button. So I'm gonna click on this button, and let's constrain it, because I can't constrain it in relation with the edit text and with the text view. I'm gonna constrain it directly here, vertically. So I'm gonna click here, I'm gonna drag here, and I'm gonna put the button here, and now it's gonna stay there. Let's run this again. Alright, so now everything looks fine, but we have the text button, and I don't know why. Let me go here. But we're gonna change this in the next video. But now everything is fine. We have our edit text, we have our button, and we have our text view, which is gonna display the converted inches into centimeters. And let's see how we can change the text of the button. For whatever reason, that wasn't changed. I don't know why. So let's delete this. Let's go down here. So we have string button convert, but why it's not? Actually, it should be here, not here. So here we need to put our text, our address. So let's delete this. Let me check first something. So we type string button convert. We run our app again. Alright, so now everything looks fine. Our app is ready to add the code, to add the logic, which is gonna convert the inches into centimeters. So I will do that in the next video. Now it's time to add the logic, which is gonna convert our inches into centimeters. But first we need to connect our widgets with the objects that we're gonna create here. So first we need to create, we have 3 widgets. First we need to create an edit text. So I'm gonna go up here. I'm gonna type private, laten it, entered inches, edit text, or let's keep it only as enter inches, and it's gonna be of type edit text. We type edit text here. Then we have a button, laten it, and it's called convert. I'm gonna call it convert button, and it's gonna be of type button. And next we have a text view, and then the text view is the text view that are gonna show the converted inches. So I'm gonna type here private, laten it var, text view inches. Let's actually call it text view centimeters, and it's gonna be of type text view. Now let's connect them with their ID. So I'm gonna type here first enter inches, our edit text, equals to find view by ID, r.id dot edit text inches. Then I'm gonna type convert button equals find view by ID, r.id dot button convert, and then I'm gonna type text view centimeters equals find view by ID, r.id dot text view convert is called. So we have an underline here because we should call this convert. So let's change it there and there also. Alright, so now we have our widgets connected. We have our objects connected with the widgets that we have here. Now let's see how many centimeters is an inch, because we're gonna use that value to convert our inches into centimeters. So I'm gonna close this, And I'm gonna open my browser. I'll go to Google and I'm gonna type here 1 inch. So 1 inch is 2.54 centimeters. So let's copy this. Let's copy this value. Let's close the browser and let's open Android Studio back. And let's add that value here. So I'm gonna type here private. Let's call it val because we're not gonna change this value. Inch. Let's call it value, and we're gonna assign that 2.54 centimeters. Now let's set on click listener on our convert button, because when we're gonna click on the convert button, we're gonna convert the inches into centimeters. So set on click listener, we choose this one with the lambda. And before we do that, let's first go back to activity.main, because now when you run your app, you'll see the text view, but I don't want to have that to text. So let's delete the text. So let's make sure that we have text view selected, and let's delete the text. Alright, so now it's fine. Now, to convert our inches into centimeters, we need to first check to see if the input, again, that the user typed is not empty. So I'm going to put here if enter inches dot text dot to string that is not empty, then I'm gonna add the logic to convert the inches that the inches that the user type into centimeters. I'm gonna press enter, and what we're gonna do here, I'm gonna create a variable called result, and here we're gonna type enter inches dot text dot to string. And now we need to also convert this into a number, because this is text that we have here. So we need to convert this into a number. So I'm going to put again dot, and we type 2, not that, 2 double. And now our text that is going to be typed is going to be converted into a double. And we're going to multiply that. By our inch value. So type here inch value. Then we're gonna call our text view centimeters, and we're gonna start text, and it's gonna be equal to result. Again, we need to convert this now into a string, because now this is if you hover over, this is a doubles, and here we can only pass text to the text view. So let's put that to string, and that is going to convert it to string. Let's add an else part. So if the edit text it's empty and it press the convert button, we're going to say text view text centimeters dot text, and we're going to add the text here. Let's call it string, and it's going to be text. I'm going to call it text, and I'm going to say please enter a number. I'm going to go back inside the main activity. I'm going to type here get string r.string.text. Alright, so now our logic is fine, it will work. So now if you run this, click on terminate. Alright, so let's type something. Let's type here 10 inches to see what we get. So let's click on convert and we get 25.4, and is this value that I have here. So now let's actually put 1 inch so let's press Ctrl Z here because so let's type here only 1 inch to see what we get. So I'm gonna delete this, I'm gonna type 1 inch and I'm gonna type convert and we get 2.54, the value that we have here. So what's the value of an inch in centimeters? So our code works fine, but what I don't like is, again I deleted the code, so let's press Ctrl Z. What I don't like is that when this keyboard is opened, you have here text. So if I type here this thing, look what happens, it crashes our app. So we need to make sure that only numbers are going to be shown in the keyboard, and to do that we go inside activity.main, we hide the emulator, we go inside the code. We can do this from the design, but I'm going to go inside the code, and here we have an attribute called input type, and here we can pass numbers. So when the keyboard is going to be shown, that input is only going to be numbers. So I'm going to type number. So now if you run our code, so now when I click on the edit text, now we only have numbers, we don't have the characters, and this is better. This is better because now we don't run in that error where you pass strings with instead of numbers. So click on convert, and let's make this text view a little bit bigger. I'm gonna go also inside the code. So where is the text view? The text view is here. So let's type here text size, and here we're gonna type let's say 20 sp. So if you run this again or you apply the changes, now if you click on convert, now I have the text a little bit bigger, and we can increase this if you want. Now I'm gonna end the video and see you in the next video. Now it's time to create another app, and this app is gonna be called change color, and it's gonna have a button which when clicked is gonna change the background of the view. So let's first open Android Studio. Let's create a new project. Let's select empty activity here, click on next. Let's call it change color, and let's click on finish. Now our project is going to be created. Alright, so now let's set up the XML file. So I'm going to go inside the code because I'm going to add here a button. So I'm going to delete this text view, and I will add what's called a floating action button. So I'm going to select this one. So we put opening tag, and for the width I'm going to type 200 dp, and for the height also 200 dp. Let's close the tag. Let's also give a background color. So let's type background tint. So let's type color, run color / purple, and now we have this in red because it's not constrained. So let's constrain it from design. So this is our button. Let's put it in the middle. So let's constrain this vertically first. Then horizontally. So now our button will stay in the middle, and with floating action button, we cannot put text on it. So you cannot put a text like click me or anything here. But I'm gonna keep it as it is because you don't need to put any text. Now, what we want to achieve is to, when we click on this button, to change this background. And if you click on this background, so if I click now, you can see that this is selected. You see this by the color that we have here, and the constraint layout is selected. So what we need to do is to go inside the code and give an ID to the constraint layout, because the constraint layout is also a view, is an UI component. So remember that discussion that we had about the view and the hierarchy and the inheritance. So all the views are gonna have the functions that the view parent class is gonna have. So here you can put an ID and you can reference this constraint layout later. So let's call it view. I'm gonna call it simply view. And now we can call this later and can change its color. So now I'm gonna go inside the main activity. I'm gonna type private later it, and it's gonna be a view, so it's gonna be of type view. And now we need to import that. Another private later it var, and now we're gonna we are going to create a button. So type here button of type button. Now let's connect those objects with the UI components. So I'm gonna go here and I will type view equals find view by ID r.id.view. So the constraint layout that we had there. Then I'm gonna type button equals find view by ID r.id. Actually, we need to give an ID to the button. So let's give an ID to the button. So I'm gonna type here ID. And let's call it button change. So let's type here button but we have this underline, so I don't know why. So I don't know why we did have that underline. Maybe it was a compile error, but it simply disappeared. So now it's working. So now let's attach on click listener to our button. So button that's set on click listener. I'm gonna press enter and I'm gonna type here view dot set background color. I'm gonna type here color dot red, let's say. So now if I run this, so for whatever reason it crashed. So let's see, let's go in the run to see. So go here. Alright, so the problem is that we should type here for the type, not a button, but a floating action button. So floating action button. This is why you got that error. So now if you run this again, now it didn't crash. And if I click on this floating action button, now the background color is changed to red. And in the next video, we're gonna see how we can to change this, how when you click on this button, the color is gonna be changed randomly. Now it's time to see how we can change the background color of our app randomly. And for that, we first need to create an array of colors. And now you may be wondering how we can create an array of colors, how we can put colors into an array. And we can do that because colors, when you type color.red, actually that is an integer. So if I go here, let's say, as you can see, this is an integer. So we can use those integers to because for the color black we have this integer, for the color blue we have this integer, and we can use those integers to put them into an array. So I can type here private val colors, and I'm gonna put equals array of, and I'm gonna type here color dot red color dot white color dot gray color dot green color dot magenta color dot black color dot, let's see where is the yellow color, so color dot yellow, and this is enough. Now how we can change this background color randomly? We first need a way to get the color, so to get the color from here, to get it randomly, but you need to get it from the array first. So what we need to do is we type here colors, we put square brackets, we put square brackets, and here I'm gonna type random, because we're gonna use this class called random to generate random numbers, and you can specify a range for the random number. So to generate, let's say, a random number between 0 and 10, or between, in our case, the color red and the color yellow, and for that, as I said, there is the corresponding numbers. So I'm going to type random dot, so we put dot here, dot next int, and inside the next int to specify the range. So from what number to what number we're gonna generate numbers. So we're gonna type here colors dot size. So this will generate a random number. This line of code will generate a random number between the first index that we have here to the last index, and then we're gonna get that color using the colors array. Inside we get that color back, and then we put that color to our view background. So now if you run this code, click on terminate. Now if you click on the button and you click again, now the color, as you can see, are changed randomly, and this is very nice. So this is a simple app, but it's very beautiful. You can show it to your friends. So it generates a random color using one simple line of code that we have here. So this line of code. So now I'm gonna end the video and see you in the next video. Now it's time to continue our discussion about Android, and in this video we're gonna look at another widget called radio button. So let's create a new project, select empty activity, click on next, and let's call it radio buttons. And click on finish to create the project. Right now our project is created. Let's go inside activity.main, egg.xml. Let's wait a little bit, and let's delete this text view because we don't need this text view. And let's go back to design. Now here where is the palette, I'm gonna search, and I'm gonna search radio buttons, and we have here radio group and radio button. Now what is a radio button? A radio button is a button which allows you to turn it off or on, and radio buttons are usually used in radio groups because you want to have the user to select only one option, only one button. So this is what a radio button is. So let's first create the radio group. So I'm gonna drag this. So I'm gonna put inside the constraint layout. So I'm gonna put it here. So we have our radio group, but it's up here. Let's move it here. Let's constrain it. Let's move it a little bit. Now let's add the radio buttons inside now our radio group. So I'm gonna type here radio, and I'm gonna put it inside here the radio group. We have the radio button here. Let's put another radio button. And let's put another one. Alright, so we have beautifully here our 3 radio buttons, and let's change their text. So go on the right hand side, we select one radio button, and let's change the attributes. Let's call this, let's give it an ID, let's call it, let's give the ID yes button. Click on refactor, and let's change the text. So the text now is radio button, but you should create string resources for the text. So I'm gonna go inside the values, strings, and I'm gonna add some strings here. So I'm gonna put string radio button text, and it's gonna say yes. I'm gonna press Ctrl D to add the line of code again and again. And let's change this to radio button text 1, 2, and 3. So these are their IDs. Now if you go here, instead of saying radio button, we're going to say radio button text 1. And go to this one, we also make sure to change the ID. So the ID is radio button 2. Let's call it no button. Let's change the text. So I'm gonna reference our, so click on refactor to change the ID. So let's change the text. So I'm gonna type here string radio button text 2. We're gonna say yes. We should say not yes, but no. So let's put here no, no, and maybe. Alright, so let's now also change the attributes of the third radio button. Let's change the text first here. So I'm gonna type here string radio button text 3, and let's also change the ID. So it's gonna be maybe button. I'm gonna press enter, click on refactor. Now let's also add the text view above, which is gonna have the text of a question, but let's add the string first here. So we put string text view question, question, and it's gonna say, do you like programming? Alright, now let's add a text view. So I'm gonna take this text view, I'm gonna put the above here, I'm gonna put it in the center, I'm gonna constrain it, let's change the text of the text view. So now it has the ID text view text. Let's call it text view text question. Let's press enter to refactor, and let's change the text to something else, to our string that we added in our string XML. So type string, so we have text view question. Let's also change the size of the text. So size, we have 14 SP, let's change it to, let's say 20 SP. Let's push it down a little bit. Alright, so now we have our UI ready. The next thing that we need to do is to connect this UI with the code. But first let's run this to see how it looks. Right, so our app opened, we have our text view, and we have the radio buttons. And as you can see, you can only select one. And the next video, we're gonna add the code. So see you in the next video. Right, so now it's time to connect our UI components, our widgets with the code. But first, let's go inside activity main.xml. Let's go inside the code, and let's give an ID to actually the radio group already has an ID. And as you can see, all the radio buttons are inside this radio group. So this is good to have in mind. So let's go back in main activity. I'm gonna type here private latent it radio group. It's gonna be a radio group, and we're gonna create also a radio button, private latent it var radio button of type radio button. All right, now here we're going to type radio group, not radio button, going to be equals to find view by ID, and going to refer the ID of the radio group, r.id.radio group. Now what we need to do next is to add an event listener, so to listen to the clicks on the radio buttons which are inside the radio group. And to do that, we need to use attach the event listener on the radio group, because even when you click on a button, is also that button is going to be inside the radio group. So we type here radio group does set, but now we're not using set on click listener, but set on check listener. So we use set on check listener, not set on click listener. This is how you listen to clicks on the radio group and on the radio buttons. And we choose this one. We let the name group and I. This should be ID. Right, and we press enter. Now what we need to do next is to connect the radio. So we type here radio button equals find view by ID, But now I'm not gonna pass a specific ID here, so I'm not gonna pass r.id.yes button, because this will always have the ID of the yes button. What we need to do, because now we are inside the set on check listener, we need to type here find view by ID, and when this when you're gonna click on a button, this listener is gonna be called, and is gonna dynamically send you the ID here, the ID of the button which was clicked. So when we put here find view by ID, we're gonna put that ID which is for the button which was clicked. So I'm gonna put ID. So now it's okay. Now, as I said, this will change. When you click on the yes button, it will pass here the ID of the yes button. When you click on the no button, it will pass the ID of the no button. When you click on the maybe button, it will pass the ID of the maybe button. And we need to individually respond to clicks on the buttons. And to do that, we type here when, so the when statement expression, and we put here radio button dot ID, and we put curly braces, and now we type here r.id.s button, gonna put and curly braces, gonna put also now r.id.no button. So if the button click is the no button, gonna do something. And if the button click is the maybe button, we'll put here r.id.maybe button. Gonna put this arrow, curly braces, and the code that is gonna be here. So now what we are doing here is we're saying, hey, if the radio button which was clicked is the yes button, then do something. If the radio button that was clicked is the no button, then do something. And now I'll introduce something called a toast, because I want to show a message when we click the buttons to see how the code works. And the toast is a class with which you can display text on your app. And to display text on your app, you just type here toast. So I have a suggestion, toast. We put dot, and here you type make text. And as you can see, we have a few parameters here: context, resource ID, and we have this one. We're going to use this one, context, text, and now you may be wondering, what is this context? The context refers to where you are currently with the code. So where you are currently displaying where you are currently displaying the text. And currently you want to display the text inside the main activity, because as you'll see, we can have many activities, and this is a way of saying to the toast, hey, display the text here by choosing this context. We say display the text in the main activity, and to do that we type here this, so this context at main activity. We have a suggestion, then we put a comma, and then we put the text that we want to have displayed. So I'm gonna say yes button, let's type button clicked. So this is what the context is. And also need to show this text, and to show the text, to put here dot show. Actually, I forgot. Also need to provide the length here. So how much time is gonna stay on the screen this text, for a short time or a long time. I'm gonna choose a short time. Short, and now we put dot to show the text on the app. So I'm gonna put show. Now I'm gonna copy this line of code. I'm gonna put it here. I'm gonna put it here also, and I'm gonna just change the text here to no, and here to maybe. So now when you're gonna click on a button, this code is gonna be called. If you click on the yes button, the code inside this is gonna be called, this toast is going to display a text inside the main activity, so inside the screen that we have. And so let's run our app to see how it works. Click on terminate. Alright, so now if I click on the yes button, we get yes button click. So we get our message shown by the class toast that make text. If I click on the no button, we get no button click. If I click on the maybe button, we get maybe button click. So this is beautiful, and I'm gonna end the video now and see you in the next video. Now it's time to look at another widget that we can use in Android, and that is a seek bar. And a seek bar allows us to use our finger to drag left or right and to set the progress. And let's see how we can use a seek bar. So I'm gonna go inside the activity.main, the XML. And I'm gonna go inside the code. I'm gonna delete this text view because I don't need this text view. Go to design back, and here in the palette I'm gonna type seek, and we have a seek bar, and we'll drag it here in the middle, the seek bar. Alright, let's constrain it horizontally and vertically. Alright, let's give it an ID. Let's call it seek bar. Press enter. Let's go to code, and let's set why you have this ID here. Let's delete this. Let's set the maximum progress to 10. So I'm gonna type here max 10. So that is the maximum progress. Another thing that I don't like is the fact that it's very small, as you can see here. So let's increase the width. So I'm gonna go to code, and instead of here it says layout width, instead of wrap content, I'm gonna put match parent. So we put match parent. So it will match the size of the parent. So it's gonna be as big as the parent, the width. As you can see now, it's bigger. So if you go to main activity, or let's run it from here. If you run this, so our app opened, and we have here our seek bar, so we can drag it here, as you can see. Now let's add the text view here, which is going to show the current progress. So I'm going to go on activity.main. Let's hide the emulator. Let's take this text view and let's put it here below. Let's constrain it. Let's move it up. Let's change the text size. So text size is 40 SP. Let's change it to 24 SP. Alright, now actually let's change this text view to something else. So let's change the text to something else. So let's go here, let's delete this, Let's go down. So we have the text view. Let's change this text, but let's create a string resource for that. So I'm gonna go here. I'm gonna go into values, strings, and I'm gonna create here a string, which is gonna be text view text, which is gonna say rate. So now I will go down here, and for the text now I'm gonna reference string text view text. Alright, so now everything is okay. Now let's go inside main activity to add the code. So I'm gonna add here a private latent it sigbar, gonna be of type sigbar. Then I'm gonna create a text view, text view progress, let's say. It's gonna be a text view. Now we need to connect our object with our widget. So I'm gonna type here sigbar equals to find view by id r.id dot sigbar. Next I will go down and I will type text view progress equals to find view by id r.id text view. I think this is the ID of the text view. Let's see. Yes, that is the ID of the text view. Text view, let's say progress. So let's change now to progress. Now, so we have this underline again, and I don't know why that happens, but it will disappear after a few moments. Now what we need to do is to add an event listener to the sigbar, so that we can respond to when the user drags the sigbar left or right. We can respond to that dragging. So I'm gonna type here sigbar dot, and we choose not set on click listener, which is this one, set on sigbar change listener. So we select this one. We type here object, and we type here on sigbar change listener. We put curly braces, we press enter, and now we're gonna implement the functions. So I'm gonna click on this, implement members, and we have those three functions. Alright, let's delete those to do's because we don't need those. We still have this underline, and I don't know why, because everything is okay. Let's rebuild our projects to see if it disappears. So it disappeared. So if you see something like that, just rebuild the project. While it's doing that, let's go inside the strings and let's change the string rate to rate and put 0 here. Because this, I want the user to see when it first opens the app, to see that the rate is 0. Alright. Now all of those functions that we have here on progress change, on start tracking, on stop tracking touch are going to be called at different phases, and this one progress change is going to be called always when we move the sigbar. So let's add a toast here. to see this. So you add a toast that make text. Let's say one progress changed. Toss that length that's short, and let's add the show to show this text. So I'm gonna copy this, I'm gonna paste it here, and I'm gonna paste it also here. But now I'm gonna change this text here to on start tracking touch, on start, to see when they are called. Start tracking touch, and here on stop tracking touch. This is gonna be called when you're gonna stop drag again. So I'm gonna type here on stop tracking to. Now if you run this, click on terminate. Now if you drag this, you see you have one start tracking touch, one progress change, so this one is called when you track it for the first time, then one progress change, and then one stop tracking touch is called when you stop tracking. So you do again, on progress change, and on stop tracking touch. So they are called, first is this one when you start dragging, then is this one while you're dragging, and this one when you stop dragging. And let's now update this text to the rate that the user chooses here. So let's see how we can do that. So let's hide the emulator, and to change that, I'm gonna go inside the on progress change, because here you can have access to the current progress. So I'm gonna type here text view text view progress dot text equals sigbar dot progress. But we have a problem. This is an integer, and here we try to assign it to the text view text, so we can't. Let's hover over, and let's convert it to string. So we put that to string. Very easy. Now let's run this. Alright, so now we have our app opened, and now if I drag this, you see that the text is changed. So if I drag this, we have 2, 3, 4, 5, 6, 7, 8, 9. But let's put the text in front of here rate. So let's go here. So let's hide the emulator. And let's go here and let's type here. Let's put quotation marks and let's put rate equals to plus. Here you can use a resource string, but it's okay. So let's run this. Now if you drag this, as you can see, now we have rate equals to 1, rate equals to 4, rate equals to 6, 7, 8. And let's put a text view above to have a question, let's say. So let's put here, let's actually use the design. So I'm going to take a text view, I'm going to put it here. And let's create a string resource. And let's say rate, let's type text view text rate, and it's gonna say rate let's say what is the rating of this course, let's say question mark. Let's go back inside activity.main. Let's click on text and let's change the text view from text to string text view text rate, and let's push it down a little bit. So let's go up and let's push it down. Now let's run this. So now we have what is the rating of this course, but the text is very small, so let's change the size of the text. And I'm gonna go inside the code to do that because it's more rapid. So let's type here text size, let's say 20 sp. Let's run this code again. So now we have what is the rating of this course, and let's say that I go here and let's say rate equals to 8. So as you can see, it's updated while I'm typing, and we also have those toasts here called because we have those inside the functions. So you can also use this function on stop tracking touch to add the text which is going to say final rate when when the user stops dragging. So it will change this text to final rate. You can do that. Let's actually do it to see how. So I'm gonna take this, I'm gonna put it here, and instead of sigbar we call that one p0. It should be called and it's a nullable, so let's put here those. So now if you run the code, but instead of rate it's gonna say final rate. So if you run this, now if you do this and if you stop, get final rate is 7. If I move again, we have rate, and I stop, we have final rate 4. If I move, I stop, final rate 10. So this they are called at the different phases. So this is how you can use a sigbar, and see you in the next video. Now it's time to look at another widget that you can use, and that is a toggle button. But first, let's create a new project. Let's choose an empty activity, click on next. Let's call it toggle button. We press enter. Alright, so now our project is created, and let's go inside activity.main.xml. Now, what is a toggle button? A toggle button is a button which allows you to check between two states, on or off. And let's delete this. So I'm gonna type here toggle. I'm gonna drag this toggle button here. Let's constrain it. Alright, let's also put a text view down here, because I will make the text view disappear or appear depending on what depending if we have checked on or off. So let's put a text view here. Let's change the size of the text view. Let's type size here, 20 sp, and here we can create a string resource for this text. So let's go inside the values. Let's open a tag string text view text, which is gonna say simply I don't know, text view. It's gonna say text view. Alright, let's go back here and now let's reference that string.xml. So we type here string text view text. So now if I go to design, we have our text view here, but let's push it up a little bit. Right. Now if I go inside the main activity, now let's connect those. So I'm gonna type here private latent it var toggle button toggle and private latent it var text view, let's say text view hide of type text view. Now I'm gonna reference those. So I'm gonna type here toggle button equals find view by id r.id dot toggle button and text view hide equals to find view by id r.id text view. Alright, so we have those underlined, so again, but they will disappear. It's not a problem. Now we need to listen to event listener to clicks on this toggle button, and to do that we type here toggle button dot set and on check listener. So you choose this one, toggle button checked on set on check listener, and we choose this one. But let's rebuild our project to don't have those underlines here. So go to build and click to rebuild project. And let's change this to is checked. Alright, so let's go back inside activity main.xml to make this invisible. So let's go to code and let's type here visibility invisible. So if we look now at design, it's gone. So let's go back to main activity. Now we're gonna check to see if it's checked. So if our toggle button is on, so it's checked, then we're gonna make our text view hide dot visibility equals to view dot visible. Else we're gonna say text view hide dot visibility equals view dot invisible. So now if you run this, and we have an underline here, let's rename this to an underline because we don't use that in our code. So we have on, if you press now on, we have text view. If you press again, it disappears. If you press again, it appears. So this is how you can use a toggle button, and this is very nice. So I'm gonna end this video and see you in the next video. Now it's time to look at another widget that you can use in Android, and that is a checkbox. And the checkbox allows only two states, checked or unchecked. So I'm gonna go inside activity main.xml and let's delete the hello world text view. So let's delete this. Let's go back to design and let's add our checkboxes here. So I'm gonna type here in the palette, I'm gonna search check, and we drag this checkbox. We put it here in the middle. We constrain it horizontally and vertically. We'll add another checkbox, so we type here checkbox. We're gonna put it below this one. I'm gonna constrain it. Let's push it up. So like that. Let's add another checkbox. Let's put it below this one. So let's constrain this checkbox also. Let's move it up. Now let's put a text view above, because we're gonna ask a question. So I'm gonna type here, actually we have the text view here, so I'm gonna put this text view here. I'm gonna constrain it. Let's push it down. Let's increase the text size. So I'm gonna go here. I'm gonna increase the text size. Let's put 20 SP. Go back to design, and I'm gonna put another text view, which is gonna display what we check. So what from our checkbox, which one we check. So I'm gonna put a checkbox below here, but let's actually put first a button. So let's put a button. Let's constrain it. Not like that. Let's push this up. And let's now add another text view, which is gonna display the checkbox that was checked. So checkbox, not text view. Text view actually, not checkbox, sorry. So let's take this text view, let's put it below. So this text view is gonna display what choice we've made. So what checkbox which we checked. So let's constrain it. Right, let's move it up a little bit. Now let's move all of this up a little bit, but let's change the text size of the second text view to also 20 SP. So let's type here text size 20 SP. Go to design. Now let's select all of those and let's move them up. So if now we move this up, all of them are gonna be moved up. So move them up. Alright, so now it's okay. Now let's create some strings here. So I'm gonna type here first the string for the text views. I'm gonna type here string text view question. Let's type here what programming language you like. Let's add another text view, another string, and so I'm gonna type string text view option, text view option. And this actually this is gonna be empty. We don't need this. Now let's add the strings for the checkbox, because we're gonna have some text on the right of the checkbox. I'm gonna type string, and I'm gonna type here checkbox. And it's gonna have the text Kotlin. I'm gonna press Ctrl D, and I'm gonna change this to Java and Python. So checkbox Kotlin, checkbox Java, and checkbox Python I'm gonna put here. Now we go inside activity.main.xml and we're gonna add the text for the checkbox, and we can do it from the design from here. So let's do for one of them from here. So let's take the first checkbox and we go down, and we have the text checkbox. I'm gonna delete that. I'm gonna type here string Kotlin. So now the text was changed. And we can do the same thing for the next ones, but I'm gonna do this from code. So I'm gonna go inside the code. I'm gonna go inside the code. I have the checkboxes here, but I can't identify them because so let's actually do it from design. So I'm gonna do it from design. Let's go down again. I'm gonna put here string checkbox Java, then next checkbox, we select that and do type here string checkbox Python. Now let's select this text view. We're gonna put the question. Let's go up. So here I'm gonna type string text view question. So we have what programming language do you like, Kotlin, Java, Python, and we have the button. Let's move the button a little bit down. Now let's add some IDs to our checkbox. So I'm gonna click on the first checkbox. It has the ID checkbox, and let's call it checkbox Kotlin. Click on refactor. We select the second checkbox. We call it checkbox Java. We press enter. We select the third checkbox, and I'm gonna call this checkbox Python. And also gonna give an ID for this. Click on refactor to have the ID added there. So I'm gonna click on this text view, and this text view is gonna display the choice. So I'm gonna call this text view choice. Press enter and refactor. Now, if you go inside the main activity and if you run this, so we have our checkboxes, and we have the button and the text, the question here, so everything looks fine. So we're going to continue our discussion in the next video. Now it's time to create the objects and to connect them with the widgets that we created. So let's first create the checkboxes. So I'm going to type here private latent need var check box, let's say Kotlin. It's going to be of type checkbox. Again, private latent int var checkbox, let's call it Java. Let's type again private latent int var checkbox Python. Also checkbox. And we also need to reference our text view, because here we're gonna show the state of our checkboxes, so what checkboxes are checked or are unchecked. And let's see what ID this text view. Sorry. So let's see what So let's see what ID this text view has. So I'm gonna go inside activity main.xml. Let's hide the emulator. Let's click on text view, and it has the ID text view choice. So I'm gonna type here private latent int var text view choice. Gonna be of type text view. And let's go back inside activity main, because let's change the text of the button to something else. So let's go inside the strings to create a string here. String button is gonna have the ID text, and it's gonna be called show. It's gonna have the text show. Now go back here, and we have the ID button. Let's call it show button. For the ID, press enter, click on refactor, let's click on text view, and let's delete that text to have when we opened up for the first time, to don't have this text view as the text. So let's delete this. Alright, so let's go back here. Now let's connect now our objects with the widget. So I'm gonna type here first checkbox Kotlin equals find view by ID r.id dot checkbox Kotlin checkbox Java equals find view by ID r.id dot checkbox Java checkbox Python equals find view by ID r.id checkbox Python. And let's also connect the text view. So I'm gonna type here text view equals find view by ID r.id text view choice. Now let's attach one click listener to our button, but we didn't create the button, so let's create also the button here. Private latent int var show button of type button. Let's see what ID the button has. Let's import that. So let's see what ID this button has. And let's change the text to show. And let's see what ID it has. So it has the ID show button. So I'm gonna type here show button find view by ID r.id dot show button. Now let's attach an event listener to our show button. So let's type here show button dot set on click listener. So we're gonna listen to clicks on the show button. I'm gonna press enter. Let's rebuild again the project because we have that underline. Now it disappeared. Right, now everything is fine. Next, what we need to do is to create a string builder, because I'm gonna concatenate some string. So I'm gonna append some string, and to do that I'm gonna type here val sb for string builder equals string builder And here I'm gonna type sb dot append. So I'm gonna append some text, append, and here I'm gonna type checkbox. I'm gonna choose the first one, Kotlin dot text. So I'm gonna get the text, the name of the checkbox, dot to string. Let's put a plus, status is, and let's push it to the next line, and let's type here checkbox. So let's put a plus there, a plus here. So let's go here and to type checkbox Kotlin dot is checked. So this is gonna return if the checkbox is checked or is not checked. So what we're doing here, we're appending this entire string, and we're gonna append it after we append the entire string. We're gonna also have to append the strings for all the checkboxes. So we're gonna add here a \n to move to the next line and to skip the line. So I'm gonna put here \n. Now I'm gonna type again string builder dot append checkbox java dot text dot to string plus status is. So put a plus here, we go here and to type checkbox, and checkbox Java is gonna give us the status is checked or is not checked. And what we're doing here with the string builder is that we are appending, and we first appending this text and we add a new line, and then on the next line we add this text. So this is why we are using this string builder, because we can append in this way text. And let's also put here a backslash n to have a new line. So I'm gonna put \n, and let's type again sb dot append. I'm gonna type here checkbox Python. I think that is dot text dot to string plus status is. I'm gonna put plus here again, checkbox Python that is checked, and also plus and a \n to add the new line to add a new line. So now we need to set this text to our text view choice. So to do that, we're gonna go down here, we type text view choice dot text, and we're gonna type here sb dot to string, and that is gonna append the entire text to our text view choice. So now if you run this, let's put a colon here, colon here. Let's run it again, because I added the colons and I want to have that. Alright, now if I go here and I check Kotlin and I click on the show button, we get Kotlin status is true. So this is executed the code that is here. If I check Java and I click on show, we get Kotlin status is true, Java status is true. If I check Python, we get Kotlin status is true, Java status is true, Python status is true. And if I uncheck all and I click on show, we get that all have the state false. Or if you click on Java, you have Java true. So this is what you can do with checkboxes. Checkboxes can have a state which can be checked or unchecked, and this will be very useful when building apps. So I'm gonna end the video now and see you in the next video. Now it's time to see what is an activity. Therefore, let's create a new project. Let's select empty activity and let's call it activity. And let's click on finish. Alright, now our project is created. Now, what is an activity? An activity, as you saw in the previous videos, is simply just a window, a screen with which the user can interact. And the activity has two parts: the front end part, so what the user sees, where you have all the widgets and so on, and the backend part, and this is where it's all the logic which we the developers can see, and those two interact with each other, and this creates the actual app. The actual app is the interaction of the back end of the code with the front end, with the UI components. Now, as you can see here, we are extending from app compact activity. And why we're doing that? We're doing that because actually this activity, app compact activity, is doing all the hard work of creating the activity, because the app compact activity has a lot of many functions which are responsible for drawing the screen, for doing the logic to make the activity to work, and all of that logic is inside the app compact activity, and we just inherit from that activity and we change it a little bit. In our case, we override, as you can see here, the onCreate function, and when you override the onCreate function, we set the content to with the layout, with our own layout that is defined here. So we set the layout layout activity.main, and if you hold Control and press click on this, as you can see, this is app compact activity. But if you go here and if you press Control O, as you can see, all of those functions are inside the activity, the app compact activity, and all of those functions are doing the hard work of creating an activity. We just inherit from the activity, and we provide an implementation for some particular functions. Like in our case, we override the onCreate. So when the onCreate function is called, we pass our own logic, which is to draw this on the screen the activity main.xml that we created. Next, we have this thing called save instance state when you have a bundle, and what this bundle is doing is holding all the properties, all the functions of this activity, of the main activity, and is doing that because activities in special circumstances can restore themselves to the previous stage. So this is why we have this here, the save instance and bundle. So this is what an activity is. It's just a screen, and has two parts: the front end, the back end. Those two interact, and this creates the app. And we are inheriting from an activity because we don't need to create an activity from zero. So to create all the functions, that will take I don't know, maybe months to do all of that. We just inherit all of that, and we provide some new functionality to the already functionality that the activity that the Android provides has. So this is what an activity is, and see you in the next video. Now it's time to start a discussion about activity lifecycle. So what is activity lifecycle? Activity lifecycle is the phases, the steps through which our app is going when you launch your app. And those steps or phases are represented by some functions which are called by the system. So those functions are called by the system. We don't call those functions. Actually, as you'll see, we can override those functions in our own activity. Now, when you launch your app for the first time, the onCreate function is called. And in the onCreate function, we set up our UI components. We connect the objects with the UI components, with the find view by ID, and so on. Next, the onStart function is called, and after the onStart function is called, the onResume function is called, and at that point the activity is running. So at this point we have the activity, if you want the app running. So you have the activity running. But now if you leave the app, so if you close the app, the onPause is called, the onStop is called, and the onDestroy is called, and the activity is shut down and the app is closed. Now here, depending on how you close the app, you'll determine if the onDestroy is called or not, because if you leave the app only by the back button, so we don't remove it from the app list, only the onStop is going to be called and the activity is not going to be destroyed. And at this point, if you open the app again, so you didn't remove the app from the app list, it will go back on the onStart. So this is the activity life cycle. Now let's open Android Studio. Now let's override the functions that I talked about. So let's override first the onStart, then the onResume, the onPause, onStop, and the onDestroy. So now we have overridden those functions inside our main activity, and let's add the toast to see that actually our app is going through all of those phases. So let's put here toast that make text. I'm gonna specify the context, this that main activity, and the text, let's say on start called toast dot length short and dot show. And let's copy that. Let's put it here, here, and here. Now let's change the text. Let's put here on resume, on pause, on stop, and on destroy. Now let's run our app. Also, we have an error here. We don't have the parentheses here, so we have an error there. Let's run this again. Click on terminate. So we have onStart called, onResume called, and now its activity is running. Let's also add a toast inside the onCreate to see that the onCreate is also called. So let's rerun this. So onCreate is called, onStart is called, onResume is called, and now our activity is running. Now, as I showed you in the picture, now if I leave the app only by this, let's say by this button, and I don't remove the app from the app list, we get onPause called, onStop called, but the onDestroy is not called. And now if I reopen that app here, now the onStart is called, and the onResume is called again. And if I leave it by this back button, get onPause called, onStop called, and onDestroy is called. So now it completely destroyed our app. if I open this, now on create is called again, on start is called, on resume is called, and so on. So this is the activity life cycle. So these are the life cycles through which our activity is going. And I might be wondering, and what about this? What is this useful? This is useful because you can add code at different phases. Let's say that first you want for whatever reason to open a file, and you can do that in the onStart function. So you can do that before the onResume or the one pause is called, and you can open the file or can open a database. And let's say that you want to save I don't know, maybe some values, some properties, or maybe you want to close a database. You can do that before destroying the app. You can save all of that data, and then you can let the app to be destroyed. So you override the function, you save whatever you want to save, and then you let the onDestroy function to destroy your activity. So you save the state. So this is the power of using those functions, because you can use them and can add code in them at specific scenarios. So now I'm gonna end the video and see you in the next video. Now it's time to create more than one activity, because so far in our videos we only worked with one activity with one screen, but in a real app you probably or definitely you will have more than one screen. And I'm gonna also show you how to open a new activity, so how to navigate from one activity to another activity. And first I'm gonna go to resources to create some strings. So I'm gonna go here, I'm gonna create here, I'm gonna type string. Let's call activity _1. Let's type here activity 1. Let's create another string, activity 2, and it's gonna have the text activity 2. Let's create a text, because we're gonna create a button we're gonna use a button to navigate to the activity. So I'm gonna type here button go to second activity, and it's gonna say go to next, or go to. Now let's go inside activity main.xml. Let's go to code, and I'm gonna keep this text view, but I'm gonna change the text to activity. So I'm gonna put here string activity 1, and I'm gonna make the text size bigger, so I'm gonna put here 20 sp. I'm gonna go to design, and I'm gonna put a button here. So we say activity 1, let's say it should be activity 1 and activity 2. Alright, so I'm gonna put a button, I'm gonna drag it here. Let's constrain it. Let's push it up a little bit. Let's add an ID, and I'm gonna go inside the code, ID button go to activity. We're gonna change the text to string button go to second activity. Now if I go to design, we have go to, and let's make the letters not be uppercase, so let's type here all caps, and let's set false. So now if I look here, I have go to, and we have activity 1. Now how to navigate to the next activity? First we need to create the activity, so we click on this package called com.example.activities. So we right click on it, we go to new, and you go down here where it says activity, And here we have a few options, and we select this one, empty activity. So new activity and empty activity. We need to give a name to this activity. It's called main activity 2. Let's call it second activity. Let's delete the 2 and let's click on finish. And now we're going to create another activity. And now change has been meant to. Let's keep memory changes. Okay, so now we have our second activity opened here. As you can see, we have it here and it's opened. Now let's go back inside main activity. Let's create our button, private, go, private latent it, go to button. It's gonna be of type button. I'm gonna type here go to button equals find view by ID r.id dot go to activity. I'm gonna set on click listener. So go to, let's put it here, go to button dot set on click listener, and we press enter. Now let's let's go inside the, so I did this inside the main activity. So let's go inside the second activity and let's go inside the second activity.xml. So we have activity, this is the second, or you can go here where we have layouts and we have activity second, activity main. So let's go inside activity second and let's put a text view here in the middle. So we put a text view, we constrain it, and we need to give, let's create another string here. Actually we have a string here, activity 2. So we go in activity second and let's change the text of that text view. So from text view to activity 2. So string activity 2, let's increase the text size to 20 ESP. Now if I go to design, so now we are in the layout of the second activity. So we're setting the layout of the second activity now here. Now let's go back inside the main activity and let's see how we can go to the next activity. To go to the next activity, we need to use a class called intent. So I'm gonna type here val intent. I'm gonna put equals intent, and the intent takes two things. First is the context on which you are currently in, the activity in which you are currently in, and the activity that you want to go. So we type here this, I run this at main activity, and now the activity where I want to go. So second activity, and we use this syntax, colon java class.java. So this is how you basically what we're saying here. Hey, go from the main activity where I'm currently in to the second activity. Now we need to call a function now which is gonna actually move us to the next activity, and then that function is called start activity. So we type here start activity, and as you can see, it takes as input an intent. So I'm gonna put intent, the intent that we create above, and now when I run this, right, so we have our activity 1. Now if I click on go to, now it's opening the second activity. So now we are in a different screen on the second activity that we created. As you can see here, say activity 2. If I press on the back button, it will take me back in the activity 1. And let me show you another way to start the activity using the scope function also. So let's delete this, and what we can do, I can put here also start activity it. So we are referencing the context object, which is the intent. So now if you run this, if I click on go to, we go to the second activity, and if I click on this back button, it will take me back in the first activity. So this is how you can create other activities, and this is how you can navigate through activities. So I'm gonna end the video now and see you in the next video. Now it's time to see how we can send data from one activity to another activity. And we're gonna use an intent, because besides starting an activity with an intent, you can also add data which can be sent to another activity with the intent. And to do the data, I'm gonna go down here, I'm gonna type intent, I'm gonna put dot, and we're gonna use this function called put extra. And this function put extra takes two arguments. The first is the key, so the key of the value that we're gonna pass, and then then we have the value, so the data that we want to have sent it. And now you may be wondering why you have this key like in the hash maps or the maps. This is because you're gonna use the key in the second activity to get the data. This is why. So it's recommended to create these keys as constant, so you don't have if you don't type correctly the key, you'll not get the data. So I'm gonna create a new Kotlin file. So new, where is Kotlin file? Kotlin class file, select file, and I'm gonna call it constants, or let's call it utils for utils. Press enter, and here I'm gonna type class constants, and I'm gonna create a companion object so that I can call this without creating an instance. And I'm gonna type here constant val, and constant val is gonna create a constant which you cannot change the value. So and usually the name of the constants are uppercase. So I'm gonna put here intent key, intent message underscore key, and this is the way of declaring a constant with uppercase letters. And if it has multiple words, you put underscores. And I put equals, I'm gonna type here message, and this way you can call this anywhere in our code, and you don't need to worry about typing this correctly, because it can happen to have to type that wrongly. So I'm gonna put here put extra, I'm gonna type here constants. As you can see, we have this con.example activity, so that one, that, and we have our constant value, intent message key. We put a comma and the message, and the message is gonna be hello from first activity. And let's add another intent to put something else, and let's create another constant here. So let's put constant val intent message to underscore key, and this is gonna have the key message too. I'm gonna go back inside the main activity. We need to close this, and I'm gonna go down here. We type intent dot put extra, again constants dot constant message key 2, and we're gonna say how was your day. And we're gonna put also another type of value, not only strings, to put some numbers. So let's create another constant val intent, let's say data, this is not the base name, but not data number equals to, let's say, number. I'm gonna go here, I'm gonna type again intent dot put extra, again constants dot, and we use this one, and I'm gonna pass a number here, let's say 3.14 is the value. Now what we need to do next is just to start the activity and to pass the intent. So I'm gonna copy this, I'm gonna paste it here, and now this data is gonna be sent to the next activity. And then the next activity we need to capture the data. So we go on the second activity, and inside the onCreate function we type val. We're gonna call this data equals, I'm gonna put get intent, so we get the intent which comes when you open the second activity. Actually you can use intent dot extras, so we're gonna get the extras that are passed here. So as you can see, we have put extra, and here we're gonna get the extras. So I'm gonna go down here, and first we need to check if the data is not empty. So I'm gonna type here if data that is empty, and if it's not empty, but we have a problem here. Actually we need to, let's use the Elvis operator. So let's put data Elvis operator dot let, and let's press enter, and here now we're gonna get the data. So I'm gonna type here val message gonna be equal to data dot get string and the key, and here we're gonna pass the key from constants dot intent message key. I'm gonna press Ctrl D to have this again, message 2, and it's gonna have the other key here. So intent message 2 key. I'm gonna press Ctrl D, and now I'm gonna get the number here. So I type here number. So what we're doing with this data, this Elvis operator, is saying, hey, if the data is not null, then execute this code. This is what we're doing here. And as you can see, it's saying that you can replace data with it. So we can put here instead of data it, but I'm gonna put data immediately. So here we need to change the constant to number, data number. Now I'm gonna use this text view for the second activity to display the data that we get from the first activity. And let's give it an ID. Let's say text view 2. It's not really a good name. Let's call it text view data for the ID. And here we're gonna create a text view private latent it var text view data intent of type text view, and I'm gonna type here text view equals find view by ID r.id text view data, and here we're gonna pass the message and the message 2 and the number. So I'm gonna type here text view data intent is gonna be equal to, and we're gonna type here message, and if you hover over, it says found required text view, or so we need to put text view dot text. Sorry, message. I'm gonna put a plus. I'm gonna put a backslash n to add a new line, and I'm gonna put here plus message plus I can use, let's type message 2. I'm gonna put again a new line plus new line \n and plus, and now we're gonna get a number. So we're gonna type here number, and we have this gray. We have so it's saying to use string resources, but here we're getting the data from there, so we can't use string resources. Now here we have again this underline. This error always appears. I don't know why, because the code is okay, it's fine. Now it disappeared. Now if you run this, look what happens. Alright, so our app opened. Let's go to the next activity, and we get the message, hello from first activity, how was your day? And here we get null, but I don't know why we get null there, so let me see. I didn't pass. Actually, this is because here we're getting a string. What we should get instead is an int, so get int here. So now if you run this again, so now we're getting an integer, not a string. That was the mistake. Now if I press go to, get hello from activity, how was your day? And have that, but I don't know why we have 0, because I passed a different number there. Alright, so now I know where is the problem. The problem is that in main activity we are using the intent to put extra. We are passing a key here, and the value that we pass here is a double. And here in the second activity, first I used the get string, I was wrong. Then I used the get int, I was wrong, because what actually I should use here is get double, because we passed a double in our main activity. So I need to get double here. So if I put here instead of int get double, now if you run this, everything will work fine. Click on terminate. Go to, and you have hello from first activity, how was your day? And then we have 3.14, the number that we passed here. This is why you got that. We didn't got the number here, because I was trying to get an integer. First was a string, then an integer. Actually, what I should did is to get the double, because here in the main activity we're passing a double value for a double type for our value. So this is our discussion about how we can pass data from one activity to another. In the next video, we're going to see how we can pass data from the second activity to the first activity. So to send data back. So see you in the next video. Now it's time to see how we can send data back from the second activity to the main activity. But first I'm going to go inside activity second.xml to add a button here. I'm going to go to design. I'm going to drag a button here below of our activity text. I'm going to constrain it horizontally and vertically. I'm going to push it up a little bit. Let's change the text. So I'm going to go here. I created a string for the text. So we go here, we delete this, and the type string, button go back. Now if I go to design, we see that we have go back, but let's set all caps to false. So let's go to code, and then let's type here all caps to false. So now if you go to design, we have the letters in lowercase. Now let's see what ID this button has, and let's call it button go back. Let's press enter, click on refactor, let's go to second activity, and let's create a button here, private latent it var go back button of type button. Now we need to connect that button with the widget button, so I'm gonna type here go back button equals find view by ID r.id dot button go back to activity. I think that is, no, it's not that. Button go back is, so button go, let's delete this, r.id, this one, button go back. And again we have this underlined, but it's not a problem, that will disappear. I'm gonna set on click listener to button go back, so I'm gonna type here go back button dot set on click listener, press enter. Now what I'll do, I'll create a constant, so I'm gonna go inside the utils, I'm gonna create another constant, and this actually I have the, if you don't have this, just type here constant val request or result code equals, and you define here a number. Then you go back inside the second activity, and here you're gonna type val intent equals to get intent. So we're gonna get the intent that was that enter in our activity. So with the intent which enter in our activity, now we get in that intent. Alright, so here we type set result, and we have the result code and the intent. So we're gonna pass here, and I'm gonna type here constants dot result code and the intent. And then I'm gonna type finish to close this activity. Alright. Now I'm gonna go back inside the main activity, because now here we need to create the code which is gonna respond to the when we are coming back from the second activity to main activity. We need to capture that data somehow, and we also need to start the activity and to make sure that that activity, the intent is gonna come back from the same code activity with some result, and for that we need to use a different function. But first let's add an ID to our text view. Actually we have an ID because we're going to display the data which is coming from the second activity. So I'm going to go inside the main activity, I'm going to type private latent it var text view data, let's call it, it's going to be of type text view. Now here we're going to type text view data equals find view by ID r.id dot text view. Right, and this text view is going to display the data which is coming back from the second activity. Now I'm going to go up here and I will type here val get result, because we're going to get the result back from the second activity. I'm going to put equals, and I'm going to type here register activity for result, and here I'm going to type start activity for result. We put parentheses here and we put a lambda here, so I'm going to put curly braces and press enter. Now here I'm going to type if it dot result code equals to constants dot result code. Then that means that we got back the data which was sent by the intent that was previously entering the second activity, and now that the intent is sending back the data, and by checking if the result code is equal to constant as result code, we're checking to see if the data which is coming back is the data that is from this intent. This is why we're checking there. And if that is true, I'm gonna put curly braces, press enter, and here I'm gonna type val, let's say message equals to it dot get it dot data dot get string extra constants, and let's see what we gave here. Actually, we didn't put here data, so let's type here intent dot put extra. Let's type here we have a constant for that. Let's see, message to constants. So this is the key that message to key, and it's gonna say hello from the second activity. Now let's go back inside the main activity, constants dot message to key. So we're gonna get that data. So now we're getting the data, and this is basically saying that it can be null, so this is why we have this underline here, and we can solve that by typing it. Actually, we know that it's not going to be null, so I'm going to put here 2 exclamation marks to say that it's going to be fine, it's not going to be null. Then I'm going to type text view result dot text equals message. Now we need to start our intent, and we're going to start our intent using this get result that we define here, because we're going to start the intent. Our intent is going to register for our result, and it's going to also check to see if when it's coming back, it's going to check to see if the result code is equal to the result code that we define in the second activity. And if that is true, it will get the data and going to display the data in text view result. So here we need to type get result dot launch, and here now we're passing the intent. So I'm going to pass here intent. So this is how we do it. So now if I run this, alright, so our app opened. Let's click to go to, and we're now in the second activity. Now let's click on go back, and to get the text hello from the second activity. So everything worked fine, so our code is working fine here. So again, what we are doing here is we are first creating a variable get result, and we are storing in the variable get result this thing that is gonna register the activity for result. So it's not gonna simply start the activity, it's gonna start the activity and it's gonna register for a result that is gonna come back. And if the result code that is coming back from that intent is the same code that was defined on the intent which passed the data, this code, then in that case it will assign, it will get the string extra, so it will get the information, and it will assign to our text view text, and we're gonna see hello from the second activity. so everything works fine. So alright, so this is our discussion about how we can send data back from the second activity. So see you in the next video. And if you find this confusing, just you can watch the video again, or you can look at the code and you can think about how all of this works and why this works. But it's not that hard. What we're doing is basically we register the activity for results. So we're not just starting an activity. We starting the activity and we're expecting a result, and then we check to see if the result code is equal to the code which was passed from the second activity when the data was passed. After that, we get data using the key, and we display the data in our text view. And here we use the get result to start the activity, but we're gonna start the activity by registering the activity for results. So it's not gonna be simply start activity and the intent. We have get result dot launch, so it's gonna launch the activity with this register for activity result, which is gonna listen for the data which is coming back. So this is our discussion about how to send back data back from a second activity, and see you in the next video.